Hello, welcome to Container Day. Hi, Jesse.
Good morning, Justin. How you doing?
I'm doing just fine. We are coming to you live today. I am in beautiful downtown LA at KubeCon. And Jesse, where are you at?
I'm in beautiful Mid-Coast, Maine. I'm your virtual co-host.
It's going to be an amazing day. And I realized last night, actually, I'm in LA, you're in Maine. Bob's going to join us here pretty soon in Seattle. And later on, we're going to have Jay down in Florida. And that's like all corners of the United States. And that's just pretty cool.
We're basically, this is KubeCon NA. So we got one of the countries sorted. We just got to get some folks in Canada. We got to get some folks in Mexico going on. Yeah, welcome everybody. We have a full agenda for you today. This is our Day Zero co-located event at KubeCon NA 2021. For those of you in LA, welcome to LA. For those of you joining us remotely, virtually, from wherever around the globe, welcome. We have an awesome agenda. We're going to talk about all things Kubernetes on AWS. We're going to talk about some EKS roadmap updates, some features. We're going to talk about a ton of open source projects that we have going. But we're going to kick it off here in a little bit. Justin.
Rambo 3349, I think, nailed it right here. We're just gonna apply some YAML and get the schedule kicked off because this is gonna be a fun day. So if anyone sound off in the comments where you're coming from, we would love to hear questions as we're going throughout the day. Different sessions have multiple opportunities to ask questions, get answers directly from people working at AWS on open source projects. There's a lot of cool stuff just planned today, so I'm looking forward to it.
Awesome. And before we get to our first session, just want to remind everybody, since this is a co-located event at KubeCon, we are following the KubeCon Code of Conduct, which everybody can reference on the KubeCon website. Basically, this boils down to just being awesome to each other and being respectful of your co-viewers. So with that, should we kick things off?
Yeah, it sounds good. Let's bring in Bob. And I'm loving seeing the comments of people all over the world. So this is great.
That's awesome.
Hey, Bob.
Hi there, Jesse. Justin. Good.
Hey, Bob.
Good morning from my corner of the U.S.
So we are happy to have you. So Bob Wise, for those folks who don't know, is the general manager of Kubernetes at AWS, and he is here to kick things off with his typical first session keynote.
Excellent. Let's kick it.
Yeah, let's pull in your slide deck. And Jesse and I are going to drop for here for a second. And Bob, you can take it away.
Great. Well, hello there. I'm Bob Wise, Kubernetes GM at AWS. Our team helps customers with Kubernetes, whether that's a managed service like EKS, running Kubernetes on AWS on your own, using Kubernetes with open source projects that we work on, like EKS Anywhere, EKS Distro, or CDKs. If you're having trouble with your schedule YAML, CDKs might be a good way to go, just saying. So welcome to our 6th Container Day. Wow, 6. We're 100% live, mostly virtual from all corners of the US, and we're hosted by Containers from the Couch. Thanks, guys. Some of us are streaming from our home offices. We have folks streaming from KubeCon. We do have a booth, but it's casual this year. We have a few people there for Ask the Experts, and you're welcome to come hang out. Moderators are also here to answer as many questions as possible live, and follow up with us after the event. Join the Slack channel. Thanks for joining us. Jam-packed day and 3 acts here. Stick around for the session right after this for our focus on security, the roadmap session, talk about EKS Anywhere and Connector, a lot of project updates in the afternoon, and a delicious slice of ACK, CDKs, and hybrid right in the middle. Let's start with reviewing our team mission. Our mission is to bring you the Kubernetes you want while delivering better efficiency with less toil. We strive to deliver customers the best possible Kubernetes experience with security, operations, scaling expertise. We have customers with production workloads in a variety of industries, startups to massive enterprise workloads. We also work to be sure that other AWS services have fantastic integration with Kubernetes. Special call out for the ACK session in the second act. That's one of the ways we do that. We both create and engage with open source projects, and open source is one of our favorite ways to collaborate with our customers. We have stayed very busy since the last Container Day. This is just a teaser. Alan and Mike are going to cover this in detail during the roadmap session, so please stick around for that talk. We also have some related launches to talk about since we last met. First up, Amazon Managed Service for Prometheus is a fully managed Prometheus monitoring service. Prior to this launch, a managed Prometheus service was one of the most highly requested new services from EKS customers, just constantly folks asking about it. So I'm very happy to be talking about this as a GA service. With the AWS Managed Service for Prometheus, you can run Prometheus, including PromQL at scale, easily, securely, use it to monitor containers on AWS and on premises, reduce your operational costs, maximize the impact of using AWS observability services. It also includes an API. It makes it easy for you to adjust and query metrics from self-managed Kubernetes clusters running on AWS. And what's little Prometheus without some Grafana to go with it? So we also have Amazon Managed Grafana as a fully managed service for making it easy to build visualizations for developers, operators, business leaders, for application monitoring, wherever your data is stored. With Amazon Managed Service for Grafana, you can easily and securely run Grafana at scale. So it's based on the open source Grafana project, extends the power of Grafana further by managing provisioning, setup, scaling, maintenance, all that toil. It natively integrates with AWS data services and data sources, and provides plugins for on-premises and third-party cloud services. No upfront investment, pay only a monthly active user fee. We also launched the AWS distro for OpenTelemetry as a open source distro of OpenTelemetry. All of the enhancements that AWS will be adding to OT are going to be done upstream. We will not fork the project, just as we don't fork Kubernetes. Toolkit is packaged and ready for production use, well tested, validated for performance. To send your observability data to EKS from these managed services, as well as any other observability partner you may be using. We're investing in OpenTelemetry, and in the future will be available as an EKS add-on. I'm sure Mike and Alan are going to cover this later, but just a reminder, the EKS roadmap is on GitHub in public, as are the other container services within the AWS portfolio. You can see what people are saying, upvote and comment on things. Our product management team is deeply engaged in this. Submit your own ideas if you think there's something missing. If you go there, this is what you'll see. And I just created a view here with EKS related issues, tagged as EKS and filtered for this view. but you can do the same for other container services like Fargate, ECR, ECS, and so forth. We love talking about our customers, our partners, and our heroes. Let's first give a shout out to our heroes. I'm sure many of these are familiar faces. Hopefully you'll get to see a few of them around KubeCon this year. Here's a few of our customers across some of the industry segments we serve. Thanks to all these customers for constantly giving us feedback, helping us build EKS to be what it is that you need. But I'd like to talk about one great example of an EKS customer. New Relic started its migration to AWS to take advantage of a number of fully managed services, including Amazon EKS and Amazon Managed Streaming for Apache Kafka, MSK, and has become one of the largest consumers of these services. While New Relic's migration to Amazon EKS from self-managed is still ongoing, the company is already running many EKS clusters with over 19,000 total nodes and 150,000 pods, with plans to triple these numbers over the next year. We are together excited about New Relic's Pixie Labs, and the EKS team is planning to add Managed Pixie to our add-ons portfolio next year. We also love the dog food. We use and support EKS on our own services. The Amazon.com front page uses EKS, as does Amazon Kinesis data streams. Amazon EMR can target EKS clusters as an option. And Amazon Managed Service for Prometheus and Managed Service for Grafana are built on EKS. So I was doubly excited to talk about those launches. We have a wide portfolio of container partners. Let me call out a few. Weaveworks empowers enterprises to unlock cloud-native agility with GitOps. The Weave Kubernetes platform enables teams to design and operate Kubernetes platforms at scale. Datadog provides visibility into the health of containers and VMs across a lot of environments, on premises, hybrid, cloud compute infrastructure. Sysdig empowers organizations to secure containers, Kubernetes, and cloud services. Sysdig is a SaaS platform built on an open source project called Falco. Portworx provides the data services that allow Jenkins, the open source automation server, to deploy at scale with EKS on AWS or Outposts. And soon Portworx backup will be launching on AWS Marketplace. Aqua Security is a long-standing partner that has worked with AWS customers to secure their cloud-native architectures and containerized applications. Well, thanks to those partners. A special note here of partners that joined us for the recent EKS Anywhere launch, which launched with 35 partners, and we're continuing to add partners as we go. We have a broad, rich container ecosystem to help augment AWS capabilities and provide lots of choices for operational software. Open source projects and AWS partner products help container users take advantage of AWS services and features. Working with our partners, AWS can help you successfully deploy container services for your applications. AWS is there to support you in all your container needs. We worked closely with Red Hat to launch Red Hat OpenShift service on AWS earlier this year. We call this service ROSA. ROSA is a managed OpenShift service jointly operated and supported by AWS and Red Hat. ROSA has a console listing, pay-as-you-go billing on a single invoice through AWS, and the option to contact AWS for support. If you're already running OpenShift on-prem or elsewhere, ROSA is the easiest way to run those workloads on AWS. So of course, anyone using Kubernetes on AWS is going to be using a wide array of other AWS services, and AWS has the broadest set of these services. Technologies, tools to build applications on containers, integrations with open source, AWS partner technologies. Many of our project contributions help any customer running Kubernetes on AWS, whether that's through EKS or another platform. There's no one right way to build EKS, and indeed our larger customers build in multiple ways. We have the most choice in data plane options, including Fargate, EC2, that includes ARM, AMD, Intel instances, special purpose hardware, GPU instances. For example, we offer integrations with EBS, EFS, and FSX for stateful applications that need storage. You can use native AWS security and authentication services to ensure your clusters are configured securely. EKS will automatically provision AWS networking services to provision load balancers, configure your VPCs, and set up Route 53. In addition, EKS integrates with both AWS native and third-party tools to provide multiple options for observability, including Container Insights, Prometheus, Grafana, to name a few. And while there's no one right way to run Kubernetes, we believe using GitOps to manage Kubernetes clusters is the best practice. And you might have noticed that Flux is part of the EKS Anywhere offering and will be coming to EKS as an add-on as well. We believe Flux is a foundational component for running GitOps in Kubernetes. This is also why we're investing in projects like ACK to provide a declarative Kubernetes-style API for managing AWS resources. So what is ACK again? Customers who deploy applications are looking to provision supporting AWS services, databases, message queues, object stores. And while AWS provides a set of managed services to provide resources for these apps, provisioning them and integrating them with Kubernetes is potentially complex. AWS Controllers for Kubernetes is an open source project, lets you define and consume these services directly from the Kubernetes cluster and gives you a consistent way to manage the lifetime of your applications and its dependencies. We've talked about this at Container Day in the past. We've made a lot of progress on ACK since the last Container Day. A bunch of controllers in preview: S3, Dynamo, ECR, SNS, API gateway, step functions, Lambda, more. Also EKS for those who want to use ACK to manage EKS from within EKS, which is an awesome inception idea. We also have work in progress on IAM and SQS, and we are really excited about two controllers that should be going GA in the next few weeks, and that's SageMaker and Elasticache. And call out here, if you're interested in contributing, we'd love to have your help. ACK is one of the projects that we work on. There are more. Security has been and will always be job zero at AWS. The Kubernetes team is no exception. We are actively involved in the Kubernetes community to shape security roadmap, participate in managing CVEs and so forth. We've open source components to simplify the deployment and management of Kubernetes on AWS. Our open source contributions and involvement, while we do that on Kubernetes, extend beyond Kubernetes. Notably, we're etcd maintainers. We have EKS distro, which is open source and available to anyone to use the same upstream Kubernetes bits we use as part of EKS. EKS Anywhere is open source. CDKates is our open source development kit for defining applications, useful for customers anywhere they run Kubernetes, and is a CNCF sandbox project. We've already talked about ACK, of course, but we have more Carpenter, CNI, CSI drivers. Add special call out there for Carpenter. We'll talk more about that later. Big shout out here to the etcd team. With version 3.5, EKS manages more clusters than any other service in the world. We're uniquely positioned to push and test the scale limits and error handling of etcd as a result. So this is a lot of what's in NTD 3.5 is things that came from the AWS team. Future roadmaps we're working with the community on include support for long-range streams, selective throttling, better load shedding, higher scale, and higher traffic Kubernetes clusters. Check out that blog post, it's a good one. CDKs. You can use this to define applications for any Kubernetes cluster, running anywhere, running locally in your dev environment, part of your CI automation, help get your Kubernetes YAML under control. You can use it from TypeScript, JavaScript, Python, Java, Go. You can import objects from any Kubernetes API version and CRDs. This makes it easy to use CDKs to write entire applications, keep them up to date without context switching between your favorite programming language and YAML. Join members of the development team later today for project update. So let's shift gears here a little bit, talk about deploying Kubernetes in any environment. We now offer multiple deployment options for Amazon EKS for both in-region and outposts. We include support for deployments onto customer self-managed compute with EKS Anywhere. With EKS Distro, we open source the Kubernetes version that Amazon uses for EKS. This is the same version of Kubernetes that EKS offers, same major, minor patch version. So this is a result of all the work that AWS does to test, certify, and build EKS when they're released. EKS Distro is part of the EKS Anywhere project. And with EKS Anywhere, we're providing that same stable and secure validated version of Kubernetes that EKS does. EKS Anywhere is built on the open source cluster API, usually referred to as CAPI. So you're not locked into any proprietary technology. It includes cluster lifecycle management tooling to let customers get a consistent operational experience. We also bundle key components, networking, storage, and we know that while a lot of customers have virtualized environments, a lot of our customers have been telling us they really want to run in a bare metal environment. So that's the next big thing up for EKS Anywhere is to run in bare metal environments, in addition to the virtualized environments we're supporting today. EKS Anywhere is a highly available Kubernetes control plane, deployment via cluster API, integrates with EKS control. We're using the Cilium CNI. Support is available from AWS. Authentication is via OIDC provided by the customer. We do have EKS console integration via EKS connector. However, the connection back to AWS or EKS, if you're using a connector, is optional. You can run air-gapped or in an occasionally connected mode. We are really excited about this. EKS provides an integrated dashboard for viewing your Kubernetes clusters across various deployment options, including on-premises with EKS Anywhere through EKS Connector. We're constantly updating the console to expose more details. So cluster operators and application developers can now use EKS as a single place to organize, visualize, troubleshoot Kubernetes applications, whether running on EKS or elsewhere. The EKS dashboard is hosted in the console and is available automatically for all EKS clusters. Please be sure to stay tuned later for a deep dive session on EKS Connector. All right, so here's a fun topic, networking at scale, which is pretty hard. And I'm sure most of you have seen slides like this before in a Kubernetes environment and containerized environments generally. You see 1 to 2, sometimes even 3 orders of magnitude in difference between running in a virtualized environment and a containerized environment. And the more you move towards a microservices kind of deployment and development approach, the more extreme this gets. So IPv6 is not new, has been around since the 90s, but has always been the next project for most organizations and applications. And especially in an a hybrid environment, some enterprises are struggling to allocate unique public and private IPv4 addresses that don't overlap between their on-premises and on-cloud environments. I'm sure some of you have heard this before. 500 billion IP addresses, enough for every grain of sand on the planet. We would, if we had been using IPv6, we would have so far consumed a trillionth of the available address space. So there's a lot of headroom here, and consequently, EKS support for IPv6 is coming soon. So one of the first bottlenecks you hit, as we said, was networking. And to be clear, what we're going to be launching here is not Kubernetes dual stack support, because that doesn't help with IPv4 address exhaustion. Rather, we're launching support for IPv6 only pods. So when this feature launches, you'll give each pod a globally unique IPv6 address instead of a VPC unique IPv4 address, allowing you to scale far beyond the IP address limitations you may have now in existing IPv4 based VPCs. Even with IPv6 only pods, EKS will configure networking so pods can still communicate with IPv4 endpoints outside the cluster, allowing you to take advantage of IPv6 benefits without waiting on the rest of your networking transformations. We'll be launching this in the coming weeks. Stay tuned, and there is an IPv6 session later today. So more scaling challenges here. While we work on ensuring the Kubernetes control plane scaling, of course, you also need to ensure that the compute connected to the cluster and being managed by the cluster is scaling to your needs, scaling up, scaling down. We will continue to support the Kubernetes cluster autoscaler, but for really big clusters or for clusters that need to scale up, scale down very fast or very large, we think an alternate approach is worth considering. This is the Carpenter project. Check it out on GitHub. We've been listening closely to customer feedback. Project has been evolving. We're working hard to get the project to the 1.0 release level. And again, there's a session later today. Few call outs here for KubeCon. We're extra excited about a few special sessions here: GitOps, security, Kubernetes on AWS, all topics that we love. And wanted to also point to a couple of things here. Since I didn't talk about all the projects during my comments here, I wanted to point out two sessions here you may be interested in. Customers have been really excited about BottleRocket. Container optimized open source OS is a perfect fit for many customers using EKS or using Kubernetes. Make sure you stay and go to the BottleRocket talk. Running applications in multiple clusters is a really interesting topic. Could probably have done a whole keynote on this and kind of related topics. We're seeing more and more of multi-cluster applications as customers scale their use of Kubernetes. So check that out during the third act. Wanted to say thanks very much to the containers from the Couch crew. And with that, I'm done.
Go ahead, I think.
Today starts making breakfast for the family. Doing my secret toast with an omelette. A solutions architect is like a cloud therapist. You need to earn the customer trust. I'm obsessed with data. We focus on infrastructure challenges so our customer can focus on their business challenges. My name is Yahav Viran, and I'm a solutions architect at AWS.
Our job is very simple: secure, efficient, and then enable the heck out of the hundreds of DevOps teams that we have across T-Mobile. AWS has really played a huge role in our modernizing our infrastructure and ecosystem at T-Mobile.
Today we run like 1 billion requests a day on AWS just on our container workloads. So we have used EFS infrequent access. EFS is, as the name suggests, it's elastic. So it can scale up and scale down per demand. We don't have to worry about pre-provisioning a storage. Teams are non-container based workloads. They have access, as long as you have like appropriate tags, you have access to go ahead and provision EFS solutions for you. If you need any extra help on it, we talk with those application teams to configure EFS solutions. The second aspect of self-service is in the container workloads. We enable application teams to use AWS EFS automatically in a Kubernetes cluster. You would just need to write a few lines of code and use a Kubernetes manifest to just go and provision EFS cluster, and you can use it in the PVCs. Our requirement for FSX was primarily on big data analytics. A lot of these teams use FSX solutions to get the reporting data as quickly as possible. So the real good thing about FSX is like it's fully managed, and the performance is much better compared to our solution what we had. We actually optimized in terms of like 50 to 60% of cost. It was pretty straightforward for us to migrate these solutions into FSX. Many of the things what AWS provides, we just go and just use it because it saves a lot of time, saves a lot of cost in many of the cases, and scalability. And most important is the reliability aspect.
Did. Oh, I did that. Welcome back. Thanks for joining us, Bob. That had so much content. Like, I'm excited for pretty much every one of the sessions, which is why I'm here. I'm excited to watch along with everyone. Thanks everyone for joining, seeing great comments. There's also a lot of people that are presenting later are in the comments right now moderating. I saw Jay in there, I saw Amin in there. So feel free to ask questions early as well. You'll get some links, but then stick around for the sessions. I am very excited for the ACK session coming later and EKS Anywhere. If you're looking at running EKS on-prem, it's I think maybe biased, but a great solution. So stick around for that too, because we had a cool demo for that. And as Bob was mentioning, AWS security is just like number one. Doesn't matter what we're doing, security has to be there. And so this next session, bringing up Jeremy and a panel of some great hosts to talk all about security. Jeremy, your video is small. I don't know why that is. It might be a Zoom issue.
Could be.
That's all right.
All right.
We can still hear you fine, so this is great.
Good.
But this is a session all about EKS security. And I'm gonna let Jeremy take it away because we got a lot of good questions. Feel free to ask in the chats if you have questions about security. And go ahead, Jeremy, let's kick it off.
Okay, let me start by sharing my screen.
Yeah.
I'll put this in presentation mode. Great. So I thought I'd start by talking about the shared responsibility model. Also, I'm joined today by my friends Rob Clark and Micah Hausler, and I'm going to be facilitating a conversation today about container security. But as a lot of our viewers may know, AWS has this model known as the shared responsibility model. And this is important because it delineates the things that our customers are responsible for as consumers of AWS services and the things that AWS is responsible for as a provider of those different services. And as I'm sure a lot of you are aware, we provide global infrastructure on which our services are built, and we're responsible for securing that infrastructure. And then this demarcation between the things that you are responsible for and things that we are responsible for moves or changes as you use different services. So we have a core set of infrastructure services where you are responsible for the lion's share of security. Again, we're responsible for securing our global infrastructure, the physical data centers, the hardware, the virtual machine software that we run on that hardware, and so forth. But then customers are responsible for things like controlling access to the resources that they provision within AWS, using identity and access management controls. They're also responsible for things like server-side encryption or encryption in transit and so forth. But then as you start consuming higher order services, things like container services, AWS assumes a greater share of the responsibility. When we look at EKS, which we'll do so momentarily, AWS is responsible for managing the control plane for Kubernetes and other elements of the service as you use different features. And then we have services that are abstracted further, things like Lambda or say EKS Fargate or App Runner, where AWS assumes yet an even greater share of the responsibilities. And for additional information about security best practices and the shared responsibility model, you can visit this link here below. Now, if we look at an EKS cluster, it's really divided into two parts. We have the EKS control plane, which consists of the API server, the controller manager, the scheduler, along with etcd. And AWS is responsible and has been responsible for managing that component of the service since its inception. When you use self-managed workers with EKS, you are responsible for your data, how you grant access to different resources that run within your cluster. You're also responsible for Kubernetes specific resources, things like network policies, RBAC bindings, quotas, limit ranges, and so on. But you're also responsible for worker node scaling, the VPC configuration, and so on. The only change to this slide that I'll mention is around cluster add-ons. So earlier this year, we released support for EKS add-ons. Today, we support 3 add-ons that you run within your cluster, the VPC CNI, kubeproxy, and core DNS. Now, this is an optional component that customers can use where we'll manage the lifecycle of those add-ons. And going forward, we're looking at adding support for additional add-ons to alleviate the undifferentiated heavy lifting that goes into managing those add-ons. Now, as the service has evolved, we've offered a greater amount of management. So with managed node groups, we now partially assume responsibility for the lifecycle of the data plane or your worker nodes, which is why the OS, the kubelet, and CRI are shaded here, or we're using a gradation shade to depict that, because we maintain an EKS optimized AMI. We're responsible for the lifecycle of that AMI, and we give you a way to orchestrate the deployment of new AMIs as they're released. And then finally, with AWS Fargate, we're assuming full control of the data plane in that we're responsible for the infrastructure scaling associated with node scaling. We're also fully responsible for updating the OS kubelet, CRI, and the AMI that we use for running EKS Fargate pods. So with that as the backdrop for our conversation today, let me stop sharing my screen. I thought I would start by asking Micah how we secure our EKS binaries, not only for the AWS, the EKS service itself, but also for variations like EKS distro and EKS Anywhere.
Yep. Yeah. Thanks, Jeremy. As Bob mentioned, we launched the EKS distro project almost a year ago now at our reInvent 2020. EKS distro is the same Kubernetes that EKS uses on the managed control plane, but you can run it yourself. So that's available as container images, as binaries as well. And it's frequently updated for whether it's Kubernetes CVEs or if it's a container image. If there's a CVE and a container image, you can get the latest builds provided by AWS. We use open source tooling. The build code for that is all open source. It's on GitHub. You can see the select set of patches that we apply to Kubernetes for security, operational performance reasons, and those are all provided through standard AWS services like ECR and HTTP. With the implementation for us is CloudFront and S3. We're using our own services here, but that's a little bit about EKS distro.
And when should customers expect new versions to become available? New versions of those binaries?
Yep, we release the same frequency as EKS. So when EKS supports a new version of Kubernetes, EKS distro will produce those builds for you to run yourself. You can run it with COPS, you can run it with EKS Anywhere, but we do the same frequency as EKS.
Great. Another area that our customers often have questions about is multi-tenancy. So there are various ways to approach multi-tenancy with Kubernetes. Kubernetes has native support for namespaces, which allows you to partition your cluster and give different teams the ability to deploy their applications into those namespaces. But how should our customers really be thinking about multi-tenancy and Kubernetes? And this is for Rob.
Yeah, that's a really good question. There's different challenges because one of the things we've heard from customers is that multi-tenancy maybe means a different thing to them than it does to us as a massive provider, right? It's probably true to say that anybody running a Kubernetes cluster at significant scale is mixing workloads of different levels of severity, or those that have maybe different types of data within them. It's important to recognize that with any kube cluster, the most robust security boundary is the edge of the cluster. So if you're running very sensitive workloads, the safest option is always to run it in a separate cluster. And the reason for that is that many components of the Kubernetes control plane can be considered to be really single tenanted, Kube API being the best example. A compromise of that, or a compromise of something that has privileged access to calls within Kube API, can be disruptive to an entire cluster. So that's the very defensive security position. It's also the case that not everybody can deploy kind of clusters for every single tenant that they consider on their system. So for them, there's a few options available. As you mentioned, namespaces exist as a natural boundary within a Kubernetes cluster. It's also the case, though, that not all resources currently are namespaced. So it's not a cure-all, but it can be useful. There are a few options available to customers if you're going kind of bottom up and thinking about container breakouts. Looking at different mechanisms for isolating a pod is a very useful and sensible step. One way, obviously, we can do that within EKS is to use Fargate. Fargate isolates pods within a virtual machine boundary, which we understand to be very robust and a very nice way of containing dangerous workloads. One of the challenges there for some customers is that your ability to deploy things like daemon sets is very limited. So it really depends on how you are considering about securing your entire cluster kind of holistically. So the key point here really is to understand that your workloads and their attack surface and the data within them are really key to your design decision about whether you're going to go ahead and deploy an independent cluster, whether you feel comfortable separating things by namespace, or whether you feel comfortable co-locating pods within specific namespaces. With whichever of these you choose, it's important to, and I think we'll talk about this a bit later, is consider how you're going to do policies and governance around what these pods can do. The biggest risk when running a multi-tenant cluster isn't necessarily the specter of a container breakout, although it's where most of the security industry likes to focus because it's exciting stuff. It's actually in basic misconfigurations of things like RBAC. I'm less worried about somebody breaking out of a container than I am what a sufficiently authorized container can already do if it is subverted without an escalation of privilege. And I think a lot of the time in the industry, we spend a lot of time focused on thing one, a breakout, and far less on thing two, which is like the policy and the RBAC and constraining whatever that container can do as an authorized entity. Micah, do you have any thoughts you want to add?
No, I think that's a really it's a really good point. I think as with most questions, when you start touching on security, there's a lot of nuance. As you called out at the beginning, it very much depends on a lot of the on the organization and what their profile is and what they're doing. Great.
And that actually coincides with the results of the Red Hat State of Kubernetes Security Survey, where like half of the respondents reported that they worry about misconfigurations within their cluster will lead to breaches. So you mentioned that Fargate might be a possibility or as a way to provide isolation. How should customers think about using Fargate? You mentioned that it doesn't yet have support for things like daemon sets, but does it provide ample isolation for a multi-tenant environment? And are there advantages to using Fargate, say, instead of an EC2 instance?
So, as Nita said, security is nuanced. The most secure way to run Kubernetes is probably to stick EKS Anywhere on a cluster, put the cluster in a shipping container and drop that in the middle of the sea and never worry about it again, right? We can be reasonably confident that it will be secure in that state. And I bring that up because we run into statements around our solution in security all the time, and it's not helpful. So what EKS Fargate does is adds really defense in depth for Kubernetes applications. It allows you to isolate each pod within a virtual machine, and that boundary prevents access to host-based resources that are used by other pods. So in the event of a container escape, which, as I said, is a common thing that we are concerned about, applications in those pods can't gain access to any other resources. In addition, the RBAC and things are appropriately configured out of the box there. Using EKS Fargate doesn't actually change your responsibilities under the shared responsibility model that you described earlier. It's just adding this layer of defense, this layer of isolation. Obviously, it integrates nicely into the EKS and AWS ecosystem and allows you to kind of manage your pods in a slightly more native way. But I would remind anyone, think about the governance and controls you have in your cluster. EKS Fargate is excellent, and it adds a robust layer of defense in depth. But as we're learning with Kubernetes in general, as an industry, there's no silver bullets here. Right? It's all about how you're configuring things up and down your stack to try and be as secure as possible.
Great. And I know that within the last 12 months or so, there have been several Kubernetes-related CVEs. When we look at the shared responsibility model, AWS is responsible for patching the control plane as these CVEs are announced. How are we dealing with this, and how do customers know that we're applying patches in a timely fashion to their clusters?
Do you want me to take that one, or?
I'll let you start.
Okay. As in all things, Micah can keep me honest and accurate here. So there's a few elements to managing security for Kubernetes, especially when you're running at our scale. So we work closely with the community on security and related efforts, and this includes being active members of the Kubernetes Security Response Committee, the Security SIG, and the CNCF Security Tag. We work closely with the Security Response Committee on any embargoed security issue. And that helps us to ensure that our customers and their workloads are protected from new or novel issues before they become a real risk. We regularly make updated armies available for download, which might include more routine updates, performance changes and such, but also regularly contain CVE updates. We recommend that customers are always running the most recent army for the version of kube that they have deployed. We provide an extended window of Kubernetes version support, normally about a year out. So basically, we will take security updates and make sure that any of our supported kube versions are patched against those CVEs. And one of the more interesting things is we support automatic upgrading of clusters on versions of kube that are going out of support. So we actually ensure that our customers stay on supported versions of K8s by auto upgrading them at the tail end of our support window.
Yeah. And I was
going to say,
sorry,
I was going to emphasize how important it is for customers to stay up to date. Although we give them, an automated mechanism for upgrading their clusters, it's really important that they stay current with Kubernetes.
Yeah. To tie into your previous question about Fargate, that's one of the advantages of Fargate is that patching, like the automated patching. When there's when you hear about a Container Day CVE or a kubelet CVE in Kubernetes, you know that your next Fargate task is going to be patched for that, and you don't have to worry about it. Also, with the Fargate model, when there's a container breakout type bug, like it's always less of a worry because you only have one pod per Kubernetes node. But that's just one of the advantages that Fargate brings.
Okay, let me change gears a little and ask a slightly different question. So the AWS load balancer controller already integrates with the Amazon Certificate Manager for certificate lifecycle management and assignment. What sort of options are available for customers who want to use ACM without the load balancer controller?
Yep. Yeah. So as you said, the load balancer controller that we support, it's open source. It's on GitHub under the Kubernetes org that we maintain and help keep up and add new features to. Maintains network load balancers, application load balancers. You can put the ACM certificates that you already have on those load balancers to secure connection. But as your question is, okay, if I'm using something else or certificates within my cluster, how do I secure that communication? ACM, Amazon Certificate Management Service, has a feature for private certificate authorities, and we AWS just launched a add-on to or a plugin for the Cert Manager project. It's another CNCF project that's built on Kubernetes that lets you request certificates from your ACM private certificate authority. So if you want a pod to have a cert that to secure communication within the cluster or from external sources, you can use ACM generated certificates that are backed by an HSM and everything to generate certificates into your cluster.
Great. Yeah, that's a really useful feature. All right, let me switch gears a little again and ask a different question. So when talking to customers, it seems like it's not terribly uncommon for them to have multiple clusters nowadays. There may be customers that run a few very large clusters, but increasingly customers are creating multiple clusters, perhaps for different environments or for running different sets of applications. And applying configuration consistently across clusters can be a challenge. And especially as your number of clusters increases. And so how is AWS thinking about this problem? And this is for either Rob or Micah.
I can take this one.
Okay.
Yeah, I think there's two primary approaches here that we really are seeing our customers get behind and working well. One, which I'll touch on lightly, is this thing you might have heard of called GitOps, or Git-based configuration of a cluster. And we use, there's a lot of different, or a number of different engines for that. One that we use in EKS Anywhere and bundle in is Flux. And that sort of provides like the consistency of state in the cluster, and continuous enforcement. The second part to this is sort of visualization, so what's actually going on. And we recently launched the EKS Connector. This provides, it's an agent that you can run in your cluster, your EKS Anywhere cluster, your cluster in any other cloud provider, your cluster that you manage on your own hardware. It doesn't matter where. You can run the EKS connector and have in the EKS console visualization of the resources in that cluster. And you can see it right next to your EKS clusters in AWS, in AWS Cloud. It lets you sort of see side by side, is the configuration of my on-premise cluster or my cluster in another cloud provider the same as it is in EKS.
Nice. Rob, any thoughts?
No thoughts specifically. I don't have anything to add to what Micah was saying, but I was just reminded that you asked a question about CVEs a minute ago. Micah and I actually have a KubeCon talk on Friday, which is a Hitchhiker's Guide to Kubernetes Vulnerabilities, where we go pretty deep on this and we look at the distribution of vulnerabilities across the entire lifetime of Kubernetes and try to figure out if, from the trends we're seeing, do we think Kube is getting more secure or less secure? Do we think vulnerabilities are more of a concern or less of a concern? And how well do we think that the community is really managing this, and how well do we participate in that? So just a quick plug for that on Friday afternoon, the Hitchhiker's Guide to Kubernetes Vulnerabilities.
Thanks, Rob. And I think I'll ask a final question before we open the floor to questions. But what are you looking forward to in 2022 and beyond? Bob, talked about a lot of really interesting things that are coming down the pike. I'm personally excited about where we can use eBPF. I'm also looking forward to the next version of pod security policies and how EKS can make use of Bottle Rocket, not only for running EKS clusters in the AWS cloud, but also with EKSD and EKS Anywhere. Any particular things that you're looking forward to?
One thing I'm really passionate about and have been able to help build a few features and parts of EKS is the identity space. So I think you'll see better integration with EKS and IAM, both directions, in and out of AWS. I think you'll see. I'm also working on EKS Anywhere, and that's an area I'm really excited about. So I think both just in the feature side and then on the security side, there are going to be really neat things coming out of that in the next year.
Great. And Rob, anything stand out for you?
Again, I'm in danger of just repeating Micah. I think one of the most exciting areas here really is, in security and observability. We're just now learning as an industry the value of something like eBPF. We're just now starting to exercise some of the edges of it. And I think the ability it's going to provide us to understand and profile the correct or abnormal behavior of pods is going to really open up a lot of nuanced approaches to security in Kubernetes. I think over the next several years, we're going to see advancements in mechanisms to automatically protect clusters and mechanisms to reduce down and scale down risk over time. In the more near term, one of the things I'm really excited about is the move away from pod security policies and into pod security standards. I think the main point here is that pod security policies were hard and people often got them wrong. And a lot of compromises that were seen in the wild were a result of people making mistakes in the amount of privilege that they would allow a pod to have. I think the move from pod security policies to standards is an interesting one because it actually signals Kubernetes moving away from the business of trying to govern policy, right? There are entire huge open source projects, many of them, dedicated to just trying to figure out how to correctly express and apply policy. And it doesn't necessarily make sense for a container orchestration system to try and also be one of those things. So what this move is a gentle push to the community to go and use one of these more accomplished platforms like OPA or Gatekeeper or Keyverno. And pod security standards exist to provide what I call foot gun protection, right? They're the very basic, like, tiered sets of standards. There's privileged, baseline, and restricted. And these exist for you to kind of be able to categorize a pod into one of these three and try and constrain it in a sensible way. I think that the general direction we're going in is interesting. I expect to see a lot of providers become opinionated about whether they would really like a Rego-based language or whether they want to go with something like Keyverno or something else. And as Michael already said, there's really interesting opportunities for integrations with things like AWS IAM and other stuff in the future. So I think the entire realm of policy and authorization in Kube is something that's going to change a lot over the next couple of years and be very, very interesting from a security point of view. And I think that our ability to get enhanced observability and understanding of what pods are doing at runtime through things like eBPF are also going to be very interesting. So we're going to kind of be able to top and tail this security problem. We'll have better ideas of what we actually allow to go into a cluster and better observability of what they're doing once they're in.
Thanks. Thanks, Rob. So I'm going to invite Justin to rejoin us here. And Justin, are there questions from the audience that we could answer while we're here?
I was really interested in what Rob was just saying because I never thought of pod security policies going away as a great thing for the community because it does let security of pods be more refined, and we can really focus in on what individual users and companies need based on, it's not just a generic, hey, this is a policy you like. The pod security policy is great for the 80% use case that Rob was saying, like the ecosystem changes quick, and not having to roll that into Kubernetes allows people to separate it. Depending on what Kubernetes version you're on, Kubernetes can keep going forward and you can kind of manage all the
Hey, Justin, I don't know if it's me, but it's a little hard to hear you.
All right, we'll try to
turn
my mic up a little more. There are a couple questions from chat that I wanted to bring in. One of them, where'd it go? Was just around viewing EKS control plane details. What recommendations do we have for customers running EKS, especially hosted EKS in AWS, to be able to see what's going on in their clusters on the control plane side?
Sure. So I could start. We do expose the metrics endpoint for the control plane, and customers can configure the Prometheus agent to scrape that endpoint and surface those metrics in a dashboard like Grafana. That's perhaps the easiest way that customers can get metrics information from the control plane.
Yeah, go ahead. Robert, you got something to say?
Yeah, I was just going to add that the EKS workshop, I think, is a useful way to help people understand a little bit more about how EKS is built and how it works. This is actually published as a standalone resource on EKSworkshop.com. And that's a very good series of tutorial-like lessons that you can work through at your own pace to help you really understand how EKS is built and how you can use it to deliver value.
Yeah, there's a ton of content in there. Everything from running clusters to exposing those logs and metrics to be able to see what's happening in the cluster. The other point I could also mention is EKS clusters can log into CloudWatch logs for any sort of logs that you need to get out of the cluster itself, see what's going on, and obviously everything else from CloudTrail and for access management, actually seeing API calls and that sort of stuff.
Yeah, and I know that we have had conversations about how we can make this simpler for customers by exposing these for them within the EKS consoles. So today, while there is work that customers need to do to scrape metrics for the control plane, we do intend to make this simpler.
Cool. Last question that I saw in chats, some CKP Cloud 12. Is there something like KubeBench that we recommend for EKS? Is there anything specific about KubeBench that we have integrated, or do we recommend people use something like KubeBench to look at their clusters?
So KubeBench can be used to analyze the conformance with the CS benchmarks, so at least the worker nodes. You don't have the ability to run that against the control plane today. We have done work to integrate KubeBench with Security Hub, so you can surface violations that KubeBench detects directly into Security Hub.
Am I muted?
No, we
Am I
can.
muted?
Nope, we can hear you.
Okay, sorry. I saw the icon. Forgot.
Yeah, the other thing I'll add is for EKS Anywhere, you can run KubeBench and you have the full Kubernetes control plane. So you can validate that it's running with the correct configuration. We also run that test. We configure the EKS Anywhere clusters that way, but that's one other flavor of EKS that you can run KubeBench against.
Yeah, and I was going to point out that, EKS is Kubernetes, so if you have a standard tool that you want to run, you're welcome to run it. Just varying degrees of, as it was described from Jeremy, ownership of responsibility for those clusters and security might rely on AWS versus you, but as Micah pointed out, EKS Anywhere runs completely on-prem, which is coming up in about an hour. We'll have EKS Anywhere demo, which I'm all ready for. So thank you everyone for coming for the security panel. Next up, we're going to do some roadmap overview. It's going to be Alan and Mike are going to talk about what's coming up in the next year for EKS, EKS Anywhere, and everything on AWS. So stay tuned. We'll be right back.
Thanks a lot.
I like to wake up early in the morning because I do my best thinking. It is super important that we have diversity in our business. I meet with my interns daily, and it is important to us that they are more than technically strong. We need them to be people strong as well. The key is actually predicting what the customer is going to need and then work backward from there. True joy to work with passionate people. You can see people multiplying each other's productivity. Around 2 or 3 o'clock, we'll often go to the deck and have a bowl of ice cream. I'm Ridley Huang. I'm a principal software engineer at AWS.
Skyscanner is a global travel search company. We have over 100 million users a month relying on us to find their travel needs.
Customers cannot accept that our site is offline for anything more than a few seconds. So it's super critical that we are available all the time. And this was one of the main driving forces for moving to AWS. We were always playing catch up. The data centers were getting close to capacity constantly, and we were constantly having to add new hardware and play catch up with our ever increasing growth.
Skyscanner engaged with AWS from day one. We got support from our account team, the solution architects, and they provide us with some great support to kickstart our migration. This wasn't a basic lift and shift. We spent 3 years doing re-architecting, and then the last year doing lift and shift and re-platforming.
At Skyscanner, our container environment is spread across Amazon ECS and Kubernetes. We have over 700 services deployed onto these clusters, and on any given day, we'll be running sort of 8,000 to 9,000 different tasks and pods on the clusters. There's some really innovative services that are available on AWS, and they certainly help Skyscanner to power their business.
Skyscanner initially used on-demand instances. We quickly moved to reserved instances for 70% of our workload, but then to drive down costs further, we use Spot. Skyscanner's entire online platform uses Amazon EC2 Spot instances. Amazon EC2 Spot instances saved us 70% per core and also provided us the flexibility to move our workloads globally.
Kubernetes as a Spot is a great fit, especially if you're running stateless microservices. The fact that the scheduler is designed inside of Kubernetes to move instances of services about, you can deal with the issues that you have with capacity. Using a traditional data center, it used to take us 6 to 7 weeks to launch a new service. On AWS, it can take us 15 minutes. We have thousands of services running in AWS versus a few hundred in data center, and that means more products and new features for travelers.
Migrating to AWS has enabled Skyscanner to focus on innovating for the traveler rather than managing IT infrastructure.
Mike's coming.
Good morning. I'm Alan. Really happy to be here today at Container Day. Talk to you about Amazon EKS vision and roadmap. In the next 30 minutes, Mike and I are going to talk a bit about what we've been up to over the last 12 months, what we've been hearing from you as our customers, and give you a sneak peek into the EKS product roadmap. So let's get started. So EKS is used in every industry around the world, from finance to gaming to social media, transportation, retail, public sector. Our customers run EKS in every country, and they use EKS to deliver value for their businesses. So let's talk a bit about the tenets that we've anchored on with EKS Anywhere when we created the service. Our goal was to provide a managed service experience that focused on security and stability. We consider security as job zero, and I think from the last talk, you probably got an idea of all the investments that we're making around security. But our top priority is really to ensure that we're able to support production workloads that are running across every customer segment, from startups to global 2,000 customers in every industry. In EKS, we've created millions of clusters, and we've handled hundreds of thousands of cluster upgrades. And at the scale that we operate, we consider change management to be extremely important, so that any change that we make across our fleet, we actually test and we validate to ensure that it doesn't impact any running applications. For example, for our CVEs, for some of the patches that we roll out across our fleet, there is typically no customer involvement. Our engineering team takes great pride in security and operational excellence. And on the product team, we actually consider security and reliability to be our top 2 product features. We're also committed. Our goal with EKS is to provide really a central place for you to manage all of your Kubernetes experience, from management to operations, and provide you all the tooling to be able to run Kubernetes clusters and operate applications across your environments. We've extended the deployment options available to Amazon EKS, from deploying on AWS to local zones to supporting outposts, and most recently with our investments with EKS Anywhere, we're providing you the ability to take EKS and run it on customer managed infrastructure in your own data center. We also took the EKS distro, which is really the Kubernetes that we run in EKS, and open sourced it and provide that for you to run on your existing environments using your own management tools as an option as well. With Amazon EKS Anywhere, we actually launched a service September 8. We went GA with EKS Anywhere. You'll actually, there's a session coming up in a bit that goes into detail with a demo. But with EKS Anywhere, we wanted to really provide our customers with an opinionated tool set for running and managing and operating EKS clusters in their own environments, right? In your customer managed environment. So the way we accomplish this is really take a set of open source tools like Cluster API for managing clusters, and package that in a way where you can install on your own infrastructure. So we actually package up a bunch of components with EKS Anywhere to really provide you that level of automation around cluster management. So for example, we package in a node operating system, which is BottleRocket. This is Amazon's container optimized operating system. We also support Ubuntu as a node operating system. We bundled in Cilium for pod networking policy and CNI. We are also bundling in Flux for change management. So the Flux controller for doing GitOps across your fleet of clusters. And EKS Anywhere actually runs both air-gapped. It runs in semi-connected environments, partially connected, as well as fully connected environments. So you can take any EKS Anywhere cluster that you create and attach it to the EKS console. Last but not least, everything we bundle in, we support. So our customers can sign up for support for EKS Anywhere from AWS, and we will support all of the various components that we bundled into EKS Anywhere. We've extended the EKS console to actually enable you to attach to external clusters. So for example, any conformant Kubernetes cluster that's out there, you can install an agent on that cluster and then use the EKS console to attach to that cluster. Once attached, you're able to get basic observability around Kubernetes metadata for those clusters that are running within AWS and outside of AWS. In the future, we plan to invest in various areas around management operations for attached clusters. So the whole notion of infrastructure as code has been around for a while. Customers have been describing configuration as code and deploying in Git and leveraging Git workflow to do these types of operations for a long time. What's interesting about GitOps is it really brings the Kubernetes declarative model. So that customers can really describe their clusters in such a way, think of it as the declarative state for their cluster and store that in Git, and then have Kubernetes controllers actually reconcile that state across those configurations that are defined in Git. This is an area that Amazon EKS is investing a great deal of time and energy in bringing the GitOps experience as a native experience for Amazon EKS. As a matter of fact, with EKS Anywhere, we've made GitOps really a native experience by bundling in the Flux controller as a means of leveraging Git to describe the configuration across EKS Anywhere clusters. And we plan to continue investing here and really extend that operating model all the way from EKS Anywhere into EKS on AWS so that now our customers can start to think of the world as far as change management in a consistent fashion across their clusters that are running pretty much anywhere EKS is running. We also heard from you that you want a simpler way to consume AWS services from Kubernetes, and part of the motivation behind the creation of the open source project called AWS Controllers for Kubernetes, ACK, was just that. So with ACK, we remove a lot of the undifferentiated heavy lifting required to consume AWS services from Kubernetes by providing you with controllers that make that much easier. And we've been doing a lot of work in this area over the last 12 months. As a matter of fact, we are going GA with a couple of services by the end of this year. Those services are Elasticache and SageMaker. And we've got a pretty rich roadmap of services that we're onboarding over the next 12 months. So really, when you think about it, the whole purpose in terms of our vision with Amazon EKS is really to enable you, our customers, to focus your time and energy on strategic operations and leave the tactical operation. Again, I'll use the term undifferentiated heavy lifting. We love that term. Leave that to AWS, right? Really around building your clusters, scaling your control plane, patching and securing your environment, setting up, performing the cluster upgrades, and at the end of the day, ensuring your applications are running resiliently on top of Kubernetes. We've been pretty busy. We've been listening to you and taking your feedback and building features and functionality over the last 12 months. There are various areas that we've really doubled down and have been investing in. If you think back to when EKS was first launched, our goal was really around providing a highly available, resilient, and secure control plane. Then we focused our efforts on kind of bringing that goodness to the worker nodes and bringing the Kubernetes API to the EC2 layer and providing more of a managed experience. In the last 12 months, it's really been focusing on things like region expansion, Osaka region, leveraging, supporting more and more Kubernetes versions, introducing different deployment options like EKS Anywhere, bringing EKS distro as an open source project to the community, enabling our customers to attach conformant Kubernetes clusters to the EKS console using our connector, support for OIDC, and it goes on and on and on. And we have a very rich roadmap that I'm going to hand it over to Mike to now talk about.
Okay, thanks, Alan. So you heard the vision. Now we're going to dive into some of the specifics of what's coming into the rest of this year and 2022. When we think about the roadmap, we're going to break it up into 4 buckets: security and reliability, performance and scale, management and observability, and consistency. And we're going to cover each of these, some of the things we've launched, and some of the things that are coming over the next year. So security, it's no mistake. You've heard this point hammered home and home already today. Bob talked about it. We had the security roundtable the last session. Alan mentioned it before. It's the top priority for a reason. It's the thing we spend probably the most time on. It's the feature that gets prioritized over everything else. And you saw this in the last session, but I wanted to touch again on the shared responsibility model. It differs a little bit whether you're using Fargate or bringing your own instances. But the point is, using a managed service like EKS, everything in orange is our responsibility. And so things like vulnerabilities in Kubernetes, Alan mentioned this, we're part of the product security committee that's responsible for triaging vulnerabilities. Oftentimes, when a CVE is announced, your cluster's already patched. You don't have to do anything. And that's not really a particular feature. You're not going to see a what's new post about it, but it's really something we spend a lot of time on. And then on your side of the responsibility model, what's in blue, a lot of the features on the roadmap are designed to make managing that shared responsibility on your side easier. And then reliability. Really the vision with an EKS cluster is you create the cluster, you get a Kubernetes endpoint, and that endpoint is going to respond, whether you're running 5 worker nodes, 1,000 worker nodes. One of the benefits of running EKS on AWS in the cloud is we get to take advantage of all the latest AWS innovations in infrastructure, whether that's moving etcd to run on the latest EBS volumes or the API servers to run on the latest EC2 instances. Even for existing clusters, you're going to get improved performance without having to do anything. It's just a benefit of using EKS. So some of the things we've launched, some of the things coming soon. On the managed node groups side, since the last time we talked, we launched support for taints and parallel node group upgrades. Taints lets you isolate workloads within a cluster. Parallel upgrades, if you're running worker nodes that are a node group with, say, 50 or more nodes, you can complete the upgrade in a faster amount of time. Again, version end of support dates. So I want to spend a little time on this one. One of the easiest ways that you can operate your cluster securely is to keep up with version updates. It's really probably the most critical part of that shared responsibility model. Kubernetes actively discourages vulnerability submissions for old versions. And so if you're on an old version, you might have a vulnerability that we don't even know about. So that's why we have the policy of the way it is. And the 117 end of support is coming next month. 118 is coming next year. So it's critical that you have an ongoing plan to upgrade Kubernetes versions. It's not just about getting new features, which of course that's great, but it's really about security. A couple other things I'll touch on here. I won't cover it all. One good example of your side of the shared responsibility model is IAM roles for service accounts. So while you can give permissions to your workloads by just adding policies to the worker node role, that really violates the principle of least privileges. And so with IAM roles for service accounts, you can give just the IAM permissions to the pods on a node that aren't shared with other pods. And this feature, we've heard it works really well with a smaller number of clusters, but we heard from you that you run into challenges when running multiple clusters across multiple accounts. And so we have plans to update how IAM roles for service accounts works to change the credential vending model to make it work across easier across multiple clusters. Another one I'll touch on here is cluster access management. Today, to give permissions to users to access your clusters, you do it through the AWS auth config map. And we've heard some challenges around managing authentication inside the cluster itself. And so we're working on a new set of EKS APIs to move that authentication into the EKS API itself. And that'll make it much easier to manage authentication through infrastructure as code tools like CloudFormation, Terraform. And then in addition to that, we'll also be adding an authorization layer. So for straightforward permissions use cases like giving a user read-only access to namespace A or cluster admin access to namespace B, you'll be able to do that directly through the EKS API without having to go through RBAC itself. So those are some of the features. There's a bunch of other ones here. There's always going to be a lot on the roadmap on security and reliability. It's first for a reason. So we recognize that many of you run in regulated environments, and EKS makes it easy for you to run those applications and meet the compliance requirements in those environments. The one I want to highlight here is FedRAMP and FedRAMP High. We achieved that compliance earlier this year, and there's additional ones on the roadmap. Okay, performance and scale. This is, I would say, after security reliability, the next most important set of features. And it applies to both the control plane, which we've really talked about, but then on your side, making sure that the system, your workloads can be scaled up and down dynamically and making it easy for you to make that availability trade-off of cost versus availability for your workloads. So a couple of things to highlight here that we've launched. Probably one of the top feature requests since we launched EKS was increased pod density. We made a somewhat unique choice when we launched EKS over 3 years ago now to build the networking plugin that integrates directly with the VPC. And it has a number of advantages because you get the raw networking performance of a VPC without a virtualized layer running on top. The downside of that is that we were beholden to how the VPC works. And in some cases on smaller worker nodes, you may not have been able to run pods and fully utilize the resources. And so to address this, we worked really closely with the EC2 team over the last year to build a container optimized VPC feature where you can attach prefixes of IP address blocks to nodes rather than individual ones. And then we added support for that in the CNI plugin. So you no longer have to worry about IP addresses as a constraint for achieving full efficiency on your worker nodes. And then scaling. So managed node groups scale to 0 phase 1. You can now manually scale managed node groups from 0 and back up. The API allows that. Phase 2 we're working on, which is a contribution upstream to cluster autoscaler, which will make it automatically scale back up and down based on requests with managed node groups. And then, so we are investing in Cluster Autoscaler, but of course, for some customers, we've heard challenges with Cluster Autoscaler, and that's why we've built Carpenter. We have a session on this later today that will go in much more detail, but the 1.0 launch of Carpenter will be coming later this year. You heard Bob mention IPv6 earlier today. While pod density, that problem has been solved at the node level, customers are running into IP challenges at the VPC level, where you may be running out before you can scale clusters. And so IPv6 is the solution to that. There'll be a talk on that later today where we'll give a demo of how it's going to work, and that one's coming soon. Okay, management and observability. This is a large topic with quite a big surface area. As you start to run more and more clusters with EKS and move more and more workloads, one of the easiest ways to make managing multiple clusters easier is to make managing a single cluster super easy. And so a lot of the roadmap, a lot of what we're working on is automated lifecycle operations to make managing that single cluster as easy as possible. And then on the observability side, it's really two-sided. It's on the control plane itself, and then it's your applications running in the cluster. How do we make it easy for you to ingest and understand insights that make it so you can improve performance, reduce cost, and minimize time to really troubleshoot issues? So some of the features that fall into this bucket. EKS connector, that was discussed. So giving you a way to connect non-EKS cloud clusters to the EKS console so you can observe and visualize what's going on in all of your clusters in a single place. And then additional EKS add-ons. We added support for Core DNS and Kube Proxy earlier this year. We have a long roadmap of additional add-ons coming, OpenTelemetry for observability, storage for CSI drivers, the load balancer controller, metric server. Those are all with the goal of making it super easy to manage lifecycle within a single cluster. Some of the other things on the roadmap, integrated GitOps. So like Alan mentioned, Flux is already bundled with EKS Anywhere. We're going to also make that an option to install directly through EKS add-ons, and that'll make change management across multiple clusters easier. Performance insights, I think it was mentioned in the last talk that we do expose Prometheus metrics for the control plane, but you still have to do the work of ingesting those metrics and analyzing them. We want to make that easier for you so you can just log into EKS, go to the console, see what's going on with your control plane without having to manually do that. Cost allocation, this is a big one, especially as you run more clusters. And if you're running clusters with different tenants from different teams, dev team A, dev team B are sharing the same cluster, you want to understand which of those teams are using which resources. And so next year we'll be adding a feature into EKS where it makes it easy to see exactly what those costs are between different tenants at the namespace level all the way down to the pod level. Okay, and then finally, consistency. This one is really all about giving you the same consistent supported experience in any environment that you can run Kubernetes. When we launched EKS, it was EKS in the cloud. With the EKS Anywhere launch last month, we now give you that same experience for running Kubernetes in your own data center. And then portability. So with portability, it's really about being able to run in multiple environments without making significant changes. But at the same time, you should be able to take advantage of some of the unique features, whether it's performance, scalability in the environment that you're running in without having to make significant changes to your application. So EKS Anywhere, we've discussed. I think it's next, or the one after. We'll dive much deeper into EKS Anywhere. ACK, AWS Controllers for Kubernetes. This gives you a Kubernetes native option for managing AWS resources, and several controllers will be reaching GA later this year. CDK for Kubernetes. Again, consistency, using the languages you're used to define your applications. We'll have a talk on that later today. And then the last two I want to spend a little more time on. So multi-cluster. One of the challenges we hear as you start to run applications in more and more clusters is removing dependencies from service A and service B that are running in the same clusters or different clusters. It shouldn't really matter where they're running for them to talk to each other. And so we are working on implementing a controller that implements the upstream multi-cluster services API and uses CloudMap as the backing layer. That'll give you a way to easily do service discovery across clusters without having to go to a full service mesh, where you may not need all of the features of a service mesh, you just need service discovery. So that's something that we're working on coming soon. And then lastly, I wanted to call out EMR and EKS. So this was a deployment option for EMR launched, I believe, late last year that can target EKS clusters. And today they support Spark, but in the future, they're working on adding additional frameworks like Flink, Presto. So again, the goal of consistency, whatever framework you need to run, you should be able to use the same tools that you're used to. And just to visualize this Kubernetes consistency, we've talked about it. EKS now supports many environments all the way from your own hardware to AWS regions, and then you can see the deployment options in between with outposts and local zones. And we have additional options coming next year that'll further slice up this graph, so you'll see additional ways where you can run Kubernetes. Finally, of course, I'm going to shout out the roadmap. This, a lot of what you just saw comes from the feedback you provide on the public roadmap. Myself, the other product managers, we're in this roadmap every day, seeing your feedback. If you have a feature request, go check the roadmap. Somebody else might have already opened it. You can +1 it. If you don't see it, open it. This is something that we look at quite frequently. If a feature on the roadmap is upvoted pretty highly, it's usually a good sign for us that it's something we should go build. And that's it. Thank you for coming. We have quite a full day ahead of different talks, and I hope you enjoy them. Thanks.
The first thing I do when I roll out of bed in the morning, again, say good morning to the team. Software Development Manager is an enabler. We enable our engineers to build, to use creativity, to prototype. My team started this thing of WFO. I have a yuzu tree, which is now dead. I have dill. I think a deer ate it. My name's Ellen Sue. I'm a software development manager at AWS.
Businesses are constantly looking for ways to optimize their usage within cost-effective budgets. With the broadest and deepest selection of compute instances in the cloud, AWS offers Amazon EC2 Spot instances to help you do more for less. Available at up to a 90% discount, Spot instances are spare EC2 capacity. They use the same infrastructure as on-demand instances, but can be reclaimed by EC2 with a 2-minute notification. This makes Spot instances a great fit with Kubernetes, a container orchestration framework. You can limit the impact of Spot interruptions by diversifying your nodes across EC2 instance families. Spot's compatibility with Kubernetes allows Kubernetes Cluster Autoscaler to direct EC2 autoscaling to automatically spin up a new instance when the current instance is being reclaimed. And when an interruption does occur, regardless if you are running self-managed Kubernetes or Kubernetes through AWS's Elastic Kubernetes service, the AWS Node Termination Handler will automatically drain and cordon the instance. Integrating your Kubernetes workloads with Spot instances means accelerating innovation at your workplace. Scale faster, lower your compute costs, and ultimately do more for less with Amazon EC2 Spot instances.
Hello, welcome back. Thank you, Alan and Mike, for the roadmap sessions. There are so many features that have come out in the last 6 months and are coming in the next 6 months that I just don't know how we fit it all in. Right now, we've been talking about EKS Anywhere in multiple sessions, and I want to have Vipin and Vignesh come on and join me because we're going to demo it. And I am I can't wait to see the demo and then hear, so we can tell everyone about what is EKS Anywhere, how did we get here, and what is it used for. So first of all, Vipin, hello. Tell me what you do at AWS and with EKS Anywhere.
Thanks, Justin. Hey, everyone. Thank you for joining our session on Amazon EKS Anywhere. My name is Vipin Mohan. I'm a product manager on the EKS Anywhere team.
And Vignesh, how about you?
Hey, hey all. This is Vignesh Gautam. I've been working as a software engineer for EKS Distro and EKS Anywhere for almost a year now.
Yeah, so if anyone doesn't know, EKS Anywhere launched in August, actually September. It was early September. It was a blur of a month. But early September it launched. It's an open source project, and let's dive right into it. I know, Vipin, you're going to tell us a little about the project itself, and Vignesh is going to do our first live demo of the day. So let's get started.
That's exciting. Cool. Yes. So the objective for today's session is to demonstrate, on-prem Kubernetes cluster creation and operation with Amazon EKS Anywhere. Like Justin mentioned, we just GA'd Amazon EKS Anywhere last month. So it's been about a month since the product has been GA. So in our session today, we will this is the agenda that we're going to cover. So we will talk about what are the customer pain points for Kubernetes on premises, and what is EKS Anywhere and how are we trying to solve some of those pain points. We then jump into a demo. So Vignesh has some exciting stuff to show around cluster creation and also the GitOps capabilities later on in today's session. We'll also talk about how you can get support for your EKS Anywhere clusters. And towards the end, I'll talk about the components that you get, the bundled components, as well as the prerequisites that you need for running EKS Anywhere. And we'll have some pointers for resources and community towards the end. So with that, let's jump in. So a number of our customers told us that they have existing investments in hardware that they want to leverage. So they have regulatory or governance requirements sometimes that define where they can actually deploy their Kubernetes workloads. Sometimes customers are looking to reduce costs, or they have a desire to use open source software and leverage all of the aspects of that stack on premises. There are also customers who have a need to run compute and Kubernetes on infrastructure that is closer to their data center and their end customers. Think of latency-sensitive applications wherein it's important for a customer to be closer to their end users so that they can deliver the best-in-class experience. So those are some of the use cases that we attempt to address with EKS Anywhere. And with EKS Anywhere, you get consistent and reliable on-premises Kubernetes operational tooling that's consistent with Amazon EKS in the cloud. So EKS Anywhere builds on the strengths of Amazon EKS distro and provides open source software that is up to date and patched. So you as a customer can get a reliable and secure Kubernetes environment on premises. Second thing is, you simplify on-premises Kubernetes management with Amazon EKS Anywhere. So we provide tooling for automating things like cluster management, cluster lifecycle management. And all of this is open source, and we will continue to maintain the project. So EKS Anywhere is built on the open source cluster API project, and it's not locking you into any proprietary technology. But we also include cluster lifecycle management tooling that allows customers to get a consistent operational experience with Kubernetes across different environments. We're also bundling some key components, things like a networking plugin, some operating system options, also a Flux controller for GitOps practices. And all of these help accelerate the readiness of your production clusters on premises. So right now, a lot of our customers have virtualized environments on premises, and they can use EKS Anywhere out of the box. But some of our customers have indicated that they actually also have bare metal environments. So our team is working on bringing support for EKS Anywhere for bare metal environments, in addition to the virtualized environments that we support. So we actually put together this chart to help you think about the different deployment options that we have across EKS on AWS. So Mike walked you through some of the roadmap items for EKS in the previous session. But the way to think about this slide is, towards the left, you have a customer managed option with Amazon EKS distro. So it's fully open source. It's the Kubernetes bits that we use for running EKS on the cloud. And with EKS distro, the customer manages everything, all the way from hardware, control plane, data plane, and when the support is with the community. Contrast that with the right-hand side of the slide, and you have Amazon EKS, wherein the hardware is managed by AWS. It's a managed control plane that you get. The data plane and security are a shared responsibility model, which Mike touched upon as well. And support is with AWS. So Amazon EKS Anywhere falls somewhere in between, and in the sense that it runs in your on-prem data center. So the customer owns and manages the hardware. With EKS Anywhere, you install the control plane, but then the management is with the customer. Same thing with the data plane as well. Support, you can sign up with AWS. We'll talk about that, and you can get support for your clusters. And security is a shared responsibility model. And what I mean by that is AWS will provide you with the tooling. For example, the security patches, the CVE fixes, all of that we will provide. But the actual act of operationalizing those and installing those patches is up to the customer. So that's a high-level overview of what EKS Anywhere is and why we built it. And Vignesh will now walk you through the cluster spec that we use for EKS Anywhere, as well as the cluster creation, a demo.
All right. Hey all, once again.
Yeah,
am I muted?
No, you're good. I'm just saying you need to make the screen a bit bigger. Text.
Oh, okay. But now. So EKS Anywhere is actually built in a way that it's actually a plugin to the EKS kettle command, so that we can use the existing EKS kettle command that we all use for our EKS clusters. So the first command that a user would want to run is EKS kettle anywhere generate the cluster config. So over here, let me just increase the font size a bit. So over here, so I'm running the generate cluster config command with a name for the cluster, and then I'm specifying the provider to the vSphere. So today EKS Anywhere supports the provider to vSphere. We have future providers in progress. So once we run this command, this basically generates a YAML file, which the user has to open up and edit. So let's take a look at an example YAML file, which I've pre-filled with some configuration, and we can talk over it. So the first section over here is the cluster definition, and this has all the cluster-wide configuration that we'll be using for the EKS-A cluster. So the first section over here is the networking section. So we've chosen our CNI to be Cilium over here. For now, EKS-A only supports CNI, the Cilium CNI. And then down below over here, we have configuration to provide in the CIDR blocks for both of our pods as well as services. Down below, after the networking section, we have the control plane configuration. So over here, we have the counts over here. It basically says how many nodes ends up being the control plane, the IP address for the control plane endpoints, and then we also have a reference to the machine group. So we'll just scroll down a little bit, take a peek at the machine group reference, just as an example. So over here, since the provider that we are using is a vSphere provider, the machine reference is actually a vSphere machine config. So you would see configuration which pertains to how a VM should be created for that particular node. So this basically has what the disk size should be, what's the folder structure that I have to create the VM in, like inside vSphere environment, what the memory should be, what the CPU counts is, what the resource pool is. The OS family over here specifies what host OS I should be using for these nodes. Today, EKS-A supports both BottleRocket as well as Ubuntu OS families. So down below,
just a question from the chat too about Windows support. There was a quick question I thought we'd bring in. You just mentioned that we support Ubuntu and BottleRocket right now.
Yeah. So for now, Ubuntu and BottleRocket are the only supported OSs. We do not support Windows at the moment. Yeah, and then we have a provision over here to specify in an SSH key, so that the user who's creating these nodes can, in the future SSH and do some operations over there. Going back to the section that we were above, so the next one after the control plane configuration is the data center reference. So similar to the control plane machine config, the data plane is going to have some configuration details which is specific to the particular vSphere data center. Stuff like what's the network that I should be using for my cluster, what's the server endpoint for my vCenter, what's the data center's name, if there's any thumbprint that I should be using, or if the connection should be an insecure or a secure one over there. So after that, we can talk a little bit about the external HCD configuration over here. So EKS supports both stacked as well as unstacked external HCD configuration. Our recommended option is to choose the external HCD configuration so that the HCD cluster itself is independent of the control plane. So over here, you have configurations for those, like the minimum count over here. Once again, a reference to the vSphere machine config, which basically has the same, the template to be using, the OS family and whatnot over there. The next field is Kubernetes versions. Today, EKS supports both 120 and 121 for the Kubernetes versions. Similar to the control plane node configurations, you have the vertical plane node configuration. Counts over there. The vSphere machine config references over there. So the next two fields are actually optional ones that we could use. So EKS supports a proxy configuration. There might be some environments where the cluster doesn't have, or the environment doesn't have access to the public internet. It has to be routed through a proxy endpoint. So we can specify those details configurations over here, both HTTP and HTTPS proxy endpoints, as well as no proxy. You could see that we support, CIDR blocks, IP addresses, as well as domains over here. GitOps ref, we can scroll all the way down and take a look at the GitOps configuration. Today for GitOps, we only support GitHub at the moment. We can specify both a personal repository as well as an organizational repository over here. We give it the name of the repository and the owner for the repository. So this is basically a GitHub ID. The repository here, if it doesn't exist, the EKS would generate a repository for you, create one, and then put all the configuration for the cluster in checked in over there, so that you can use it at a later time. So once this configuration is all filled up, you would technically run the EKS create cluster, supplying in this file as an input. So just as an example, I've run this before, so that I could.
Yeah. Let's make that font bigger. And just going through like the general workflow here, where a lot of people that run Kubernetes are used to, I create an application with a container, I create my YAML file to deploy that container, however it is, and then I have something running. In this case, we're doing that in EKS Anywhere at the cluster level. And this is pretty standard for how Cluster API is doing it, where we say, hey, we want to define this YAML describing our cluster. You went through all that, great, to show how many worker nodes, how many control plane nodes, where etcd is running, everything configuration we need for what OS. And then now we just say, okay, take that YAML and apply it, right? So like this is the same workflow, declarative workflow we get with Kubernetes for workloads. We do that at cluster level with EKS Anywhere.
Yeah, cool. That's right. So this is what an output would look like when you run the create cluster command. So I've run it with verbose logging over here, just so we can see what's happening behind the scenes. So it's validating the GitHub the PAT token, the personal access token, which enables the workflow to create repositories or clone it and check in repo, check in the code over there. So it's doing a bunch of pre-flights validation, hitting those vSphere endpoints, seeing if you have enough permissions, see if that folder structure exists, to see if that particular template for creating those nodes exist, and whatnot. And then in the end, yeah, it's creating a bootstrap cluster. It's creating all those control plane endpoints, those etcd nodes, as well as the worker nodes, and applying all those configurations as CRDs so that it can exist on the cluster itself. Yeah. And then at the last stage, we also delete the bootstrap cluster at the end.
And so walk through that as well. I know we have it in the documentation too. Bootstrap cluster comes up locally, creates my workload cluster, and then transitions all my controllers over to the workload cluster and says, okay, now you manage this. Here's all my CRDs. Here's all my configuration that I used. And then the cluster that's running locally on my laptop goes away, and everything at that point is self-managed in the cluster itself.
That's right. Yeah, all the CRDs get moved from the bootstrap cluster into the workload cluster, and you can manage your cluster using those CRDs and the controller running in your workload cluster from there on.
And I can manage that a couple of different ways, right? If I have the EKS Control Anywhere plugin or command line locally, I can still run commands against it. But also, I saw that you had the GitOps controller built into this cluster. So I'm assuming you want to show that off too, and just saying, hey, how do we actually modify and manage the cluster directly through a Git repo?
Yeah, that's coming a little later in the presentation, Justin.
So I might be jumping ahead.
Yeah.
So you're totally right. So you can use the CLI, which would again generate the bootstrap cluster, and then get all those CRDs, and then do the update or how you want to manage it, and then push those updated configurations back into the workload cluster. Or you could use the GitOps way as well, where you just look at the configuration file, make those edits over there, push those checked in code, and then it would the controller would react to those changes in your GitHub repository, and then apply those configuration on the workload cluster itself, all without the CLI.
Right, so you don't need the CLI at all. That controller pulls that down. That's sweet.
Yeah.
Cool. I must say, I love Justin's excitement here. So he's been very closely working with our EKS Anywhere team, and he knows all the ins and outs. And in fact, he wrote a launch blog and a bunch of other documentation as well. So super excited. So this slide over here is a visual description of the cluster creation workflow that Vignesh and Justin just talked about. So effectively, you create the cluster spec file, and by the way, the file that Vignesh went over, you don't have to create that from scratch. So there's a command in EKS Anywhere on EKS Anywhere that you can use to create a template, and then you can just edit some of the fields. So to create a cluster, you create that cluster specification file, and it includes all of your vSphere details as well as information about your EKS Anywhere cluster. And then you kick off that EKS Anywhere create cluster command. And the reason Vignesh didn't go through it is because it takes about like 5 to 10 minutes, and we're just waiting around for the cluster creation command to complete. But effectively what it does is it creates this temporary bootstrap cluster that you see on the left-hand side of your screen. And that's on the admin machine. And that's used to create the workload cluster in vSphere. And once that workload cluster is created, the cluster management resources are moved to your workload cluster, and the local bootstrap cluster gets deleted. And once your workload cluster is created, a kubeconfig file is stored on your admin machine with the RBAC admin permissions for the workload cluster. And essentially, you use that with kubectl to set up and deploy workloads. So there's documentation on all of this. We have pointers towards the end as to where you can find all of the documentation. But this is more like a visual interpretation. So just spending some time on just unpacking EKS Anywhere itself. So EKS Anywhere is a set of operational tools that we provide to customers to deploy EKS distro-based Kubernetes clusters in their own data center and hardware. So it's opinionated cluster creation and lifecycle management tooling that you get. And what that means is that there's nothing proprietary. It's all open source. So we use upstream Kubernetes bits, and all of the integrated and bundled software is all open source as well. But we are going to be opinionated in terms of what we provide and how you can configure those clusters. For example, with the operating system, Vignesh was talking about it. We have a couple options. The default is Bottle Rocket, and you can also use Ubuntu. For pod network policy and CNI, customers can use Cilium. Cilium is a scalable Kubernetes CNI. It's open source, and it allows you to transparently secure network connectivity between application services that are deployed using Linux container management platforms. There's also OIDC support. So with EKS Anywhere, you can create clusters that support API server OIDC authentication. And that means you can federate authentication through Active Directory locally or through Azure Active Directory. You can also leverage the IAM role for service accounts, or URSA, and that feature allows you to enable AWS authentication. We're also looking to integrate with other identity providers, so let us know. So through the open source project, I'll give you a pointer to where you can open issues and let us know. There's also GitOps tooling. We have a Flux controller that allows you to create and manage configurations by pushing a YAML file to a repo. And the unstacked etcd, I think Vignesh briefly touched upon that. So essentially what you get with this is that it's an external etcd topology, which decouples your control plane components and the etcd member. So let's say your control plane node fails for whatever reason. It could be a memory leak in a component like the Kube API server. It doesn't impact your etcd member, and that basically helps you restore the state of your cluster back quickly.
And this is also good for performance, right? I mean, if we're running what we're calling stacked etcd in this case, if it runs on the control plane, I have my Kubernetes API server, I have any parts that are critical for running the cluster and etcd on the same nodes. And if something starts hammering the API, etcd could run out of resources at that point, right? So this
exactly.
Good practice. I mean, if I was running an application anywhere, I wouldn't necessarily put the database on the web server, right? Like that's just not really standard practice for any sort of 3-tiered app. And separating out etcd into its own unstacked configuration with 3 separate VMs allows you to have full isolation, and etcd can consume all of the resources it needs on those machines for its own just database storing. And the API server and anything else in the control plane is only focused for all of its resources, serving, making sure the API is available and controllers there.
Exactly, yeah. And the last point was about a connectivity to the EKS console. So we have a session on EKS Connector that's coming up where you'll have more details about how you can use that.
Next,
yeah. So quick word on EKS distro. So EKS distro is what provides the version consistency across Amazon EKS on the cloud and with EKS Anywhere on-prem. So we open source the Kubernetes version that Amazon uses for running Amazon EKS in the cloud. So you get the same major, minor, and patch versions. And this is basically the distribution that powers EKS. And you get all of the security and operational reliability that you get with Amazon EKS on the cloud. And AWS does the same testing, certification, and building for getting these Kubernetes versions released. So I think now we get into the second piece of the demo that Justin was referring to. So what we'll do now is talk about a cluster upgrade using a CLI, as well as show you some GitOps practices using EKS Anywhere. So over to you, Vignesh.
Thanks, Vipin. So so what I'm gonna do is I'm gonna kick off the cluster upgrade process using the CLI. So down below in the window over here, I'm going to edit the YAML file that we saw before, where I'm going to go and bump up the Kubernetes version from 120 to 121. And then I'm going to run through the EKS kettle upgrade cluster command, supplying in this edited YAML file, as well as the kubeconfig to this particular cluster that we created in the step previous. So while that's running, just to explain what's going on in these windows over here, the above window is basically running a get pods on watch. And over here, we're running kubectl get KCP. KCP is actually short for kubeadm control plane. So KCP is one of the CRDs that we talked about a little earlier, which gets pushed and applied on the cluster itself so that the cluster could manage it on its own. Just below it, we have a get vSphere machines. vSphere machines, once again, a CRD definition for the custom resource. You could see that it's basically pointing to the 3 unstacked etcd nodes, as well as the 2 control plane nodes, as well as the 2 worker nodes. And then we are running a normal kubectl get nodes over here, which is describing the 2 control plane and the 2 worker nodes, and it also has the version pointing to 127 over there. So over on the left, there's like a sample application that's running on the worker nodes. In the logs that it's crawling over, you could see that it's basically doing those pre-flights validations that we were talking about a little earlier. It's going to stand up a bootstrap cluster. It's going to find the difference between the configuration that's on the cluster versus the one that was supplied in, and it's going to figure out that, hey, we want to upgrade this cluster version from 120 to 121. So at which point it's going to start the upgrade process. So over here, it's discovering that this is an existing cluster. So I'm going to get rid of the existing CRD so that they don't cause any confusion between the upgrade process. So it's getting rid of the CRDs, the vSphere machine CRDs, as well as the KCT CRDs, and then it's going to start the upgrade process where it's going to spin new nodes with the 121 version and start draining the old nodes with 120, which we will just speed through it and see it in a bit. So there was a 121 node that's already spun up, which is not ready. You can see the containers are getting spun up, like the Xilium, CNI, the kube proxy, the CSI nodes getting spun up over there. The nodes, the old node that's running 120 went to scheduling disabled, and it's going to get removed in a second over there. So this process is going to get repeated, for the worker nodes first, and then move on to the control plane. So at this point, you can see both the worker nodes are already upgraded to 121 version. So the next one would be to upgrade the control plane. Oh, there you go. So the control plane is to 121. It goes to not ready, and then when it becomes ready, it puts the old nodes to scheduling disabled and then drains it and then gets rid of the node. So once this all this is done, you would see that the new cluster API CRDs, like the vSphere machines, the KCP, would be moved back from the Bootstrap cluster that we created on our local machine into the cluster itself. So you see that the CRDs are getting created again with the updated configuration, so that the controller can start reconciling and match between the expected configuration and the state of the cluster itself. So this is the CLI upgrade process.
So I just want to walk through it again because I like the visual here of my running cluster had CRDs there that the CLI looked at and said, okay, I'm going to pull those into this local cluster I'm running so I can modify them, I can see what's going on. And then it actually, just like any sort of a deployment in Kubernetes, it does a rolling upgrade of my worker nodes, my control plane nodes, and then it pushes those CRDs back to be, again, just like it was before, self-managed cluster, controllers, everything in the workload cluster to be able to spin down the cluster on my laptop that was doing that work.
Yeah. So a quick note over there is it pauses the reconciling of the controllers over there on the workload cluster, and then gets rid of all those CRDs over there on the workload cluster, and then does the upgrade process, and then moves all of our CRDs back into the workload cluster, and then resumes those reconciliation process.
Right. I guess if you don't pause the controllers, you could end up in a really bad state when all your CRDs disappear.
Yeah.
Two quick questions here I can just bring up. Someone did ask about load balancer with EKS Anywhere, and to point out for anyone, like this is on-prem, completely managed in your environment. And so if you have an existing load balancer, it's Kubernetes. And so any sort of integrations that will work with Kubernetes, or if you have a F5 or there's plenty of hardware manufacturers that sell load balancers. If you're running one on-prem, there you go. In our docs, and thank you, Waleed, for sharing, we do have documentation on integrating kubevip if you want to run a load balancer, like a floating IP address within the cluster to be able to expose services. So I wanted to bring that up real quick because that is a question we often get. On-prem environments, not everyone always has a load balancer, and that's fine. At this point, EKS Anywhere is just giving you Kubernetes. Any existing ecosystem integration will still work with it if you have something, and then we just have some recommendation in our docs if you don't have anything.
Yeah. So the second part of the demo is where we try and scale up using the Flux, using GitOps. So over here, this is a live running cluster that we just upgraded in the previous demo. So just like the previous one, we are running a watch command on the get pods. The top right is actually showing the logs of the EKS controller. That's going to help us, look at the GitHub differences and then apply the new configuration. over here, we are running kubectl get machines, and then down below it's kubectl get nodes. So what we're going to do is, down in the bottom left over here, so we have this GitOps repo that our EKSA create cluster command generated for us. So if you open up the YAML file over here, you would see that it's basically the one that we gave in as an input. So what we want to do is go in and update the worker node count from 2 to 3. It's still in 120, so we might have to pull down the new configuration because we upgraded through our CLI. So let's pull that, and then you would see that 121 is already here. And we are just going and I'm going to scale up the worker nodes over here. And let's create a commit out of it. Increasing worker nodes. So let's push it. I'm not following best practices for Git over here, but just for demo purposes,
Vipin should review it. It's okay. We'll get through the actual full pull request.
Yeah. Yeah. So once it gets pushed, you would see in a second over here on the top right column, you see a bunch of logs scrolling down. You'd see that there's a new configuration that it should take a look into and try to apply that configuration and try to reconcile the current status of the cluster to match the one that just got applied. We're waiting for few seconds over there for that to get applied.
And again, just to say what's going on, you push this to GitHub. The GitHub repo is updated with that. You automatically merge it to master or whatever review process people have to get that merged.
Yeah.
The Flux controller, it's already deployed in cluster. There it goes. It says, hey, I'm just going to pull GitHub, see whenever this update comes in. As soon as I see something into master, the Flux controller is assuming Vipin reviewed it and did it correctly. I know I've approved some bad PRs. So this is you still have to have your own safeguards for how this is getting merged in. But the Flux controller says, okay, I see this main branch got changed. That is what I should merge the state of the world to. And it sees that you increase that worker node count. So the controller is then gonna update the CRD. Controller says, hey, 4 nodes or 2 nodes doesn't match 4 nodes, so I need to increase my node count.
Yeah, that's exactly what's happening. So you would see over here, the machine object just got updated to provisioning. It created a new machine object, which is in provisioning state. So it's going to wait for the controllers to go and spin up the actual node itself. Which actually just got spun up. It's not ready. Over here, pods are getting installed, like the CNI, the CSIs, the kube proxies. And then, yeah, there you go. There's a new node, which was brand new in 23 seconds, also running 121 cluster version.
In that case, this controller's, again, talking directly to vSphere APIs. And as Vipin mentioned earlier, we'll have more providers in the future. So if we want to do this on bare metal, if you want to do this with another provider, we have other options coming in the future, which will let you add nodes. I mean, in some cases, if this is bare metal, the controller doesn't open a PO to like order new hardware, but there'll be situations where you'll be able to add in Bootstrap and create a new node on bare metal or another option, not just vSphere.
Yeah, totally right.
Perfect. Yeah, so that's hopefully there's a good demo with cluster upgrade as well as like using GitOps to scale up your worker nodes. So just a note on GitOps. So essentially, we are using Flux, which is a tool that automatically ensures that the state of your cluster matches the config that is in Git. This is what Vignesh did when he put in the commit. The operator in the cluster actually triggered the deployment inside Kubernetes, which means that you don't need a separate CD tool. And it's the operator that makes GitOps happen in your cluster. And it ensures that your cluster config always matches whatever is there in Git. And the couple advantages and best practices with GitOps are that number one is you declaratively describe the entire state of your system in Git. So that means it includes all of the things like your apps, your config, dashboards, monitoring, everything. And the second thing is you really only push code, and everything is controlled through pull requests. So there's really no learning curve that's required for new developers on your team. and you just use the standard Git pull request process. So here's how we are thinking about GitOps to make your Kubernetes operations easy across on-prem and the cloud. And I believe Bob touched upon this earlier as well. So GitOps is going to be, it is an important aspect of EKS Anywhere, and we are starting to lean into that from an Amazon EKS perspective as well. And the whole intention is that customers will use their pipeline as a way to determine how the deployments will take place, rather than pushing everything to a central control plane. So basically, they push a YAML file and the config to a Git repo, and then the controllers that are running on both your EKS as well as EKS Anywhere clusters will change the clusters according to the changes that you make to your cluster spec. So a note on support. So we talked about the capabilities that we offer. So EKS Anywhere is open source, so it's going to remain open source, and we'll maintain the project. You can download it and use it for free. But if you, let's say, you want support for your production cluster, for example, so you can always reach out to AWS and get support. So AWS support for EKS Anywhere will broadly span two areas. One is the cluster control plane itself. So let's say in case you run into an issue with cluster creation, deletion, or configuration, for example, you can open a support case with AWS, and you will get support. The other is the third-party bundled tooling, things like BottleRocket or Ubuntu, Cilium, or Flux. You can, if you require any support for those bundled components, you can open a support case with AWS and get help. So that said, support is also going to be a shared responsibility model. And what I mean by that is, for example, the cluster upgrade operations will be owned by the customer. So we will provide the patches and the CVE fixes, but the actual operationalizing aspect is owned by the customer. Same thing with the application and code, as well as the physical server, storage, and network on premises. Any third-party tooling that you use, other than those bundled with EKS Anywhere, will also be owned by the customer. And for support for EKS Anywhere, the prerequisite is that customers already have an enterprise support plan with AWS, and customers can purchase a EKS Anywhere support subscription. Pricing is on a per cluster basis, so it's a flat fee, and there are two options right now. So either you can purchase an annual subscription per cluster for 1 year at $24,000, or let's say you would like a longer term commitment. So if you do a 3-year commitment, you get a discount, and support fee is $18,000 per cluster per year. We talked about the components throughout this talk today, but just want to quickly summarize. You get some operating systems that we are bundling. We're looking to add more options to that. So let us know if you have any specific requirements. Cluster lifecycle management, as well as scaling data and data plane upgrades. You get it through Flux right now. For CNI, we have Cilium, and then for GitOps, there's a Flux v2 controller. We have a session on EKS Connector coming up next. For storage, we are not really bundling a storage solution, but any compatible CSI, any compatible storage solution, either on-prem or cloud-based, as long as it has the compatible CSI driver, you should be fine with that. We also require VMware right now for your on-prem EKS Anywhere clusters, but we're soon going to add support for other deployment targets as well. Just want to make a quick special note of all of our partners that joined us for the EKS Anywhere launch. We had about 35 partners, and we're continuing to add to that list. And the AWS partner ecosystem for containers is a rich and broad ecosystem and can help augment your EKS Anywhere workloads. So we have partners who are providing capabilities across foundation, DevOps, monitoring and logging, security, networking, and even consulting services. So we have a bunch of our consulting partners who are part of our launch. So we are super excited, and we are continuing to add to this list. Some resources for you. So there's a link to the EKS Anywhere docs. I'm sure we'll share some of these with you after the session today. There's also the GitHub link where you can go and download EKS Anywhere and start using it. There's an FAQ page. So if you have any requests, feel free to open a GitHub issue. Let's say you want more bundled components, or you want support for something else. Open a GitHub issue. Our team is looking at that. I'm looking at that as well. So we'll definitely love to engage with you on GitHub. And we have a Slack channel on the Kubernetes Slack workspace. So feel free to take a quick screenshot of this slide, and we'd love to engage with you either on Slack or on GitHub. So I think we are almost there. And just to summarize today's talk, key takeaways are, we are super excited to let you know that EKS Anywhere is now GA. It's been GA for about a month now, and you get simplified installation and on-prem Kubernetes cluster operations. You can set up a highly available Kubernetes cluster control plane on-prem. And deployment is through Cluster API. It's open source. It's a Kubernetes open source standard. We also have integration with EKS Scuttle, which is consistent with whatever you're using today on EKS on the cloud. You get a bundled components as well as support for the control plane components and the bundled components from AWS. Reach out to us. And it's basically consistent control across on-prem and the cloud. So with that, I just want to say thank you for attending today's session and hope you enjoy the rest of your day. We have some exciting content coming up. And I'll hand it over to Justin. If there's any questions that we can answer.
And Vipin, don't leave yet. A couple things. Open source. I just wanted to reiterate that, where this isn't just EKS Anywhere is open source, right? Like that's the piece that integrates Cluster API. It integrates like the spec and everything. But below that, like you said, Bottle Rocket's open source. EKS Control is open source. Flux from Weaveworks is open source. Like the entire thing, is from the OS level all the way up to where we're integrating it, all the controllers that we're deploying, all open source. So it's not even just this tool is in there. It's like, no, the entire stack is. In your slide earlier about if you want EKS distro, which is just the binaries of Kubernetes that runs, you can run that yourself. We deploy those automatically, bundle them. If people need to modify their OVAs for something inside of vSphere, they can do that by building their own OVAs. And another thing that we didn't point out yet is there is the developer cluster locally, where you can actually just run in Docker. You can run all of EKS Anywhere locally in Docker. You don't need vSphere to try it out. So that's, if you have Docker installed on your laptop or a VM, go ahead and try that out. Like you can run it. It's not even something that you need any other sign up or access or accounts for. Pull down the bits and give it a try.
Absolutely.
And a couple things that I did see in comments as well. One, I saw a comment earlier about Raspberry Pi supports and ARM supports. I know it's not there yet, and Raspberry Pi support would require bare metal support.
Yeah.
But we get questions about Raspberry Pis and more of the hobbyist sort of like how to run this at home clusters. And so I know we are working on enabling, especially with bare metal, how we can get that available to people in the future so that they can try it out with less, less demand for resources necessarily in an entire environment that's like production ready. The other things that I wanted to pull in was monitoring. And because this is a shared security model, so how is monitor being addressed, and can it integrate with Container Insights? Container Insights is hosted inside of AWS. In this case, EKS Anywhere is a Kubernetes cluster that's running completely on your hardware in your environment.
Yeah.
So any monitoring agents will work,
customers
right?
don't even need an AWS account. So you could run it without an AWS account. So in which case, you may not have Container Insights. So that's why it's meant for like on-prem use cases, disconnected use cases.
Right. So if you have on-prem Elastic or you're shipping logs to Datadog or something like that, all of those integrations, because it is vanilla, it's just Kubernetes, those integrations will still work, but it is all running in your data center. So if you need like a direct connect or something else, depending on your network situation, that needs to be set up from your on-prem. And the last one I wanted to bring up, which Vignesh, you might be able to answer here, is can we do upgrades through GitOps? If I wanted to actually do the 120 to 121, is that available now? Is that coming? What's that story?
So so today we can't do that yet, but it's in the works. It's coming. Yeah.
Cool. Just wanted to make sure, like right now, the GitOps workflow has some limitations on what you can modify in cluster, and the CLI has other things that you can do with the Bootstrap cluster. So just wanted to set that as a level, like everyone understands. We're working on enabling as much as possible in GitOps workflow with Flux, and those will be coming soon. Right?
Awesome. Thanks, everyone.
Thank you, Vignesh. Thank you, Vipin. We're going to move
guys.
right into the EKS connector bits. we had talked about it a couple times already today, how you can connect a Kubernetes cluster running anywhere, any compliant Kubernetes cluster, into the EKS console and connecting it to EKS as a service. So we're going to bring in Lee Chun and Raphael. Hi, Lee Chun.
Hey, Justin.
Hey, Raphael.
Hello, how's it going?
It's going just fine. How about yourself?
Not too bad, thank you.
So, Lee Chun, tell me what you do at Amazon, what you've been working on.
Yeah, hi everyone. I am a product manager from the EKS team. I've been working on EKS Connector and actually EKS Anywhere.
How about you, Raphael?
Hey, so I'm one of the engineering managers here at EKS, and I've been working on the EKS Connector project for some time now, as long as I joined EKS in the beginning of the year. And I'm very happy to be here with you to share that project with you.
And I know EKS Connector launched last month, if anyone noticed the launch blog. Lee Chun, can you tell us a little about what it is and what it's for?
Yeah, so we actually entered the public preview with EKS Connector on the same day as EKS Anywhere GA. And however, the connector itself is a EKS Amazon EKS overall feature. Is a capability that you can use to help you connect just about any cluster, not just EKS Anywhere cluster, but any cluster running anywhere to the EKS Service Control Plane. More specifically, it's an agent that you can install on your cluster. As soon as you provide appropriate permissions to it, you're going to be able to see the cluster showing up on the EKS console side by side with your EKS cluster in the cloud.
So I have hosted EKS clusters running. I see them in the console. I have my Kind cluster running on my laptop, and I want to see it in EKS console, and I want to be able to use some of the EKS features with my Kind cluster. That's what EKS Connector is for?
Yep. You get it right.
That's pretty amazing. and what is it using for, how is it doing that connection? You mentioned it's an agent, but what else is involved? Do I need a VPN to Amazon? Is there something that I need to make that connection secure and available?
Yeah, so actually we will dive a lot deeper into, let's say, network requirements and all of that. But why don't I start with explaining how the connector works with a diagram? It would probably be easier if we start from the high level.
I love pictures.
So here I have a screen that I have shared. And let me know if everyone can see the screen.
You got the screen?
Great. So it's actually a two-step process. Let's say, you as platform operator, the first step is you will come to AWS, whether it is through the EKS console or our command line tools or EKS APIs. You start with a step that is registering the cluster. And as part of that, you would provide some basic metadata such as the cluster name. And after you initiate this registration intent, EKS is going to generate a manifest file for you to download. Now, as a second step, you would take this manifest file and go to your remote cluster. And this is outside the realm of AWS. You take the manifest file, go to your remote cluster, and just apply it through, whatever cluster change mechanics that you use today. Apply that manifest file. This application process itself is going to start pulling the connector image from ECR and finished automatically the connector installation, as well as some initial authentication with AWS. By the end of that, the connector itself would initiate and maintain a connection to AWS EKS, and from which point on, you would be able to see this cluster showing up on your console, see it show up in any API or command line query of list cluster right next to your EKS hosted cluster in the cloud. Now, you can connect one or more clusters to your AWS account, even in the same region. You just need to repeat this process each time for each new cluster you generate a new manifest file, apply correspond to the corresponding cluster, and you can do this, connect the cluster from your own on-premise data center and any colo, or you can connect a cluster from another cloud provider, or even let's say the self-managed Kubernetes clusters that you have deployed on EC2s in AWS today. So this is at a very high level how the connector works today. So
I'm assuming when I go register my cluster, I need some IAM permissions or something set up for the cluster to be able to connect back and do things within EKS, right?
You do. And now actually Raphael would be able to show you in action how those permissions should be specified, and then also put everything that you just see on this diagram in terms of the real console workflow. So I think we can switch to probably Raphael's desktop right now.
Sure.
And I love that manifest file that I get is just a Kubernetes manifest. I can deploy that through CI/CD. I can kube control apply it however I want. It's just I get an app essentially, and the controller or the connector in this point is to me just a YAML file. It's an app that I deploy. If I wanted to like roll that into whatever customize or tooling that I have to apply workloads, it's just a raw manifest file, and I can put that in the cluster, and then everything else at that point is taken care of by Kubernetes with the install and everything else.
Correct. Yeah, you're correct. We're basically using all Kubernetes native resources here, so we're not installing anything on your host, for example, on your nodes. So it's all native Kubernetes resources, as Lucia mentioned as well. So yeah, I'd love to go through a demo with you all, so you can get a sense on how easy it is to connect any Kubernetes cluster to Amazon EKS. So to try,
are you able to make the screen a little bigger?
I am not sure.
It's all right. If it's video, that's fine. We'll talk through it.
Yeah. Okay. Sounds good. Let me know if it's not visible. So to try out the EKS connector, all you need to have is an AWS account, of course, administrator permissions on the cluster you want to connect, and outbound connectivity to AWS Cloud. I'll talk more about the network part later. So I have recorded this demo just to speed up the process a little bit, and we could make sure we cover it all during the talk. Of course, I'm very happy to take other questions. So let's get started. So the first thing you need to do is to log into your AWS account using any user that have enough permissions to manage EKS and IAM resources. In this case, I'm using this user called Kubernetes admin. And for this demo, I'll connect a local KIME cluster running on my laptop. So the end state for this demo is to display this local cluster on Amazon EKS console and navigate through the resources just like you could do with any native EKS cluster. Before we get started with the registration itself, we need to create the necessary roles to make it work. So the first one is a service linked role. So this will enable Amazon EKS to manage other AWS resources on your behalf. So you can create using IAM console or any other client. For this demo, I'm using AWS CLI. So you should be able to see an output very similar to this one. It seems like it worked. So the second role, which is the role that will be assumed by the EKS connector agent running inside of your connected cluster, right? So this will be used to communicate back with AWS Cloud. So you can, again, create it using IAM console or CLI. And first, I created this policy document to associate with the role. So the permissions I'm associating with this policy enables the connector to talk back with the system manager service or the SSM service, which is actually the service that we use to establish this connection channel between AWS and the connector. So this policy will allow us to create a control and data channel to enable this communication. With this, the data flow for the request when you navigate through EKS console will go through EKS and SSM service until it finally hits the agent running inside of your cluster. So first, I'm creating the policy document, and then I will attach the policy document to the role we just created. So once you've got both roles created, you're basically good to go and move on to the fun part. Okay, very good. So to register any cluster to EKS, you can basically use any client, right? So you can use EKS Console or AWS CLI or EKS Kernel. For this demo, I'll use the EKS Console just because it's more visual. So you can go to EKS main page and click Register Cluster. First, you can provide a name to identify your cluster. In this case, I'm providing Container Day demo. And then you can select the provider where your cluster is running. So in this case, since it's a local kind cluster, I'll just select Other as the provider. Next, you can select the role which will be assumed by the agent running inside of your cluster. This is actually the role we just created, right? So it's a one-click process. There you go. So the first thing you're going to notice is that the cluster status is pending. This is because, as you mentioned, this is a two-step process. So the first step is to register cluster in the EKS API, and the second one is to actually complete the registration in your cluster. So you're going to notice that there's this warning message and a download button. So you have to download the manifest file, which contains all the resources required to install the EKS agent on your cluster. All the resources, they will live under a specific namespace called EKS Connector. And you can inspect all the resources there before you apply, of course. So you can use kubectl or any other mechanism to apply this manifest, for example, GitOps operator, right, as we just talked. So if you go back to the console and hit refresh, you're going to see that the cluster is now active, which is a good sign. It makes let you know that the cluster registration is over. And now the next thing you're going to notice is that a warning message saying your user doesn't have permissions to see the resources in the cluster. And this is actually expected because we rely on native Kubernetes authentication and authorization mechanisms to impersonate the user logged into the console. So to be able to navigate in the console and see the resources there, you need to create the cluster role and cluster role binding to map your AWS user to the role with necessary permissions to see those resources, right? So the IAM you're using to log into the console will be displayed on the warning message. So this is actually helpful to help you create and map the role to the right user. In case you're familiar, this is actually pretty similar to the way IAM Authenticator works today. So first, you need to grant permissions for the EKS connector to impersonate the user you're using to log into the console. In our documentation, we provide a sample manifest file so you can follow there. So just download the example from the documentation and inspect it. So before you apply, make sure you replace a variable called IAM_ARN with the IAM_ARN you're using to access the console. So as you can see there, this is going to be displayed on the warning message. However, in case you missed it, you can also use the AWS CLI to get the same information. So you can just use AWS CLI, STS, get caller identity. So once you get the IAM_ARN, make sure you replace in the cluster role manifest file before you apply. Once again, you can use any mechanism you want to apply, including GitOps. Right. So now the agent has enough permissions to impersonate the user. However, you need to make sure your user have the permissions you want to access the resources, right? So again, if you go back to our documentation, we provide another example in the documentation that you can download as a base manifest file and change the permissions as you wish. In this case, I'll create a cluster role with permissions that basically lets me see all the resources inside of the cluster. However, you can restrict to specific resources or maybe even specific namespaces depending on the use case. For this, we use regular Kubernetes RBAC system, so it should be something that you're already familiar with. Again, make sure you replace the IAM_ARN variable before you apply with the IAM_ARN you're using to log into the console. And then once you apply the cluster role binding, you should be able to go back to EKS console, hit refresh. And then the first time it loads, it will take a couple of seconds. And then you're going to be able to see all the workloads and the nodes running in your cluster anywhere. including your local cluster. There you go. So as I mentioned, since this is a local cluster, this is my desktop node. And then you can inspect that to see all the configurations, for example, the kernel version, the container runtime, the kubelet version, all the containers, pods, conditions, stats, labels, basically every single relevant information about your node. Also, you can navigate back to see the workloads running inside of your cluster, right? So you can see all the namespaces are there. Of course, this will depend on which permissions you got. And then you're going to be able to navigate through these resources. So for example, you can navigate inside of the EKS connector itself. So we're going to see the EKS connector has 2 pods, and each pod contains 2 containers. One is the connector agent, and the other one is the connector proxy. So the connector agent is actually the open source SSM agent running container mode. And the proxy is actually the bridge that will talk with your API server. So that's pretty much all I wanted to show for the demo.
And to bring up what you were mentioning earlier, if people aren't familiar with SSM, the session manager tunnel, it opens a secure TLS socket to AWS APIs and then tunnels all of your traffic through that. It's similar to, making a TLS connection to Amazon for any sort of API calls that you're doing. I noticed there was one question about SSM channel if it was using mutual TLS. And mutual TLS is a very specific implementation of both sides have a certificates. And in this case, AWS has a certificate. The traffic is still encrypted over that certificate channel, but it's not. Mutual TLS is like service to service. I need to tell everyone's identity. So SSM is using a WebSocket tunnel to traffic that information. But to the point of using SSM is you don't need VPN. You don't need a direct connect. You don't need something else to secure that traffic from my Kubernetes cluster anywhere, whether that's an anywhere cluster or a cluster that runs anywhere. If it's a compliant Kubernetes cluster, that tunnel can be created by an outbound connection without any other further networking requirements, correct?
Yeah, that's correct. So the communication will always be encrypted. You don't have to worry about that. And if you want to learn more about how SSM encrypts the connection and the socket, you can go to SSM documentation. In specific, we basically use the very same technology. So it's all there. And SSM agent is also open source, right? So you can go to their GitHub page to learn more about it.
And it's being used for a lot. It's more than just EKS connector. If anyone doesn't know as well, if you're using Session Manager to replace SSH on your EC2 hosts, you can use Session Manager for a lot of different ways to securely connect into Amazon, which is, I don't know if people that may not know that. It's something that is being used all over the place as a way to securely connect any environment, any network back into the AWS APIs through a tunnel. I did use it a lot at a previous job for replacing SSH, where I didn't need SSH keys, I didn't need users. We use SSM directly on EC2 instances that I didn't need a VPN or something to get into those EC2 instances. All I needed was my AWS credentials.
That is correct, yeah. And the technology is the same. However, what is particular to this use case is that we're using the SSM agent in the container mode, running as a container, as a pod inside of the cluster. So it actually doesn't have the same access that you usually have in the host itself, right? So it's a much more restricted access just to talk with the API server itself.
Right. So traditionally, I install the SSM agent on any machine, which if you're looking at other, like you can run SSM agent on your home lab and connect them back and then use that tunnel to get to machines anywhere. Traditionally, it's installed as an agent, systemd, something that runs on the box. In this case, because it's running in a Kubernetes cluster, like you mentioned, we have multiple pods, and one of those pods is that proxy that allows me to get back to a secure connection back into AWS.
Exactly, yeah, that's correct.
I also like how the IAM credentials are set up the exact same way that I would do any EKS cluster, where I have that basically mapping of my credentials to the console need to be able to see specific things in a cluster. So if you're working in a large environment, and only certain people can see certain clusters or specific namespaces within those clusters, you can isolate those things at the console level. And so it's not just anyone that can see the EKS console can see everything in every cluster, right? Teams, you can isolate by team and by cluster.
Yeah, and the nice thing that we're using a native Kubernetes RBAC system, right? So people that are already familiar with it don't have to learn a new thing. So actually, I can go through the authentication authorization piece in more details real quick. So first of all, since the connector is based on System Manager, the SSM agent will perform the authentication back to AWS, which we will assume the IAM role we created in the beginning of the demo, right? And this IAM role is informed in the register cluster API call. Once the EKS connector actually establishes the connection back to AWS, it will act as a proxy and forwards all the requests from the EKS console to the API server, right? So the EKS connector service account needs to have impersonation permissions to talk with your API server in the behalf of the user logged in the console. And of course, as you said, right, to define which resources the user actually have access to view in the console, you can use regular Kubernetes RBAC system to bind the necessary permissions to the cluster role object. You have to be mindful that the subject for the role binding is going to be the AWS IAM ARN, right, which is displayed on that warning message, or you can get by running AWS STS get caller identity. So on the IAM side, the very same IAM identity you're using to access the console needs to have permissions on EKS Access Kubernetes API in their policy. So these two together, the IAM permission and the RBAC permission together will have enough, will make the authentication authorization process goes through, so you have access to the resources.
Cool. Another question here from the chat. Thanks, Isaac. Legion, can you talk through some of the other benefits? I know we can see the console, the cluster, any cluster in the console. What's coming on the roadmap, and what else do we want to do with those once we've connected them to the EKS control plane?
Right. So this is, connector is just a beginning. You can connect the cluster and see it. But over time, EKS as overall, we're going to add more features that is bringing a operational consistency between the cluster that you run in the cloud, in AWS Cloud, and any connected clusters, including but not limited to EKS Anywhere cluster or any other cluster you connected through the connector. And these capabilities would range from config management, and we talk a lot about GitOps driven cluster config management in all the previous sessions. You can expect that to be something you should be able to use not just on EKS cluster in the cloud, but also on EKS Anywhere and possibly future connected cluster as well. And you can also expect, let's say, manage add-on. It should be something that is you can install on connected cluster in addition to EKS Cloud cluster. So over time, we will add more and more features such that you don't have to tell the difference between a cluster running in the cloud versus a connected external cluster.
At some point, you'll be able to manage those clusters, like you mentioned, manage add-ons through the EKS API, because those clusters are also connected back to that control plane.
Yep.
Awesome. And we haven't even mentioned, like, what does this cost? Like, what's the difference of, like, I need to run this, I need support, something has to be in there for how much this costs for running these clusters.
It's free. The feature right now is in public preview, and it's going to be free to just see the cluster show up on your console. And we think, that is something you get for free for most of the other features. So with the visibility, free of charge.
That sounds like a great feature to me. I mean, free is always a good feature.
And I actually has been monitoring some of the questions on online, and I believe there is a question related to networking. I'll let Rafael dive deeper into the specific networking question there. But one thing, question haven't been asked but related is regions. If your cluster is not running in a location that has an AWS region, actually you can still connect it to AWS because there's no direct dependency between a AWS region and the location of your cluster. But we really recommend you to pick a AWS region closest to your cluster location to minimize any network latency, which could cause UI lagging, for example. So if you have a cluster in Tokyo, technically you can connect it to US East region, but it would have been much better if you connect it to the AWS region in Tokyo. I know there's a question about, does the connection have to go through a private subnet, or maybe if you're running the cluster on-prem, do you have to open up a firewall port to let AWS reach into your cluster? But, Raphael, you want to comment on that?
Sure. Yeah, of course. So actually, the connection between the cluster in AWS requires only outbound connectivity from your location to AWS Cloud, because this connection is going to be established as a socket right from the agent to AWS Cloud. So EKS or AWS will never reach inside of your cluster and initiate a connection or a request, right? This will always go the other way around. And then once you navigate through the console, the EKS API will use this already established connection to navigate and call the agent and request for all the information. But this is always initiated by the user itself. EKS will never initiate any request to the agent.
And that goes directly to Isaac's other question here on, does it work with air-gap clusters? And in this case, you do need an active connection, at minimum an outbound connection available to go to the AWS APIs. So if you don't have internet connectivity to your clusters, that won't work. Do you know if this works with if I have a network proxy, can I go through a proxy and then do that connection?
Yeah, so proxies, they can introduce some latency, which could be potentially a problem, as Lichen said. But again, this doesn't have to be a public internet connection. So for example, if you have any private link to AWS, this should also work.
And how about, does this do anything for logging and auditing in the cluster? I know we're making a connection, we're seeing it in the console. Is there anything additional that this integration gets us?
So I would say EKS connector itself may or may not be in the implementation choice, but again, we will bring feature parity between what you could do on the in the cloud and any connected cluster. Logging and auditing is one of the key tasks that a lot of our customers would have to do on the cluster management. So it is something we will want to bring feature parity as well. We just don't want to, design how that should be implemented in this one session.
Yeah, and anyone with a Kubernetes cluster is free to still install the CloudWatch logging agent to send their logs to CloudWatch. That's not something that you need the connector for. That's not something that you can set that up in any cluster that is still just sending those logs. As long as you have IAM set up to be able to push those logs into CloudWatch logs, that's something available today with and without the connector.
Correct. Yeah, we intentionally didn't design the connector to be a single agent that do everything. Would be too powerful. So yeah, it's decoupled. You can install agents as you want and as you need.
And lastly, from a privacy standpoint, like what kind of data that we do send, one thing we want to make sure is we don't send or store any data that is not requested by you or authorized by you. So right now, the connector only will send data if you have initiated some action from the console or have called an API. For example, on the console, you see cluster configuration information, what paths or nodes are there. The connector will retrieve those information from the Kubernetes API and relay it back to AWS so we can display it for you. But we don't store those information, and the connector also don't volunteer those information. In the future, we might store something just to improve the UI optimization, but it won't be stored unless it is authorized by you.
Great. Anything else we want to talk about with the connector before we drop for a break? No?
I think we're good.
Pretty much it.
Thank you so much, Lichen. Thanks, Raphael. When we come back, we're going to shift a little bit from cluster management and then talking about CDKs and ACK, which are two open source projects for working with workloads inside of Kubernetes clusters. So stay tuned, about a 15-minute break, and then we'll be right back. Can you hear me? Are you muted? There you are.
Can we hear each other? Can
I
everybody
hear
hear
you.
us? Hey, then everybody can hear us.
Wonderful.
Yeah, welcome back.
Yeah,
Hope
welcome
everybody
back
had
to break.
a good quick break and that everybody's having an awesome event so far.
And I wanted to give a hand to the interpreters. This has been wonderful having you here. So thank you for joining. I'm trying to keep up watching it too and remember my ASL from college. So Jesse, what's next?
Next, we are going to bring Ellie in to talk about the CDKs project, to talk about what it is and what they've been working on. And we have some awesome announcements to make. Welcome,
Hi, everyone.
Ellie.
Hey, Jesse. Hey, Jesse. Hey, Justin. Hi, everyone. So really happy to be here to talk about CDKs. My name is Eli Polonsky. I'm a software development engineer at AWS, specifically working on the CDKs project, as you can imagine. And Jesse, do you want to, I have a bunch of slides. You can also kind of interject and, we can have a conversation about them, but do you want to share my screen? Right,
anyone
cool.
anyone in chat have questions about CDKs too? Feel free to ask. We'll we'll bring them in and talk about it.
Cool. So as you can see from the title, I didn't bury the lead. This will be the announcement of CDK's first major version, 1.0. And we'll talk a little bit about what that means and the enhancements we made. But let's first talk and see the whole agenda for this talk. So CDKs has been around for quite a while now. We've also talked about this at the previous Container Day. But I do always like to start these sessions with a quick overview on what CDKs actually is and why you should consider using it. We'll then move on to the main event, which is announcing the first major version. We'll see the enhancements we made towards this release and what exactly that means. Following that, we'll talk a little bit about CDKs with respect to the open source community and specifically the CNCF. And finally, we'll have a dedicated Q&A session kind of to wrap things up. Okay, so what is CDKs? Or instead of what, I prefer talking about the why. So let's talk about why CDKs. So why CDKs? Because authoring Kubernetes manifests can be a rather complicated task. CDKs aims to make authoring those manifests simpler and more robust. And how does it do that? It does that by leveraging general purpose programming languages and standard software engineering practices. So in general, we've been talking about, infrastructure as code for a few years now, and we're all trying to apply that daily. But to me, it seems like we haven't fully adopted it yet. We still create a lot of specialized domain-specific languages, which are awesome for, simple tasks, but to me always seem to fall short when our systems become more complex. We then create entire tool chains to maintain those DSLs, and in a way, kind of mimicking what has been around for a long time now, which is general purpose programming languages and the ecosystems around them. So let's dive a little deeper into why authoring Kubernetes manifests is hard, or at least harder than it can be. We know that manifests.
I honestly thought that you were going to turn YAML into an acronym of why authoring manifests. I was going with it. And I was like, this is amazing.
Oh my God, I didn't think of it. I will try it for next
time. This is key right here. That was gold.
Great, yeah.
I was reading it.
Good call. Okay, so let's talk about YAML, yet another markdown language. So we know that YAML is static, right? It doesn't allow for conditionals, variables, loops, in general, kind of control flows and enumerations. This promotes a lot of copy paste and makes manifests kind of error prone and very difficult to change. YAML is also hard to customize since there is no native way to pass inputs to it, right? There's also no native mechanism to publish and consume YAML manifests via some sort of central hub or central package manager. This makes them hard to share and fractures the ecosystem and kind of increases the copy paste throughout in a bigger scale. In addition, manifests are they introduce a fairly high cognitive load. Now, this isn't strictly unique to YAML. The load comes from the vast set of resources and properties that exist in the Kubernetes API. and the fact that sometimes those properties are purely mechanical. They don't necessarily align to the mental model of the users. Let's see an example that will hopefully make that clear. So here's a fairly common scenario for deploying an HTTP server and exposing it behind an ingress. Here are the resources that we need to define in our manifest in order to achieve that. So on the left side, we have a deployment that defines our container. In this case, I think it's an HTTP echo container. We have a service on the middle here to expose that deployment. And we have an ingress to register the service under. Now, this is already quite a bit of code or quite a bit of configuration, but also let's look at the more problematic and kind of error-prone parts of this manifest. So you can see that this app echo label here is repeated 3 times, right? So 2 times in the actual deployment resource, because that's how pod selection works. You need to define a pod template, and you need to label the deployment with that with those labels. And it's also repeated in the service because the service needs to know which pods to discover and which pods to serve. The container port is repeated twice because the service needs to know which ports to target. And the service port is also repeated twice because the ingress needs to know which service port to route to. Note that in this case, the container port and the service port are the same, but that doesn't have to be this way. And finally, the service name, echo service, is also repeated twice, once in the service, because every resource needs a name in Kubernetes, and once in the ingress, because the ingress needs to know which service to route to. So all in all, there's quite a bit to get wrong here, right? You need to make sure all those strings match, and you need to understand the mechanics of what exactly are pod templates and how do you apply label selectors and everything. Now let's talk about general purpose programming languages and how they can be used to address these issues. So general purpose programming languages, first of all, are dynamic, right? You can use all the variety of control flows and iteration capabilities they have to offer. This makes it easy to keep your manifest dry, i.e. following the don't repeat yourself principle, which we've seen is problematic with YAML and in general is considered kind of a 101 software engineering practice. Every programming language also has its own standard package managers. So we have built-in sharing and consumption mechanisms for the entire ecosystem. And to address the problem of cognitive load, which I mentioned is not strictly specific to YAML, we can also encounter it when we're using code. But with code, we can actually create abstractions, right? And because of the standard package managers, we can also share those abstractions and provide our users with a much more simplified API. So let's see an example, the same example actually, with CDKs, now in code using TypeScript. So we can see the same set of resources, right? We still have 3 resources. We still need a deployment, and we still need a service and an ingress. But now you can see that they're defined in code. Now, these resource APIs, the kube deployment, the kube service, and kube ingress, these are auto-generated by CDKs based on the open API specification of the Kubernetes resources. And you can generate them for any Kubernetes version. You can also generate them for custom resource definitions simply on demand. So the structure of this this program is basically the same. We create 3 resources, but since this is now code, we can very simply define constants, right? These are the same constants that we talked about that we're repeating all the time during the manifest, and we can just use them whenever we need to. And another cool feature of CDKs, and also this is just possible because this is code, and it's not like it's not super, it's not super high tech, right? Just the fact that we're migrating or transitioning to code opens up a lot of possibilities that seem simple and native, but are really powerful. So for example, CDKs will actually auto-generate Kubernetes resource names for you. Remember that those resource names are required, and they have to be unique across the entire manifest. So CDKs will actually take care of that for you. And you can use those auto-generated names in your manifest when you need to reference them. So for example, here, instead of repeating the service name, we can just assign the service to a constant and then access the name property for that service anywhere we want. And you can imagine how easy it would be to combine this code into reusable components, right? This is just simple class composition, and then share it and publish it through standard package managers. And this composition is also how we create API abstractions and address the problem of cognitive load. Okay, so CDK itself offers a set of API abstractions called CDK Plus. And let's see an example. Let's see the same example actually using these abstractions that we offer as part of the tool.
So as we transition there, Ellie, so basically the way I see this is exactly how you just laid it out. So we're taking the conceptual knowledge that we have of Kubernetes, which we don't get for free, right? There's no magic here. You have to still understand what you're doing.
Yeah.
But you're shifting from working with YAML, which is not inherently a programming construct or programming language that like lends itself to programming constructs.
There's a big debate. There's a big debate on that, right?
Well, I didn't say it's not a programming language. I was like, wait, maybe I did. So I didn't mean that. But you can actually encapsulate those same concepts in these more modular pieces of code, and then actually import them, extend them, which I think is the real magic here, right?
Exactly. And I want to also emphasize that we've heard people and our customers and users talk about the fact that code is great and abstractions are great, but the flip side of an abstraction, right, is that it kind of it hides certain things from you, and sometimes people want to have the full control over their underlying infrastructure. So the example we saw before, let me just go back for a sec here. So this thing, you can see that the API that this exposes is exactly the same as the YAML one, right? So you don't actually lose anything here. You can still define every single property and resource you want, but you can just do it simpler with code. CDK Plus, however, does hide a few things away from you. We'll see that in a bit. And that does mean that you have to kind of, and again, it hides those things, but it doesn't, someone needs to take care of all that complexity, right? So it's either you, the user, or it's the library. And when you use those abstractions, you kind of take a leap of faith, or there's a lot of trust involved here that the library will do the right thing. So these are the kind of pros and cons. But let's look at the CDK Plus example, and let's just talk a little bit about what CDK Plus is. So CDK Plus offers.
Ellie, I just want to mention like what Jesse was saying too. I know a lot of people, YAML, like you're learning the API, you're learning what Kubernetes API is, and for me, I remember my very first, I wrote the YAML file. I was like, oh, I deployed it. That was amazing. And then I was like, oh, I want to reuse this. And I just put like environment variables in there. And I use like env substitute and just like bash curl it into like Kubernetes.
That might be what I still do. Like I might still do that quite a lot, just saying. And I might wrap it up and make files because I'm that terrible a person. Yeah, okay.
You're not alone here. I used to do this a lot. Not just with Kubernetes manifests. Every single configuration file that I ever had basically turned into some sort of templating.
Right, and that's how like the Kubernetes ecosystem has grown from that. Where originally it was static manifest, but your point early on, there is no Kubernetes manifest hub. Like I can't go like just download someone else's stuff. Like I need to template that somehow. And like beyond that is essentially what Helm is doing, right? We have Go templating in Helm. I've written plenty of Helm charts in my time, which is essentially the same thing. It's just instead of the pretty inflexible environment substitute command, I'm using Go and templates that can do things like same defaults, and I don't need to export everything as like an environment variable. I can get a file and it merges. Like there's some benefits there of Helm. I can reuse a template from someone. Those get published. There is a Helm repository for those things where I can just take all those substitutions. I know what values I want and then deploy those things as well. And CDK is different, where we're not just wrapping the YAML with new ways to substitute values. We're taking a programming language with all the tooling of that language. If you're using, Python, you can do tests. And then we're generating YAML from that. And so we're taking a code first approach to generate the YAML versus replace a bunch of variables in something that is static.
Exactly. I couldn't have said it better. Definitely. I think that the tools like Helm do a great job with this, but again, there's an entire toolchain around them, right? There's for programming language, we already know this stuff. We already know how to publish packages and how to consume them and how to declare dependencies and how to import them. So this is kind of what we've been doing all along. So why not do it also with these infrastructure needs? And we've been talking about infrastructure as code, and let's start talking about infrastructure is code, right? And if infrastructure is code, then let's use code to define it.
Right.
And I think
one quick question just from the chat here about CDK versus Helm. And CDK is the cloud development kit from Amazon. So if you're used to using Terraform or CloudFormation to create AWS resources, the CDK allows you to do that with code exactly the same way that CDK is doing that with Manifest, YAML Manifest. So you're doing the same process, different sort of resources and APIs you're dealing with.
Exactly. And actually the CDK for Kubernetes was kind of born from our experience with the AWS CDK, and it uses the same underlying technologies, whether it's the construct programming model or JSII to do the transliteration for programming languages. So it's definitely in the same domain. But yeah, CDK is specific to AWS resources. CDK is about authoring Kubernetes manifests. Okay, so let's take a look at this example, right? So this is the same thing. This is the same exact manifest that we defined before, but all we need to do here is we define a deployment resource. We don't necessarily know how the deployment resource is structured, but what we do know is that we want that deployment to deploy a container. That is our intent, and that's why we commonly refer to CDKs plus APIs as intent-based. So we interpret the user's intent, and then we perform the underlying mechanics that we need in order to make that happen. So here we create a deployment, we define a container, we then expose that deployment via service using semantic APIs, right? This expose via service method is exactly kind of the semantic that I'm targeting. And it's very similar. It's actually the same as running kubectl expose. And then we use that service and we define an ingress rule using that service. So these 10 lines of codes will generate the exact same manifest, but in a much more concise and intent manner. Okay, so now we can finally define kind of what CDKs is, right? CDKs is an open source multi-language software development kit for modeling Kubernetes resources as reusable components. So it lets you employ standard software engineering practices, cut and copy paste, and go from code to config that can run anywhere. And that's an important point that we've had a few of our customers mention, that CDKs will generate pure Kubernetes manifests. They're not in any way tied to Amazon EKS or any other provider, right? They generate the manifest, and we actually, as CDKs, intentionally don't handle the deployment aspect of it. We're an authoring tool, right? So we help you author the manifest, and from that point onward, you can take it and deploy it, whether it's kubectl or GitOps or whatever other way you see fit on any cluster. And CDK currently supports Python, JavaScript, TypeScript, and Java, and Golang is coming soon. Okay, so this is the main event. Yeah, woo! So CDK finally gets its first major version. I'm really happy to announce that. We know that it's not easy to fully adopt a tool before it has those compatibility support that comes with a major version, especially with big enterprise or projects that require a lot of infrastructure. So let's see exactly what this means and what are the enhancements we made with this release. So first, let's talk about the CDK CLI. So the CLI has three main commands. So it has CDK init, which kind of creates the scaffolding for your CDK project. This is just a normal idiomatic project based on your preferred programming language. It just helps you get started. Then there's CDK import, which is what I mentioned before. It's the command that actually auto-generates code bindings based on API specification, whether it's the core Kubernetes resources or custom resource definitions.
So and the third one, you can import a CRD. Any CRD you can import, you get that spec automatically, and then you can build your CDK, your code to generate the YAML.
Exactly. You get the bindings for that CRD, you initialize it, you pass your inputs, and then you synthesize and get your manifest. So, and then the CDK synth command is what actually produces the final manifest. Now, this is a CLI command, but you can also do this programmatically if you want using the CDK's API. So starting with this release, all of this functionality and API will remain stable, at least until the next major version, right? Okay, so CDK's core is the second component, is the foundational API that everything else is kind of built upon. It was a silent participant in our slides, but it's actually very important. So this isn't the generated code bindings, right? The generated code bindings are on-demand code that we generate. This CDK's core API is lower level and actually is used for a few features. And one of them, we've seen one of them, which is the auto generation of Kubernetes resource names, right? This is something that the core API does. There's also Helm support, escape hatching, resource dependencies, a bunch of these stuff that's needed to orchestrate your manifest, but that's not tied to a specific resource. So again, this also gets the 1.0 mark, and all its APIs are expected to be stable going forward. Now, what about CDK's Plus? So CDK's Plus, we decided to keep these APIs right now in beta a little while longer, as we gather more feedback from the community. Like I mentioned before, these APIs are the abstraction layer, right? And with any abstraction, it requires from the user kind of a delegation of trust, and trust needs to be earned. So we wanna bake these APIs a little while longer, work with the community, and make sure that we're covering our bases here. Having said that, we totally intend on graduating CDK's Plus in the near-term roadmap. This is very important to us, and we're very eager for any community feedback here. It'll make this process a lot faster. Okay, so let's talk a little bit about some enhancements we made. So I said a few slides back that Golang is coming soon. Well, here it is. I think that was the fastest release ever, 30 seconds or something. So Golang is now officially supported with CDKs. It has been by far our most asked for language. We acknowledge, the prominent role Golang plays, and especially in the Kubernetes and the container community. So Go developers can now use this awesome language to define both their application code as well as any Kubernetes infrastructure needs. Special shout out goes to the maintainers of the JSII project, which makes this all possible. I mentioned this before. This is the underlying technology that also powers the multi-language support for the AWS CDK, and actually for the CDK for Terraform as well. Note that Golang support in JSI is still in developer preview. You can track the support for Golang in the JSI repo. Okay, so CDK's Plus for multiple Kubernetes versions. This is also something that we decided to add with this release. Even though we're not graduating CDK's Plus, we are paying attention to it. And one very common thing that we've been trying to deal with is how do we support CDK's Plus for multiple Kubernetes versions? The lower level APIs, the ones that are auto-generated, that's not a problem, right? Because those APIs are just generated on demand. You can specify which Kubernetes version you want, and CDKs will generate the code bindings for that version. But CDKs Plus APIs are handcrafted. Like, we write them, right? The community writes them. And when we write them, we need to be aware of which Kubernetes version we're targeting. So let's see what kind of problems that will arise, and that'll give you a better understanding of the solution we decided to take here. So this is the code we saw before, right? This is the CDKs Plus code that defines our manifest. When we were writing this code, we, as me, as a user, as a consumer, I was operating, let's say, Kubernetes version 1.21. And we were using the V1 beta 1 version of the Ingress resource, right? Because in that Kubernetes version, that resource exists. So what happens now if I decide to upgrade my Kubernetes version to 122 and I synthesize the same CDKs application and I get the same manifest? Well, for those of you keeping up with Kubernetes releases, the Ingress resource has actually graduated to stable a few versions back. And in 122, the V1 beta 1 version of the ingress resource no longer exists. So this means that if we try to deploy the same manifest on our new Kubernetes version, it'll fail. So we definitely need to perform some sort of code change here. And that makes sense because Kubernetes, according to their SLA, did a breaking change of sort. So from our perspective as CDK plus authors and maintainers, one option would be to simply replace the Ingress v1 beta 1 resource with the stable version, and let it compile. That's not a good option, right? Because that means that we're performing a breaking change here. We're performing a breaking change, and we're also making the library basically unusable for users who still want to use the v1 beta 1 resource for their own reasons. Another option would be to add a new stable ingress resource to the same library so that we'll have both v1 beta 1 and the new stable resource, and then users can choose to migrate whenever they want to. The problem with that is that now CDK Plus will expose two different versions of the ingress resource. And depending on what Kubernetes version you're actually targeting, both of them may fail at some scenarios. That's not a good experience. One of the main goals or tenets of CDK Plus is that if your program compiles, then it should also deploy. And definitely if your program synthesizes, then it should also deploy. So we don't want to expose users to any capabilities that they might discover are not available in their target cluster. So does that make sense? Okay, let's see. Oops, sorry. Let's see what did we decide to do here. So the solution we came up with is actually to vend a different version of CDK Plus for every Kubernetes version out there, right? So instead of using CDK, so before we used to use CDK Plus 21, and now we're using CDK Plus 22. And notice what happened when we upgraded this dependency, right? And remember, we're in code. All we do is upgrade a dependency in our package JSON file or something. When this dependency was upgraded, suddenly we get a compile time error because that resource is not available anymore. And this is great. This is exactly what I wanted to happen because I'm now aware of the Kubernetes change, and I don't even have to deploy and get an error to see what I need to fix. So I know that all I need to do is change from the Ingress v1 beta 1 to the stable Ingress resource, right? And in CDK Plus 22, that Ingress resource is available. And in CDK 21, the earlier version is available. So users can choose which CDK Plus version or which CDK Plus package to use based on their target Kubernetes version. Let's see an example here of something even cooler, I think. So this is the same code, right? This is the same code as, it produces the same manifest, but in a simpler way. And notice that here, all we do is create a deployment, and then we call the expose via ingress method. That's it, right? And this method is a representation of our intent. Remember, all we wanted to do in the beginning was create a container and expose it with a specific path, right? That's it. So when we do that, when we switch over to 122, we actually don't have to do anything because we didn't actually use the ingress resource. It was created for us by CDK Plus, and it will continue to do so, but with the correct resource. So when we change from CDK Plus 21 to 22, we actually bypass this breaking change altogether, and we don't need to perform any changes to our manifest. So
at that point, the important thing is to match your library, whatever version of CDK Plus you're importing, with the version of the cluster you're going to deploy to, right?
Yeah,
so you don't have to change the code, but you have to change the library to say, oh,
exactly.
The cluster,
you still have to change. Yeah, you still have to change the dependency, but that's it.
Yeah.
And if that's not it, then the compiler will tell you.
Right.
So CDK Plus will be maintained for the 3 latest versions of Kubernetes. As of now, these are 22, 21, and 20. It's a little hard to kind of grasp. We have an FAQ. What are the differences between them? When you should use each one? So make sure you check that out. Okay, let's talk a little bit about the community. So CDK has been developed as an open source project from day one, right? It was really important for us to form a community and get community feedback, because this is the shaping of these APIs really need to be, battle tested. And we're actually continuing our open source engagement by coordinating with the CNCF, which I want to talk a little bit more about. So CNCF, our journey kind of with CNCF, we released CDKs as part of AWS Labs. We were then accepted to the CNCF sandbox and moved CDKs to a dedicated CDKs team organization. We also recently completed CNCF onboarding, which is a bunch of boring logistical stuff. But the reason I mention it is because we're highly engaged with it, and we're really looking forward to continue working with the CNCF as far as developing an open governance model and gearing up towards incubation and moving forward. All right, so that's it. I think we have some time for Q&A. I'm not sure.
We are almost out of time for this session. There was one very relevant and also great transition into the next talk from AK here.
This is perfect.
Right, can you combine CDK and CDK? So CDK, the cloud development kits, I want to provision AWS resources. CDKs, I want to use those resources inside of my Kubernetes cluster.
This is perfect. Yeah, we actually have a native integration for the AWS CDK with CDKs. You can define an application that depends on both of them. You can use CDKs to author your Kubernetes manifest, and you can use the provisioning capabilities of the AWS CDK to deploy an EKS container and then apply your manifests to it. I'll be happy to share some more resources with that. I actually did a reInvent talk last year around this specific area and kind of showing how that can be done. But yeah, definitely good question and a good use case, super possible and super intentional by us.
And to the point of, doing it in the CDKs combination all in code is a great way to combine those resources. Our next session about ACK actually addresses that in like a slightly different model, where if you want to manage the state of those resources directly inside of Kubernetes with controllers, you can do that with the ACK. So we're going to talk about that piece just next. I think that was most of the questions. Oh, one other question I saw come in, unit testing, because that is one of the big benefits of doing.
Oh yeah. Yeah, excellent question. So we do have some facilities for unit testing, mainly in TypeScript at the moment, but we are actually working on providing an assertions library for all the supported languages. This is also kind of tied with the work we're doing with the AWS CDK around this matter. So definitely unit testing is in our roadmap, and you can also see examples kind of in our repo. How do we unit test our own manifests? So definitely we're planning on enhancing that capability.
Cool. Thank you, Ellie. Thanks so much. And congratulations to you and the team on 1.0.
Thank you.
Awesome. And yeah, next we're going to bring in, we're going to do it live. We're going to transition to the next session. And now we're going to bring in Amin and Jay to talk about ACK, or the AWS Controllers for Kubernetes project. Welcome. How you doing? All right.
I'm doing great. Thanks.
A little latency there, Jay. A little latency. Yeah, welcome to the stream.
Sorry about that. I should probably share my screens. I have a, let's see here. Sorry. I have some slides. Whoops. Can you all see my slides?
No, we can't. And like I said, we're doing it live.
Okay, then. Oh, well, that would help if I did that properly. How about now?
If you share it, then we can
yes.
see it. And now
yes.
you won the internet, basically. There you go.
Hey, thanks, Jesse.
All right.
So, yeah, thanks. So, hi, I'm Jay Pipes. Amin Hilali is also an ACK software developer. And today we're going to give you a little bit of an update on what's been going on in the ACK project or projects over the last 6 months or so. And Amin is going to live demo 3 separate ACK controllers doing their magic and communicating with AWS APIs to manage the lifecycle of AWS resources. So I'm actually really excited about this. I've been excited all day. I've actually been watching the Twitch stream, and I'm in there moderating for a time. So I'm super excited about this. Let me get started. But before we get started, I did want to give a big shout out to all the contributors, the open source contributors, internal to AWS, external to AWS, and all our partners. Thank you so much. I think we're like past 1,600 stars or something on GitHub, which is crazy. Absolutely awesome. We have like over 50 contributors to the various ACK projects. We're collaborating with Crossplane and Red Hat, and we're just super excited for all those contributions. So thank you from the bottom of my heart. I appreciate it. You're what makes ACK ACK. So, all right, ACK in 30 seconds, or maybe 60 seconds, we'll see. So what is ACK all about? Basically, it just allows you to manage AWS resources using the Kubernetes API. So instead of logging into the AWS console or using the AWS CLI to create resources or update a resource, instead you simply do kubectl apply and communicate with the Kubernetes API. And there's a set of ACK service controllers that actually communicate with the AWS service APIs for you and manage the lifecycle of resources in your target accounts. We make heavy use of code generation in ACK. So those of you who kind of saw my previous spiel about ACK at other KubeCons or reInvent, you know that, well, there's only a few of us on the core ACK team that are working on all of these different service controllers in ACK land. So there's really no way that we were going to be able to maintain and manage the construction of hundreds of these ACK service controllers without really relying on code generation quite a bit. So we actually take the AWS service API models and we actually output the full implementation of these service controllers. I'll get to that a little bit more later. One thing that makes us a little bit different than some other approaches, we speak directly to the AWS service APIs. So we actually don't go through CloudFormation. We don't construct a CloudFormation stack and use the CloudFormation API in order to track state of the resources within a stack or anything like that. Instead, we talk directly to S3 and RDS and IAM and EC2. And in that way, we're a little bit different than some of the other solutions out there. One other really important thing to mention, we run on any Kubernetes cluster. So even if you don't choose to use the EKS managed control plane and all that, you can use and install an ACK service controller in any Kubernetes cluster in GKE or Azure or running on Kind locally. It doesn't matter to us. We're just a set of normal pods and deployments that you install into any Kubernetes cluster. And yeah, that's what we're about. Also, we're 100% open source and use an open development model. We have community Zoom meetings every week. All of our stuff is done on GitHub in the github.com AWS Controllers Kate's organization. And yeah, we're really excited to get feedback and bug reports and all that kind of stuff from you. So like I mentioned, code generation is something we rely on heavily in ACK. We consume the API model files that are, right now, we take them from the AWS SDK Go repository. There's a set of model definitions within the models APIs directory in that source code repository. But we consume those in a tool called ACK Generate. And the ACK Generate tool outputs a set of generated code. Now, we can output an ACK service controller for a specific service. So for instance, if I use the ACK generate controller command, I can generate the controller for S3 by reading in the S3 API model. We can also, because our code generator is quite flexible, we can actually generate the cross-plane provider AWS resource managers for a particular API. So the ACK generate CLI tool is pretty flexible, takes in these API models, and spits out a bunch of Go code that follows either the ACK runtime or the cross-plane provider system. And what is the end user experience that we want? Well, we want this end user experience. We want Alice or Bob or any other Kubernetes user to just be able to do kubectl-apply, pass in a YAML manifest. I know that's going to hurt Ellie because he doesn't like YAML, but it's okay. Like ACK is all about the YAML, right? So you're just going to kubectl-apply and pipe in a YAML manifest that describes the AWS resource that you want to create or update. And the ACK controller for that particular service, in this case ECR, will take the custom resource that you've applied to Kubernetes and speak to the AWS ECR API to manage the creation and update of your particular repository. So this is the end user experience that we want ACK controllers to provide.
I'm just going to throw out there, Jay. I think that these two projects are completely compatible, right? Because you're gonna create YAML, and he can actually leverage that.
He can synthesize YAML.
So it's amazing. It's amazing that you can actually build really cool pipelines here for in CI. Yeah. So anyway, it's cool.
No, I completely agree, and I was mostly just joshing with Ellie.
Yeah, I know.
Any solution which synthesizes to YAML manifest, which obviously CDK does, it integrates fully with our user experience, which is really just the Kubernetes API. So CDK is all about the Kubernetes API. So it's good synthesis. Okay, one big feature that ACK has is cross-account resource management. So we've had this feature for a while, and it's actually been demoed by Amin a number of times to customers and others. It makes the experience of running ACK controllers a little less painful, put it that way. If you are a customer or a Kubernetes user that has lots of different AWS accounts. Let's say you work at a big company, you've got 100 different application development teams, all working on different microservices. You can use a single installation of an ACK service controller to manage resources for that particular service across all of those 100 AWS accounts. You don't need to install one ACK service controller for S3 in 100 different clusters or locations. Instead, you just have the one ACK service controller, and then you annotate a namespace in Kubernetes. A cluster admin would annotate a namespace with the AWS account ID that all custom resources of a particular kind within that namespace should be managed in that AWS account. So in that way, it cuts down on the number of controllers that you need to install in your target clusters. We also support resource adoption. So let's say you've got some existing resource that you want to ask an ACK service controller to take under its own management. Well, we support this resource adoption functionality. And one thing that makes this special in ACK is that it is an explicit action, right? And when I say it's an explicit action, I mean there is a separate, distinct custom resource definition called adopted resource. And you actually have to create that adopted resource and explicitly tell the ACK service controller, hey, I want you to take this particular resource under management. And this is a little bit different than other solutions that have taken an approach where you sort of have an annotation on a custom resource that indicates that, hey, this thing already exists or not. We took a slightly different approach that we thought was a little safer and a little more manageable to do this explicit, distinct CRD for adopted resources. Okay, so we've got some news about progress that we've had over the last 6 months. Well, not 6 to 9 months in the ACK project. We've had a lot of changes, right? One of the big ones is we have a new GitHub organization, github.com/AWS-controllers-K8S. We have separated our mono source repo that used to be just called AWS/AWS Controllers K8s into lots of sub repos, a community repo for all the documentation, a repository for the code generator, a repository for the common runtime, a repository for all our test infrastructure. And I think we're up to like 16 or 17 separate service controller source code repositories where each of the individual ACK service controllers now lives. So that was a huge thing where we separated out our monorepo and now have these separate source control repositories. In addition to the separate source control repositories, we're now also publishing separate binaries for each of the service controllers and separate Helm charts in individual ECR public repositories. We've got a brand new Hugo-based documentation site, thanks to Nick Thompson. Yes, it's awesome. I'll show you in a second. We've also got another, thanks to Nick Thompson, generated CRD reference documentation on our doc site. Let me show you a little bit. We've got this new GitHub organization that lists all of our repositories. There's lots of them there. Please come contribute. I will note that the GitHub issues are only enabled on the community repo. So if you have a bug or a feature request or something, please go to that community repo. This is our ECR public AWS Controllers Kate's gallery. So you see here we've got 32 separate chart and controller ECR repositories. And this is our new documentation site that Nick helped put together. It's all nice and snazzy and well and lovely formatting. I love it. Anyway, and then we've got this reference documentation for the custom resource definitions that each of our ACK service controllers expose. So here you see the Aurora DB cluster resource and the RDS controller. And you see like the fields that go into the spec. All right, I did mention that we have a lot of ACK service controllers. I think are up to 17 at this point in varying stages. So they kind of keep multiplying. We're onboarding more and more AWS service teams into the ACK ecosystem, and those AWS service teams and engineers on those teams are helping to maintain and own their individual service controllers, which is great. So what do we have in preview right now? We have a preview and a GA maintenance phase, and that really just describes the maintaining teams' confidence in the long-running stability of their particular controller. We've got preview for Amazon MQ, application autoscaling, API Gateway v2, DynamoDB, ECR, EC2. Now EC2, we've got, I think 4 resource managers now, maybe 5. I think Brian was working on VPC endpoint yesterday. We've got security groups coming and a number of other core EC2 networking concepts, constructs, new resource managers coming out every week for the EC2 controller. Elasticache, KMS, RDS, S3, SageMaker, SNS, and step functions. All of these controllers are in preview right now. I have Elasticache and SageMaker highlighted in green because they are quite close to going generally available. And then we also have 4 controllers that are currently in progress. The EKS controller is going to be very Inception-like. It's kind of like MC Escher as a service. We've got the work started on the IAM controller. That is our #1 most requested controller outside of EC2. So support for declaratively binding IAM roles and policies, that kind of thing. That's going to be awesome with the IAM controller. Lambda, which actually is in progress right now, and Amin is going to be showing you that in progress controller, and it's actually working. So, and then also SQS, we are currently in progress working. So, all that said, we are now going to hand over to Amin to do a demo of a set of ACK controllers that are the Lambda, S3, and DynamoDB controllers that are going to be managing the lifecycle of AWS resources in a sample application, a serverless application that Bob is going to communicate to the Kubernetes API to construct all of the pieces of his application. So let's see, I'm going to hand it over to Amin.
Thank you, Fox. Are you able to see my screen?
Maybe a little bit bigger on the font if you could. Comically big is better than too small. That's my motto. Comically big. Love it.
Okay, is this good?
Maybe one more. Yeah, that's good. Thank you.
Okay, perfect. So let's get started. For this demo, I prepared an EKS cluster. And as Jay said, we don't really need an EKS cluster to run ACK controllers. You can run them on Kind, Minikube, bare metal, whatever you're using for Kubernetes. You can spin ACK controllers and use them to deploy your resources. So as Jay said, for this demo, we are deploying 2 Lambda functions, 1 DynamoDB table, and 1 S3 bucket. And before getting started, all the code and the manifests you're going to see today is available on GitHub. We're going to share the link by the end of the presentation. And yeah, let's get started. So this is my repository. I have a directory with some functions, list item Python and put item Python, which is basically putting items on a DynamoDB table and listing them. And I have a resource directory containing the manifest for a DynamoDB table, a Lambda function, and an S3 bucket. Before starting deploying everything, I'm going to show you what the functions look like, just to get an idea of what we are doing here. So for example, put item .p. It's a simple Python function that loads an environment variable called table name and uses the DynamoDB table client to put an item in it. And it's basically using a UID generator to just put random UIDs in the table. For the other one, it's a list items, which is also a Python function, doing the same thing exactly. It's just going to list the items in the table and return them to us. And for this demo, we're going to use ACK to deploy these Lambda functions, the DynamoDB table and the S3 bucket. And at the end, we're going to invoke the Lambda functions and verify that they are working correctly. So before starting to deploy a Lambda function, we're going to need an S3 bucket where we're going to put all the Lambda functions, and then so we can create the Lambda functions using ACK. And for that, we have manifest, for example, for S3 bucket. We have a YAML file, like any Kubernetes manifest starts always with an API version, kind that is a bucket. And here we have a metadata name and a spec name. The metadata name is the Kubernetes name that is used to store an object in etcd or the API server. And the spec name is the name used by the AWS API to create your S3 bucket. So the S3 bucket will have literally this name. For this demo, they have the same name, but they can have totally different names. It's totally OK. So I'm going to start with this. I'm going to apply this manifest, S3 bucket YAML, and we're going to see that in action. So if I do get bucket, like get pod, we're going to see that we have a bucket that got created. Normally, there's a controller that will catch the event and create the S3 bucket for us in the cloud. If I do an AWS S3 ls and I grab ACK demo, I should see a bucket that got created. So we got here a bucket that just got created called ACK demo bucket KubeCon 2021. So our bucket is ready. Now we just have to zip the functions and upload them to the S3 buckets. And to that, I'm going to go to the functions directory, run the zip file, zip command twice. I zip my functions, and now I can do I put object, sorry. I put object for the put item and for the list item zip file. List item zip file. Okay. So now that our code is on the S3 bucket, we can go and create the Lambda functions. However, what we can do before is create our DynamoDB table before creating the Lambda function. That will not really impact something, but I can show you what a DynamoDB table, for example, manifest looks like. Sources, DynamoDB table. To create a DynamoDB table, like any Kubernetes manifest, you need an API version and a kind. Like S3 bucket, we need a name and a table name. We have one primary key, or let's say hash key, that is an ID. And we have a default provisioned throughput and a streaming specification. which is not used in this demo, but just for the sake of defining our DynamoDB table. Let's go and apply this. Let's do our DynamoDB table. Should be created. If I do get table, I will see my table here. If I do get table, demo table, or YAML, we can see more in depth what our table look like. We're gonna see that it's got a status, and the status contains the ARN of the DynamoDB table, the owner account ID, the AWS account that was used to create the demo table. And here at the end, we're going to see the table status that says it's active, which is ready to be used or consumed by the Lambda functions. So everything is OK from our side. We can go ahead and deploy the Lambda functions. So before, let me show you the Lambda functions. We do resource, Lambda functions. Like the other manifests, we have two Lambda functions in here, two Lambda functions resources defined in one YAML file. You're going to see that we have a function name and a code section where we define where can the Lambda function find the code for, or the Lambda API find the code for this function. And we're going to see here, I'm precising the S3 bucket name, the put item.zip, and I have a role arm that I prepared before that, basically giving a DynamoDB read write to put item, and for list item, I have a DynamoDB read only. I also I'm having a variable environment variable name, table name, demo table, so that the Lambda functions know to which table write and read from. With that said, I can go ahead and directly deploy our Lambda functions. I'll go and do an apply the functions. So two resources got created. If I do get functions, I'm going to see that I have two functions that just got created behind the scenes. The controller captured that and created them using the AWS API. I can go ahead and do a Lambda, I think it's get function. If I do this, I can see that the state, for example, of my put item function is active, and last update status is successful. So our Lambda function is ready to be invoked and called live. So with this showed, I can directly call a Lambda invoke. I can do here. I'm gonna call put item first. So as I showed in the Lambda function, this function will just generate a UID and put it in the table. So as much as I call this function, we're gonna get more rows in the DynamoDB table. So if I call it twice, we're gonna have 2 rows in the DynamoDB table. And now if I call Lambda invoke for the list, I'm gonna see two elements in the DynamoDB table. So we're gonna see here the items of the DynamoDB table. There is the first ID and the second ID. And yeah, that's it. We have 2 Lambda functions, 1 DynamoDB table, and 1 S3 bucket, fully deployed using ACK.
That is super cool. That's it. Yeah, and you're like,
and live, and a live demo that didn't mess up.
Yeah, you've done something right for the demo gods. We had one question during this that I think is really pertinent to the demo, and this sort of reflects a couple of other ones, sort of about state management and over time. So ACK would recreate the S3 bucket if I delete it, right?
If you deleted the S3 bucket via the AWS console, yes, the ACK controller would attempt to recreate that. The tricky, so you can sort of detach a particular resource from ACK management by sort of like detaching or deleting the finalizer in ACK land. So you can kind of work with both.
The thrust of the question was more, I think, in the positive vibe, where people are thinking sort of toward this declarative config and control loops and reconciliation and GitOps, and this is just a really great fit. Like this is sort of extending that to your cloud resources. Fantastic demo. Thank you. Do you guys have anything left in this session? You just covered so much stuff. Super impressed.
One thing I didn't demo this. I mean, I can demo it if we still have time, but there is also
the updates and the delete operations, I only create the resources using Kubernetes. But for example, if I go and let's say I modify the DynamoDB table attributes, the controllers will watch that and go and update my DynamoDB table instead of recreating it. And the same for deleting a resource in the API server. The controllers will watch that and delete them. So yeah, the ACK controllers are literally doing any CRUD operation using the API, the AWS API to manage the resources.
Right. That's
and
awesome.
I can answer a couple questions if we've got any time left, but maybe not.
I believe we are just about out of time.
All right. Well, find us on provider AWS Kubernetes Slack channel and ask all the questions you want. We're happy to answer them. Thank you so much.
Thank you, Jay. Thank you, Amin. And next up, we're going to move from that action-packed session into our hybrid application partner panel hosted by Alan. So stay tuned.
Moving your business to the cloud means having a vision. Owning that vision and bringing it to life means building a plan. As you build yours, it's worth remembering, modernizing your business to innovate requires investing in your people. Through cloud training, you build skills across your organization to embrace a change, a new operating model, a new mindset. You can deliver the business promise of your transformation when your workforce is ready. And that's the vision of AWS training and certification. Our comprehensive training can help your workforce innovate faster, accelerate cloud transformation, and give your business a real competitive edge. It helps inspire personal growth while driving organizational growth. It creates a culture of continuous innovation to attract and retain talent. It brings new thinking and even more opportunities for fresh ideas to flourish. Developed by the experts at AWS, our flexible training options are designed to meet the evolving needs of modern business. You give your team the vision, we'll give them the cloud training to bring it to life. Lead through learning. AWS training and certification is how.
AWS Activate is an exciting free program designed to help startups get started and grow their business on AWS. Take your business further with free AWS credits, support credits, training, exclusive offers, personal content, and more. Applying for AWS Activate is easy and only takes a few minutes. If you don't have an existing AWS account, you can create one for free. Then you're ready to apply. To begin, simply go to the Activate website and click on Apply Now. From there, you'll be prompted to sign into your existing AWS account if you're not already signed in. If your startup is self-funded or funded through pre-seed, angel, seed, debt financing, or Series A, and you have an Activate provider org ID, select AWS Activate Portfolio. If your startup is self-funded and not associated with an Activate provider, go to AWS Activate Founders. Next, fill out the application form providing some basic information about your startup. And that's it. You're ready to submit your application to AWS Activate. Once approved, AWS credits and AWS support credits will be added to your AWS account. You'll also receive an email from AWS Activate highlighting all your new benefits. So, sign up to apply for AWS Activate today and take your startup to the next level. For more information, visit our website.
Hello, I'm Alan, and today we're going to be talking about hybrid computing. So we have a panel here. I'd like to welcome our panelists, and the topic is going to be along the lines of hybrid computing. So let us go through some introductions, starting at the top. Duffy, why don't you kick us off? Tell us a bit about yourself, your company, and perhaps by answering, what are some of the trends you're seeing around hybrid computing that are shaping the future of Kubernetes?
Awesome. So my name is Duffy Cooley. I'm the field CTO at Isovalent, which means that I help a lot of our customers understand how to best make use of technologies like networking and eBPF inside of Kubernetes clusters and in other environments, and that's been a lot of fun. I think hybrid computing has been helping helping kind of, or trends I've been seeing in hybrid computing in the space. I think what I've been noticing is that there is definitely a need. It's like people are starting to adopt multi-cluster environments and also environments in different areas, or that are areas and different from one another. Sometimes in their own data center, sometimes they want to burst to the cloud, sometimes places. And I think that that's a form of hybrid computing because it means that you're going to be running that hardware locally, and you're also looking to like pick up machines that may be running a different architecture in a different cloud environment due to cost. And this is I think probably the biggest driver for like the multi-cloud stuff that I've seen is like that sort of space.
Great, thanks for that. Leonardo, I'll pass it over to you. Same question.
All right, hi everybody. My name is Leonardo Murillo. Everybody calls me Leo. I'm Principal Partner Solutions Architect with Weaveworks. And my job is to work very closely with our partners, including AWS, trying to find solutions for our clients and how to use EKS and the whole suite of EKS products, EKS Anywhere, EKS Distro, to build large-scale enterprise architectures. Now, as far as the question, I think hyperscale and fleet scale is something that we're seeing over and over. And this is very much associated to, for instance, the telco vertical or IoT, where we're looking at an increasing complexity in managing very, very large scale fleets of clusters that are distributed and running in very heterogeneous environments, right? And that brings forward complexities in terms of operation, which is where I think, for example, patterns such as GitOps come into play, as well as day two operations, right? Managing the life cycle of these clusters is complex. And I think Kubernetes will, as a project, right, will evolve new mechanisms, right, to make it easier for organizations to handle this level of complexity.
Great, thank you. Zachary, how about yourself?
Hey, thanks, Alan. It's great to be here. My name is Zachary Smith. I'm the managing director of Equinix Metal. As commonly known, Equinix is the world's digital infrastructure company. And so we offer data centers in over 200 places around the world, 64 markets.
Zachary, we can't really hear you. You're breaking up.
Oh, okay. Come back to me. I'll work on my microphone here. How about that? Can you hear me now?
Nope, still.
I can hear Zachary well.
I can hear you well as well. So.
I think it's on your end, Alan, where you're having trouble.
Okay, shall I keep going?
Okay, go ahead,
Keep
Zachary,
going.
then. Okay, cool. I'm going to keep going then. And so we have about 10,000 enterprise customers around the world. And what we do with Equinix Metal is try to make it easier to access the global reach that our enterprise customers are looking for, as well as the interconnection capability that they need to reach all their various partners, all their different cloud ecosystems, and connectivity options. And so I would say that our business is definitely interacting with customers who are going through a hybrid multi-cloud journey. They're either digitally native from the start, or they're transforming and investing heavily in digital. And what that means is that they're trying to move faster. And we see that that is the major trend as it comes to Kubernetes is a transformational tool for our customers, which is number one, how can they look at moving faster with their very, very complex, I love what Leonardo said about heterogeneity. We see every one of our large enterprise customers having not one of something, but a lot of everything, from applications to providers to complexity of locations and whatnot. So investing in the technology to be able to move in a complex hybrid world, and then also culturally. A lot of our customers are on a big journey to figure out and how to transform their organizations, and people transformation and cultural habits around how they manage risk, how they deploy and manage applications, where they use those in their businesses, and the skill sets that they need. And so we see Kubernetes being a very big investment point for our customers, mainly around cultural transformation, just as much as technical transformation.
Great, thank you for that, Zachary. Frederick, I'll turn it over to you.
Yes, hello everybody. So Frederick Maliki, I'm a CTO for the Southern region at Atos, covering Iberia, France, and Italy. And among my main responsibility, I'm in charge of innovation, portfolio, and also supporting our client in their digital transformation. And this is where Kubernetes is playing a key role. So 1 year ago, we have announced our One Cloud program, so which aim at bringing together all our assets to support our client transformation to cloud. And when it comes to Kubernetes, we see it as the main component to accelerate our client transformation and enable multi-cloud and hybrid deployment. And we see Kubernetes in the future at different scales, from large clusters hosted in hyperscaler, and still we mainly see Kubernetes being used in a public cloud environment. But now we see also more and more use cases leveraging this edge to cloud continuum, and we could see also Kubernetes even at the device level, at the edge level, where the data is being captured and processed, and then, of course, in the cloud. And we see also some trend, in particular in Europe and in France, with sovereign cloud, where, from my point of view, Kubernetes has a key role to play. Because when we think about sovereignty or trusted cloud, I think Kubernetes, by bringing this multi-cloud dimension, providing also the interoperability across the various cloud providers, and bringing this abstraction layer. So it's playing a key role, right? So, and when we think about indeed the sovereignty dimension, it's not limited to the data only. It's not only addressing the operation, but the software dimension is also important. That with the open source part, I think Kubernetes is taking, it's filling all the box, right? I was listing before. And we see more and more use cases with our client in research, in energy utility, when we think about the electric vehicle, as an example, where we need to have a common platform, so from the car up to the edge and then in the cloud. So again, we see Kubernetes playing a key role more and more and everywhere for the future. I hope I answered to your question, Alan.
Absolutely, thank you for that. So let's actually start with Zach. Zach, how has the role of bare metal changed in the cloud native ecosystem over let's say the last 5 years?
That's good, timely. So I was acquired by Equinix back in March of 2020, and previously I'd started Packet, which was a bare metal compute platform, in 2014. So up close and personal with the concepts of portable software needing programmatic infrastructure. And I think what we've seen over the past few years is a big acceleration of software, which is able to kind of work on any infrastructure, and developers who are taking more and more control over that process. And what we've missed, I think, until in recent years, was a substrate that was sufficiently programmatic to allow control against a diversity of different hardware devices. And this is internally at Equinix, what we like to say, we have several 100,000 racks of co-located infrastructure in our facilities around the world. And our customers have all types of different needs, whether it's from a storage perspective, from a compute perspective, networking or accelerators or whatnot. They have all kinds of diversity. And so now that we're trying to take this kind of what I'm going to call very, very manual co-location product and turn that physical infrastructure to move at the speed of software, this is where bare metal becomes relevant, where really you can take this physical infrastructure substrate called co-location and turn this into digital infrastructure, where suddenly it's programmable and can be done repeatably, and you can use those same kind of DevOps mentalities and idempotent control of software on your infrastructure. That, I think, has really opened not only the investments that people have made. We've donated our bare metal provisioning platform, Tinkerbell, into the CNCF, which is incubated there, helping infrastructure become more portable and more reusable in private data centers, in neutral connected data centers like Equinix, or in public cloud. And so I think that's just widened the market for enterprises who frankly have a lot of physical infrastructures throughout their enterprise data centers.
Great. Anyone else wish to add?
Uh-oh.
Folks working on trying to figure out things like cluster API Tinkerbell, which I think is really exciting, and coming from have some good friends working on that project, and it's really exciting to kind of see that take off, especially as it relates to the cluster API project. This is I think in my opinion, as a Kubernetes person, I would say that like it's really important to think about how to deploy Kubernetes clusters kind of as a purpose-built Kubernetes clusters that you can kind of easily recreate and reprovision if you need to. And I think that some of that work there is really lining up with that. One of the things that associates with that, and this actually kind of ties into the EKS Anywhere model, is the ability to create effectively a flat pod network across multiple clusters. And we call it multi-cluster mesh. It gives you the ability to for networking and observability and security across multiple clusters that you could spin up leveraging Cluster API inside of EKS Anywhere. Exciting stuff.
Absolutely. Anyone else?
I think there's an interesting component that kind of resonates with the whole idea of Cluster API and Kubernetes as this level of abstraction that looks to provide kind of a common operating model as well as common developer experience. And it's the fact that Kubernetes is evolving to become not just a container orchestrator, right? Yeah. Rather the control plane of everything. And what Sekar was saying, right? Kubernetes is effectively becoming the control plane for even bare metal, right? You can actually coordinate the operations and lifecycle using the Kubernetes API. And I think that's very relevant to being able to manage hyperscale and fleet scale diverse operations. The one gap that I think it's interesting for us to eventually talk about, particularly in this kind of like hybrid world, is how the development loop is still somewhat complex, right? How providing the developers with an effective experience still has gaps that I think as a community, as we kind of merge in together all these different realms of expertise, right? The whole idea of data center as a service and the hardware as a service and the Kubernetes project, right? How we can provide access to this diverse landscape in a way that is very friendly to the developer is going to be key to kind of like furthering the adoption that we're already seeing, right? Because it's the traction is unquestionable.
Yeah, and that's actually a pretty good segue in terms of the power of the Kubernetes API. Leonardo, I'll ask you this question, but how does GitOps really improve the security posture of an organization delivering applications in a hybrid environment?
There's a lot of ways to answer that question. So I think for one, the fact that you desired state. So I'm not going to go into kind of like in depth as to what principles of GitOps are all about, right? But when you think about having the desired state in a store, in a repository that guarantees traceability, auditability, you get, of course, something very solid to begin with, right? You know exactly what changed, when it changed, is immutable, it's versioned. And if you use Git, it's distributed, right? You have many copies of it, and everybody can see the truth, right? There's also a risk that I think gets pretty much eliminated in terms of continuous delivery pipeline hijacking, right? Because when you have agents running in your cluster, where you have agents that are actually pulling this state, and applying the necessary actions to reconcile your desired state with your runtime with your desired state, the risk of malicious actors modifying the actions taken is dramatically reduced, right? Because you are storing a description of your desired state. You still need to protect your CI, right? You need to make sure that your artifacts and your supply chain is secure, that your artifacts are trusted. But once you have this barrier that clearly creates a boundary between CI and CD. And CD, matter of fact, is to continue to deliver and deploy. You don't even need access, external access to push into the cluster. You can pull from within, right? All those characteristics, I think, together provide a lot of let's call it built-in security to the operating model that bring in a lot of that reduce the effort necessary to maintain a solid posture.
So, question for everyone. For organizations that haven't yet adopted GitOps, what's the best way for them to think about starting?
Yeah, I think we should look. Yeah, sorry. No, I just wanted to say that from my point of view and the experience I see with my client is that we should not start with Kubernetes only from a technology standpoint, but really approach it at the organization level. And it's not only about the technology, but also about the organization, as you said, Leonardo, about the CI/CD pipeline and the different processes and way of working we have between our development team and the operations. So, and we really need to start thinking about the concrete use cases that we want to implement and where Kubernetes is indeed relevant. And we have some experience. Duffy, you talk about EKS Anywhere as an example. So we made a prototype very recently for one of our clients in the manufacturing space. And it was really fundamental for us to think about the use case and the benefits it will bring to our client, and then ensure also that beyond the technical part, we also set up the right organization to benefit from the values that Kubernetes is bringing. So it's all about the agile organization, SRE kind of model, and to going beyond the platform itself, meaning what Kubernetes is bringing to my business. And for example, for this specific client I was referring to, sorry, we are modernizing its application, replatforming them to allow him to get more flexibility, some interoperability as well, and then avoid also vendor lock-in, which is one of the key requests he made to us. So yeah, my recommendation would be indeed not to limit it to the technology, but also to address the whole dimension, the organization, and the processes as well in the organization.
Anyone else?
Yeah, I agree with a lot of that. I would say that, like, whenever we're trying to adopt a new technology, especially something like GitOps, the right way to start would be to really dig into like what the problem you're trying to solve is, right? Frequently, people adopt things like GitOps because they're looking for a transactional method to understand the changes that are happening to clusters over time. Sometimes they're looking to adopt GitOps to be able to define some declarative state that they will apply consistently across multiple targets, across multiple clusters, and GitOps can do all of these things. It can be a part of the recipe for success across a variety of different areas. And I think that what's important is that you just pick, one or maybe two things that like the functionality of something like GitOps would apply, and then, evaluate the different frameworks that are out there, evaluate the different solutions that are out there, determine what your operating model will be, whether it be a push or a pull model, whether you're using an agent or just applying things in the way that you're probably applying things today, but using a CI environment, and then figure out from there, like, how to graduate to something that you're happy with in a production environment.
Yeah, I'm gonna second a little bit of that, and I want to point in on something that Frederick mentioned. This is what we see with primarily our enterprise customers. Service providers are a little bit different, where they have much more kind of control of their own software stacks, where they might have the ability to make more fundamental changes, and they're kind of used to being operators by default. What we see with our enterprise customers, it's much more of this cultural kind of transformation. And so oftentimes, and this is why I would say, like, if you're investing in or interested in, say, a GitOps model, looking at the organizational structure and figuring out, hey, what are we trying to do here? Per Duffy's comment, I think most enterprises are going to say we want to move faster. That's what we hear. We're trying to move faster with software. And I think then making sure that you find something small and recognize that what you're doing is a pretty big cultural transformation. and that the point of it is not to move extremely fast, or the point of it is not to have this outcome. The point is to learn and get good from an organizational model and break down some of those, I wouldn't call them, kind of cultural norms. For example, UAT testing styles, 3-month release cycles, planning purposes, the concept of monitoring and observability and risk, which are generally negatives, in some traditional models, which become part of your process in a GitOps model. So I think that a lot of this can be used as an experimentation with enterprises. And as long as you know what you're maybe looking to do is experiment with a new operating model.
Yeah, that's actually what we're seeing a lot and what we hear from our customers as well. So Frederick, can you elaborate about some of the use cases in which some of your customers have sovereignty constraints for their workloads?
Yeah, so we have some use cases in many different sectors. So like energy utility, for example, I talk about the electric vehicle, and one of the main challenge is about energy roaming or network optimization. Also, for the charging of the vehicle, or the electric grid, where you fuel the network from the car batteries, and to do that, we need a common abstraction layer across the ecosystem, right? And this is where we are building this ecosystem data platform, which need indeed the Kubernetes infrastructure at the bottom to enable the use cases I was referring to before. Another example is in finance, where we are working, for example, on fraud management platform. So within the ecosystem, so we see more and more use cases where we are expected to build a platform which will serve a full ecosystem, and where indeed various customers, partners, or even sometimes competitors will be contributing to the development of the same services and platforms. So we have other example, for example, in manufacturing, with supply chain optimization as an example, where we are deploying Kubernetes clusters in research, also where we have several, for example, in France, a research institute contributing to a single project where they need to build, to contribute to the development of applications jointly together. And indeed, Kubernetes is enabling this ecosystem and this development platform. So these are just few examples. I could take many others. For example, within Atos, we are part of the Gaia-X initiative in Europe, which is this sovereign cloud initiative, which aims to build this multi-cloud interoperable environment at the European level. And of course, Kubernetes, from the various dimensions we talk about, is playing a fundamental there. So becoming the core platform, right, enabling all these data use cases I was mentioning.
Anyone else want to add to that?
Yeah, I'd like to talk about our experience with telecommunication companies, because I think that is very, very interesting, particularly because of the rise of 5G, because telcos are in a very interesting position because they cannot deprecate anything, right? They have to run their 3G, their 4G, and now they have 5G, then, which means they're kind of always in this position of growing complexity, right? Where they still have to worry about bare metal, where they still have appliances, they have devices that are deployed across regions, right? But as they evolve, they're looking to, well, they went from kind of like physical to virtualized, and now they're going into containerized. And the ability to operate this very complex landscape together with sovereignty concerns, because that's kind of like where this was coming from, right? Brings forward the need to enable organizations and developers to be able to transparently move across stages and across sovereign and not sovereign environments transparently. Because if you think about certain operational sovereignty, data sovereignty scenarios, that usually applies to kind of production environments, right? But you want to make sure that the promotion of your artifacts, that the life cycle of your developers allows them to operate certain workloads on the cloud, because they, for development or integration, do not have the same constraints in terms of sovereignty that they would have to apply in production. So allowing them to use Kubernetes as this common platform that they can use to transparently move across these different stages while maintaining sovereign workloads for production, whether data or operationally, is something that we're seeing very, very often in telcos. And I think for telcos, there's another interesting challenge, and that's the coexistence of all these different generations of technology, right? And how some very established mechanisms of control must coexist with new technologies such as Kubernetes. That's kind of from our experience where we see out there, what we see out there.
Alan, maybe I can stop in here and answer a question that I saw in the chat, which I think it applies to this. We see this kind of use case of, I'm going to call it on-prem or interconnected colo movement of infrastructure, generally to those sovereign or edge-related environments. But the one of the main use cases we've seen for like EKS, right, which is kind of this really interesting opportunity to bring, kind of a common control plane for enterprises into, attached, tethered, or private environments, has specifically been, this is to answer Isaac's question, over Equinix Fabric. So, cloud on-ramps to AWS in 38 markets. What we're seeing is a unique opportunity for customers who are invested in the AWS ecosystem and also have some, regulatory control, whether they want to use metal or colo, private cages, secure infrastructure, things that only they control, and they can connect and register those clusters over private connectivity. I think that's a really interesting enabler for these kinds of, sovereign workloads that need to kind of move back and forth between very controlled and maybe static environments, and kind of use of public cloud infrastructure and services.
Yeah, absolutely. So Duffy, based on everything we've discussed, how do you see the role of Cilium playing for hybrid computing landscape?
Well, I think it kind of plays a little bit into that question that we were just talking about data sovereignty and like different security environments and things like that. Where Cilium fits in, I think, really just it is a framework on which we can build a lot of really great functionality, leveraging the kind of the superpowers of Linux, like eBPF. And one of the biggest pieces that we get out of that is an incredibly rich amount of context about what's happening at the process layer and also at the networking layer, and being able to like identify exactly what process opened a connect call to some external piece, being able to like immediately shut down that connect call if it was determined to be not okay, being able to make important and complex routing decisions about where to route this stuff so that we can integrate with things like existing discrete firewalls in between particular zones, however you've actually created your security infrastructure inside of your data center. All of these things we're doing with people today with Cilium. I think it fits into that model pretty well. It kind of gives us the ability to bring a lot of great new technology to a lot of older problems and really kind of level everything up a bit.
Yeah, absolutely. Thank you for that. Anyone else want to add?
I'd love to. Yeah, I mean, I think like one of the things that we see with our customers is a movement from kind of, I'm going to call it siloed network environments where you kind of brought everything to you. We're talking MPLS and private line and telco and, like IT controlled, very private, environments to ecosystem based. And that's like the hybrid multi-cloud story that we see is people are accessing a variety of services. They're interacting with SaaS applications and partners. They're doing more business, throughout a bunch of heterogeneous networks. And the ability with something like Cilium, huge fan, right, is to be able to provide kind of security substrates and related, kind of observability across all these types of things. Because the one thing that we know is very bespoke and, whatnot is networks and clouds versus networks on-prem versus mobile networks and telco. It's like, it's all very, very different and often somewhat a little bit walled, like we've seen in private data centers or whatnot. So having that ecosystem-based approach and being able to cut across that with something like, eBPF is really powerful.
Anyone else?
eBPF is awesome. I love it.
Everybody hearts eBPF.
I confirm the ecosystem that you just mentioned is indeed very important, and this is really a trend we see more and more with our client and within our environment. So it's the same. Yeah.
All right. So this is a question for everyone. What advice would you give organizations today that are embarking down the hybrid journey?
I would start with, I always kind of default to an answer of what problem are you trying to solve. I think that helps really nail down exactly like what your approach should at least begin to look like. When you're looking at hybrid cloud environments, I think it's important to understand like what you want to get out of it as an organization, right? Like what you're actually trying to solve, whether you're trying to lower the cost of compute, whether you're trying to improve the reliability of your services by deploying them into different environments or using a different technology, whether you're trying to improve the security of your environments by having a better isolation between data sovereignty environments or what have you. I think that what's important is that you kind of just begin by defining like where what you want to get out of it first, and then from there, I'm a big believer in experimentation and iteration on things like this, right? So when you've actually got a pretty reasonable plan for what you want to accomplish, set about defining those environments and experiment with them. Develop a threat model if the security piece is important to you. Develop a resilience model if you're actually going for a more reliable environment, right? Do some chaos experimentation. Figure out what happens if you turn off a data center and you lose that capacity. Are you still able to service applications? Prove out that experiment that you have defined.
And just to riff off of what Duff is saying, because I agree entirely. Like that's the first thing that came to mind, right? Like have a good reason to make that call, right? And I think Duffy speaks about, or what Duffy speaks about, is very much about measurement, right? You want to be able to have quantifiable, objective means to determine whether you're moving in the right direction, right? Whether these experiments, because I think a lot, for example, when you talk about chaos, right, Duffy, a lot of people, I think, still get the sense that chaos is just inject, failure, right? But there is a whole scientific process to it. There is a hypothesis that you're trying to prove or not, right? Or so, and I think that applies to not just chaos. That applies to transformation and what Saker and Frederick were talking about, right? Adopting hybrid will have impacts into how your organization interacts and how your different teams work together, right? And what type of technology you're going to have to evolve into. So having a clear view of where you stand and what metrics you're using to determine whether you are making progress or not, I think it's critical for success.
Yeah, I'm gonna riff on that. I basically say like the first thing to in addressing a challenge is to admit you got a problem, right? And I think this kind of acceptance that most companies, whether digitally enabled service providers or enterprises, are gonna live in a hybrid multi-cloud world. Whether they buy companies, they change technologies, they have to be in specific regions, they're regulated in certain areas. Like, it's complicated. And so just recognizing that this is like a big, there's no simple answer to like turn on the easy button for all of this stuff. And so just recognizing the investment and complexity and being eyes open that, you're gonna live in probably, a hybrid multi-cloud world, and then investing in some of those core primitives that, that can help you through that journey or help you to meet your, as Duffy put, like decide what you're trying to solve. Is it availability? Is it cost? Is it security? Is it just you want to move faster and ship stuff? Like, what are you trying to do? And then, effectively invest, around that.
No, I fully agree. And just to add on what you said, Zachary, so most of our client today are enterprise clients, so having a huge legacy estate. So when it comes to hybrid, for them it means mainly going to cloud, right? And indeed they need to think about the use cases and the value that cloud will be bringing to them, but also what hybrid model generate in terms of benefits. So, and as you said, there is no one single answer. We see indeed different expectations. So depending on the client, depending on the industry, it can be about resiliency, about more agility, about time to market, because indeed they want to go fast, they want to beat the competition, so they want to put their product to the market in a more efficient way. But yet, yeah, it's all about being more efficient and bringing more value to your businesses. So,
I had one thing that you brought to mind, if you don't mind me interjecting, which is the other thing that I've seen around just like an investment in a hybrid cloud strategy or B in Kubernetes in general, is talent acquisition. Like a lot of companies find that they just cannot hire innovation talent without, moving on this journey, right? And so I think there was a great keynote at reInvent a couple of years ago, which was kind of like innovation equals software and software equals cloud, right? And to the extent that like if you don't have the capabilities to service your internal creators, your developers, and your engineers, and your product people with the tools they need or they want, it's pretty hard to attract that talent and keep them. So
yeah, for sure. It's one of the key areas of investment that every organization needs to make as they embark on that journey. So I'm going to give each one of you an opportunity to give a closing remark, but I'm curious, what are you going to be up to this KubeCon? Anything you want to highlight as our audience should pay attention to? Why don't we start with Duffy?
So KubeCon, this will be the first large conference I've been back at in person, and it's really been great kind of connecting with people again and also welcoming a lot of incredible virtual attendees. I know that our attendance in virtual has continued to grow and that we're going to see like more and more folks showing up at KubeCon like over the year. So I think this hybrid model that we're doing here will continue to happen. Yesterday I hosted the eBPF Day and I thought that was an incredible session. All of those videos will be up soon. And so if you're interested in understanding more about eBPF or exploring different spaces there, those videos will be up soon, and that will be linked probably from ebpf.io for that sort of content. And then for me, I'm looking forward to Wednesday when I actually present a talk with some good friends about exploiting a particular volume, and it's exploring a CVE in Run C, which is a super fun thing. So definitely check that out if you're going to be attending virtually or in person.
Zachary?
Well, I've got a couple things. First off, it's just so good. One of the best parts about Kubernetes and in general this ecosystem is the community, right? It's just such an 100%. Awesome place to connect with other people who are passionate, who are open, who are trying to do great things for each other in the world and their companies. So like first and foremost, that's like our major goal. Secondly, we would love to connect with others, learning more about what their strategies are, what's top of mind, how's it going, and get feedback on some of the investments we're making, for example, in bare metal automation with Tinkerbell. So that's part of the, in the incubation phase right now in the community in CNCF. And the third, which is totally like not to do with any of this, is we want to give away a lot of the cloud native community cookbooks. So we made a cookbook with a lot of our friends here in this ecosystem in partnership with the CNCF. You can actually add your recipes on github.com/CNCF/cloud native community cookbook, or you can get a hard copy. And so hopefully we can enjoy some food together as well.
Great. Leonardo?
Well, yeah, like Duffy and Zachary said, community is awesome, and I'm very excited. Matter of fact, I should have been in LA today had it not been for my flight gotten canceled yesterday. So I'm right after this, I'm getting an Uber to the airport and race to the gate. Tomorrow we're going to have a panel where we're going to be talking about the Open GitOps project and the GitOps working group that I think it's going to be very valuable. There's actually going to be representatives from AWS as well. For those interested in kind of like an end of day wrap up, the Cloud Native TV working group has daily wrap ups where we're going to be kind of like just going over what happened over the course of of the KubeCon day. So listen in on those. Those are actually streaming on Twitch as well. And if anybody is out there, I'd love to meet up. Like this is it's been 2 years since I've been in contact with other human beings. So I'd love to kind of like be very close to everybody. So looking forward to seeing you all.
And Frederick.
Yeah, so this is the first time I'm participating to KubeCon, so it's very interesting. So I like also the community and the discussion we just had all together. So it's very enriching. So and I like indeed to learn from each other. So what you are doing, your strategy, your challenges as well, and just to see how we could best learn from each other. So I'm been very happy to be there, even if I'm remote today. So hope that next time I will be able to travel to the US and meet with all of you. But yeah, very useful and really enjoyed this conversation with all of you.
Excellent. So I wanted to thank our panelists. I think we are right on time, 1 o'clock. We've got a 15-minute break. And thank you, everyone.
Thank you.
Thanks, Alan. Bye, y'all. Enjoy KubeCon.
switched laptops, so we can mute the camera, but we're good now, right? Can you hear me? Boom. That's it. We did it live. Figured it out. So I practiced my sign language just a little bit, but I'm super slow. So I'm excited to be back and want to welcome in Jacob and Alex for our next session. Hey, Alex. Hey, Jacob.
Hey there. I was just thinking that I need to brush up on my sign language.
Do you know it too?
No, I don't.
Oh, well. That's fine. I know enough to be distracted to try to read it, but otherwise can't speak it so well. So thanks for joining me. Next session on Carpenter, which I can't wait for everyone to see the demo because I think Carpenter is super cool. But first, Alex, go ahead and introduce yourself. Tell me what you do here at AWS and what you're working on.
Yeah, no, absolutely. So my name is Alex Kestner. I'm a senior product manager with EKS, and I focus primarily on all things that are compute related for EKS. Carpenter and cluster autoscaling is obviously a part of this, and so really excited to be here today to tell you a little bit about the project and share a demo that Jacob will be presenting.
Hi, my name is Jacob Gabrielson. I'm a senior principal here at Amazon, and I'm working on Kubernetes scaling and performance, and in particular, I'm one of the folks working on Carpenter. So I'm looking forward to demoing it shortly.
Yeah, so we'll get started with a quick deck just to refresh everyone's memory. If we can bring that in, perfect. Let me see if I can fix the ratio there.
There you go. That's good.
Hey, look at that, doing it live. So we're going to talk about Carpenter today. Really excited. Again, I'm Alex Kestner, joined by Jacob Gabrielson. So one, just kind of very quickly give a sense of what we're going to talk about. Make sure that everyone will stick around for the demo because that is definitely coming later and it is going to be far more interesting than my deck. But we're going to talk a little bit about cluster autoscaling with Kubernetes, the Carpenter demo, and then going to be happy to take some questions. Justin, feel free to interrupt me if there's good questions coming in the chat. I'd love to tackle them as they come in. And yeah, so I think I want to start a little bit by talking about what Carpenter doesn't try to address. So Kubernetes autoscaling can mean a handful of different things. There's a few different paradigms for autoscaling on Kubernetes. And so I want to kind of really make it clear what part of this ecosystem Carpenter plays in. So everyone here is probably familiar with the various pod autoscaling solutions, thinking the horizontal pod autoscaler. So this increases the number of replicas of a pod of a deployment when there's additional load on the workload, or vertical pod autoscaling, increasing the resource requests for an application as as it starts to scale up. So while these are very interesting parts of the Kubernetes autoscaling ecosystem and environment, not exactly where the space that Carpenter lives in, although very much related. So Carpenter, I think, is the most closely related to cluster autoscaling. You can think of this as a scenario when there's new pods or larger pods that are coming in, trying to be scheduled in the cluster, but there just aren't enough compute resources in the cluster for these pods to be scheduled successfully. And so we need to add more resources. We need to add more EC2 instances, and make sure that there's a place for those pods to run. And so this is very much the place that Carpenter lives and plays in. I think happy to talk a little bit later too about how it may be similar in some ways and dissimilar in other ways to the Kubernetes cluster autoscaler. All right. So now I think it's a little clear as to where we're talking about. I want to switch gears a little bit and talk about some of the use cases and challenges that our customers have run into with these use cases that led us to build Carpenter. So the first one I think is gonna be one that most Kubernetes customers are going to be familiar with. This is kind of a classic Kubernetes use case, soft multi-tenancy. So I think the classic example here would be different application teams sharing a cluster. Not exactly a sort of full SaaS-based hard multi-tenancy where you really need to kind of guard against unfriendly tenants or anything like that. Everyone's buddies here, and all trying to kind of accomplish the same goals. But the challenges here is that it's really tough to get configuration right for all these different tenants. The different workloads from these teams may be really different. need different kinds of compute resources. Some perhaps need accelerated instances. Some need to run across different availability zones for high availability purposes. And as a result, it can be really tough to get cluster utilization up to the level that you'd like to see in your Kubernetes cluster. So, this is not something that's a sort of edge case. This is something that nearly half of AWS Kubernetes customers have told us they have problems getting this configured right. So we have all these great recommendations about how customers should run their workloads in production. So things like running across multiple availability zones, running across a variety of instance types that kind of fit the workloads really well, and then leveraging stuff like Spot to help bring deeper cost savings to their clusters. And you can see I think this way the configuration that's required to get this all set up and kind of working together correctly. It really takes a lot. Each one of these dimensions adds a new node group to the cluster, and you can imagine how this kind of quickly becomes really hard to maintain and operate over time. So that's kind of one kind of classic Kubernetes use case that I think we were thinking of with Carpenter. The other one is a sort of different style use case that is machine learning workloads. So these work obviously a little bit differently than kind of the classic stateless service, which is what I think most people would think of as the bread and butter, containerized use case or workload. So these are more job-based workloads. They sit idle. These clusters perhaps sit idle in between training cycles, but then they quickly need to spin up a bunch of capacity to train machine learning models, run simulations. And this can both be on an ad hoc basis. So they have perhaps scientists working to increase the performance of their machine learning models, or on a regularly scheduled basis at the end of the day. Data needs to be updated, models need to be rebuilt to help serve customers better in the future. And so there's this kind of spikiness to the demand is really challenging for the cluster autoscaler. And this is something else that we really wanted to see if we could serve our customers a little bit better with Carpenter. So, waiting to deploy this capacity, scaling it down, kind of taking, being a little sluggish. These are both areas where we think that Carpenter can offer some true improvements. So I've said a lot about. Yeah, go ahead.
I wanted to stay on that machine learning idea here, because it's not just machine learning, but anything. Let's say I have my Nginx container, my pod is running, it's fine, but then someone says, hey, I want to reuse that cluster, but I want to run my machine learning jobs. The options right now are you either create all the nodes with GPUs and just keep them that way, and even though Nginx isn't using it, you just keep the GPUs around, and not a great cost benefits of you're not using those things. So ideally, anything with a GPU, anything that you're not going to, when you're not using it, you spin it down, it goes to 0, and only the machine learning jobs are going to use that. Right now, if you're using Cluster Autoscaler, you either run multiple Cluster Autoscalers targeted to autoscaling groups, or you configure it to a single Cluster Autoscaler to multiple autoscaling groups, whatever your node groups are, which is exactly to your point of this gets complex. Once I have 2 or 3 jobs that need different sized nodes, different requirements on the nodes. If I have Graviton 2 instances and standard Intel based or GPU, that does get really complicated, whether you're trying to split that up at a node group level with multiple cluster autoscalers or separate clusters, or a single cluster autoscaler. So yeah, I just want to dwell on that a little bit, because that's where that complexity lies in, and that's what Carpenter is really trying to solve.
Yeah, exactly. I mean, I think that's one of the benefits of Kubernetes is that you can commingle all these different kinds of applications together. And I think Carpenter really helps that promise become true. It's that much easier to realize those benefits. So, talked a lot about Carpenter, but not really clear perhaps what exactly Carpenter is. And so I really just want to put a fine point on this. Carpenter is a new open source and flexible high performance Kubernetes cluster autoscaler. So key things here that I think are really, really differentiating about Carpenter. Carpenter picks the compute resource that's best suited to your workload. So your workload, for example, needs GPUs. It'll spin up GPU-based instances, ensuring that there's no additional configuration that's needed to be done, saying, hey, at some point in the future, I may need GPUs. Please, make sure that's possible to launch in the future. Obviously, adds and removes these resources as needed. Uses the same kind of paradigm as the Kubernetes cluster autoscaler, in that It looks for pending pods that that haven't been able to be scheduled, and launches resources to be able to scale them. I think the final piece here is that we've built Carpenter in a way that will allow it to remain performant even at and beyond the limits of Kubernetes itself. So as we start to look at larger and larger Kubernetes clusters, that we really have built Carpenter so that it can scale to that size and continue to be as quick as it is, in more modestly sized clusters. So, I think just to kind of highlight the difference between the kinds of configurations that we're talking about, the flexibility and simplicity here, I think, really shines through when you do want to follow all of these best practices. So multiple availability zones, bunch of different kinds of instances, spot and on-demand capacity types. This is all is possible out of the box with Carpenter with the single default provisioner Kubernetes resource. You can see a little sample here. This is a very minimal example. There's obviously many more knobs that you could tune, but this would get you pretty close to spinning up a bunch of capacity for your cluster that would be really responsive to the workloads in it. And I mentioned the performance. So obviously we'll see a bit of this in the demo, but we have some really aggressive goals that we're excited about for next year, hoping to be able to launch a pod and new node in as little as 15 seconds. EC2 is doing a ton of great work to bring the launch time down for EC2 instances, and this is something that we really look forward to taking advantage of. And then not just launching one pod and one node really quickly, but being able to scale up to really large deployments, like these machine learning jobs, for example, right? That spin up many pods all at once or need many nodes. And we want to be able to launch 1,000 pods in 30 seconds, and not just on average, but at the 90th percentile. So really excited about the flexibility and the performance that Carpenter can bring. I'll briefly kind of explain. I think I've touched on this a bit, already, but Carpenter, similar to the cluster autoscaler, responds to pending pods and launches capacity when those pods can't be scheduled, but obviously uses the Kubernetes scheduler if there's already capacity that can fit those nodes or fit those pods. So I think that it's this kind of really tight integration with Kubernetes and the compute provider, for example, EC2, that really bring a lot of power to Carpenter. So with that, I want to pause, and I think that it probably makes the most sense just to switch over and have Jacob take over the demo. I think there's so much more that we can show you and talk about, but I think really just getting hands-on here is the best thing.
And you flew past two things there that, like, to me as an operator, were just what I really want in an autoscaler sometimes. One was pod being scheduled to node being provisioned and running like 15 seconds. Like, that's crazy. There's no node existing, and all of a sudden I schedule a pod and I can have something running on a fresh node scheduled with whatever I need for that pod. So it's like workload native node scheduling.
Yeah, and obviously there's things that would influence this timing, and this is a goal that we have. This isn't the reality today, but we definitely are really working hard to drive down the node launch time, because this is such a critical factor to having a cluster be responsive to the workloads on it. They should, new nodes should come online and be ready to schedule those pods as quickly as possible. So yeah, that's absolutely right.
Yeah, and then the second piece of, we've said it before, where you don't need to pre-provision a node group to have GPU capacity or spot capacity or something. So I want Jacob to go so we can pull in his demo, because those are the two things that I think are just great about Carpenter for any operator, or if you want to have flexible workloads in your cluster, you don't have to go through any sort of node group or cluster autoscaler pre-configuring to make sure that you get the right resources for the workload.
Exactly.
All right, great. Well, let me just walk you through what you're looking at here, folks, and then we'll get into a demo of using Carpenter to respond to new deployments being created in this case, and then spinning up nodes in response. So in upper left here, we have just the Lens IDE showing which nodes are in the cluster. You'll notice there's two here already. Those are just the ones that Carpenter itself is running on, and the usual things like Cert Manager, things like that are all running there. The bottom left shows all the active deployments, so there's none right now. And then this right-hand window, you can see the very bottom, it just sort of shows you a running count. Probably a little hard to see of the number of nodes and pods and how many spot instances we have. in the cluster, and then also there's some log output from Carpenter in the middle, and then in the tops where I'll be typing commands. So
can you zoom some of this font for us?
Let's see here. I can try.
It's okay if it wraps. It's better if we can make out some of the text.
Is that a little better? That's probably the farthest I can go.
All right.
I can try one. We'll just have to leave it at that. Okay. First thing I'm going to do is just show what it's like to create a provisioner. So here I'm configuring. You always have a cluster name and some endpoint that you need to configure nodes with. And then I've already created this provisioner, but I'll just show you what it's like to create one. As you can see, it's already there, but pretty simple stuff. This one actually will launch both architectures, AMD and ARM, and also supports both on-demand and Spot. And if you have another team that wants to use a different provisioner, for example, with different rules, you can do that. So here I'll create another one. Again, this one already exists, but the same command would work. And if you notice here, there's this taint here that only allows this sort of team one to actually use nodes created by this provisioner. So it's definitely something you can do. And now we'll start creating some deployments. Just with 0 pods in them at first. So here's one that will require AMD 64 nodes. And here's another one that will require...
I don't see where you're typing right now.
Yeah, sorry. I'm just pasting stuff from another window.
Okay.
Yeah, so it's in this upper right-hand corner.
Okay.
This one creates ARM64 instances. And you can see at the bottom left that deployments exist as I'm creating these. Here's another one that will create Spot instances. So here you can see there's a node selector that is requesting Spot. And as Alex mentioned, you don't have to sort of pre-configure Carpenter to know about GPUs. So here's another deployment. As you can see, the pods here want, in this case, Neuron GPUs. So you can just put that in the pod spec. You don't need to tell Carpenter in advance. Here's another deployment that is meant for the team one only. So that's this toleration here. And again, they'll be all in their separate nodes. Here's another one that demonstrates support for topology. So you can see here there's a topology key by zone. So now that we've created all these deployments, we'll just see what happens. Well, actually, first I should show you just to show you for sure that there's actually a provisioner CRD, and just so you can see the provisioners are here and they're happy. And so now we'll just start scaling up these deployments. So the first one will scale up is the AMD 64 one. As you can see over in the bottom left, that one of the pods actually scheduled onto an existing node right away, but the other 4 didn't. And over here in the logs, if you scroll back up a little bit, you can see that Carpenter basically figured out a bunch of kind of right-sized nodes that those 4 pods could fit on. And so then it sort of launches them. And you can, in the upper left, you can tell that it actually launched about 14 seconds ago. This will take a little while. As Alex mentioned, we're still working on getting this time down. So it'll take a little while before it's ready to schedule pods, but it did launch very quickly. And so now we'll just scale up the other deployments. So this one obviously requires ARM instances, so they'll definitely require a new node. This next one requires GPUs, so we'll get a GPU instance for that. I'll scale up the Spot as well. As you can see, scrolling by, the provisioner keeps finding nodes that, or instance types that satisfy the constraints of those nodes. So here, For example, you can see that it found a bunch of Graviton instance types for the ARM deployment. This one will make a spot request, of course, as the name suggests, and we'll also scale up the deployment for team 1. And lastly, we'll also scale up the deployment that requires a topology thread. So as you can see over here on the left, a bunch of nodes are starting up in response to all this. Oops, sorry. Shouldn't have tried to go off script.
And all of those nodes are unique to each workload because each one had different requirements that it needed for architecture or.
That's right. Only the AMD 64 one could use an existing node, and it actually found one available slot on there. It'd be nice if.
Bringing in a quick question here, just from Chaos to Fish. If you do provide both spot and on demand, are you allowed to add weights to that? Is there a way to say choose one over the other?
So this is a really exciting feature that we launched in the most recent release, which I'll happily talk a little bit about after the demo. But in V0.4, we add support for node affinity. And this is how we would suggest customers kind of model this spot preferred on-demand fallback use case, which I think is the basis of the question, is that it'd be great to just use spot if spot's available for what I need. And by the way, I think with Carpenter having such a diversity of instance types that it requests, you're more likely to get the compute you need with spot because it'll ask for a bunch of different kinds of instance types, and as a result, you're more likely to find one that has some spot capacity available. But if you can't in the region or zone that you're looking in, it'll spin up on demand requests if you weight the affinities accordingly.
So since a little crash there with Lens, I'm just showing you the nodes getting ready here. As you can see, most of them are ready now. A few of them, I think one is left. So, of course, another question is that we get all the time is, well, what happens when I'm not using my nodes anymore? So, for example, let's say that these ARM tasks were maybe jobs that have all finished. What would happen to that ARM instance? So we can just sort of see what happens. As you can see, well, hopefully in a second here.
So you scaled that the ARM deployment back down to 0.
Yeah.
The pods will terminate, but the node exists.
Yeah. So there's a lot. Just so you can see the deployments scaling down. The ARM 64 one is down to 0 now,
and the other thing I'd point out here is that this is the speed with which Carpenter terminates nodes after there's no pods scheduled to them is completely configurable. We have a parameter called TTL, I think, since empty or till empty, and that will you can set that as kind of tight or as generous as you'd like, based on the workloads in your cluster and kind of how flexible you are to keeping nodes around because something might schedule again really soon.
Well, the law of live demos is kicked in, and I don't know why the node has not gone away. So I will just show what happens when I delete all the deployments. So here. You can see that the controller is noticing some of these nodes are empty now, and it's adding a TTL to them to terminate them. So
the node drains, and then Carpenter says, "Hey, nothing's running over here," and whatever the configuration then says, "Okay, well, we might want to just get rid of that node, scale to 0, save you some money if that's what your goal is."
Yeah, and as you can see, the nodes are all gone already at this point. Of course, I don't know why the ARM 64 one didn't go away earlier, but I'll look into that, of course. So yeah, that kind of concludes the demo. Happy to take questions now.
Yeah, and Justin, I think it'd be great to talk a little bit about the roadmap for Carpenter, the community that we're starting to build here. So we're really excited. This fall, we have a couple of really major milestones for Carpenter. So we just cut 0.4, which has a ton of exciting features. node affinity, like we were just talking about in the spot and on-demand kind of use case, as well as topology spread, which Jacob just demoed. This is in addition to a number of features. If you haven't looked at Carpenter since the last KubeCon in the spring, we had a v0.3 release in July, v0.4 now, tons of features. Definitely check out the GitHub and have a look at the releases there. So beyond kind of all of these exciting features that we're adding to Carpenter, and you can see in the 2022 roadmap, there's even more that we're going to be investing in next year. Later this fall, we're going to be we're going to be kind of certifying Carpenter. I don't want to say a 1.0 release because I think it's early days for Carpenter, but we're going to be recommending that customers take a dependency on Carpenter, use it in their production clusters, and the reasons, in addition to all of these features that we think customers will be really excited about, that will suggest that customers use this in production, is that we're going to be conducting rigorous scale testing against Carpenter. We're going to actually publish the results of these scale tests so that you could, and as well as the code used to generate them, so that you could run in your own environments. And I think that this is kind of the where the rubber meets the road for us, right? We'll be running these tests, showing how well Carpenter performs at scale, as well as offering support for Carpenter running in EKS clusters on AWS. So, this is something where I think you should feel comfortable to, use Carpenter in production, knowing that AWS support will be there. You can cut us a ticket and get to the support teams or to us if need be later this fall. So we're really excited about both of these releases.
Yeah, it sounds great. And that actually, some of this roadmap touches on a question I saw earlier. I'm trying to find it right now about EBS volumes. There it is. If Carpenter's supporting spinning up and saying, I have EBS volumes, which are AZ, per AZ, is it possible for Carpenter to pick which node to scale or which AZ to scale or add an EC? I guess there's no auto-scaling groups at this point. It's just EC2 instances. So where to land that EC2 instance based on the EBS volume?
Yeah, so this is definitely on our roadmap for next year. I think it really will help enable the kinds of machine learning use cases that we were talking about, where often data has to move around, or even stateful workloads. For example, running databases or other things that require other workloads that require storage to travel with the applications in the pod. So I think the other one here that I would really want to highlight, which I think maybe reads a little opaque on the slide, is cluster capacity optimization. So all of the stuff that we've mentioned earlier around Carpenter choosing the kinds of instances that your workloads need, scheduling them based on their scheduling constraints, and doing it all really quickly is kind of just the first phase of Carpenter. The next phase that we imagine here is that Carpenter can continuously look for ways to optimize the efficiency of your cluster over time. So by maybe scaling down nodes that are underutilized, you could define a threshold perhaps, or by rescheduling pods to group them together onto larger nodes, lowering that daemon set overhead and the kind of Kubernetes system tax, so that your cluster can be both more efficient from a performance perspective, but also from a cost perspective. And this is going to be a big theme for us in the beginning of next year.
Yeah, that's really cool that we'll be able to continually look at the workloads, because as workloads come and go, as they scale up and down, a lot of times you get underutilized nodes. You get nodes that maybe aren't the right pick for the workload just because they scaled up. And so that's a great point, that we'll be able to look at those over and over again with Carpenter and keep reevaluating that depending on what what your cluster's goals are. If it's minimize costs at all, at all costs, like, okay, we'll delete nodes faster, or if it's optimized to, everything should be 80% CPU, we can figure that out too.
Yep, exactly right.
Obviously.
Oh, sorry. Go ahead, Justin.
I was just saying, last question that I saw in the chat was you mentioned production readiness, and just want to bring this up is if someone's running cluster autoscaler, you say that at this next milestone, you think that late Q4 it'll be ready. Carpenter will be ready to say, yeah, you should swap out cluster autoscaler. Carpenter can now take the place to scale your nodes in the cluster as needed.
Yeah, so I think that the way we see people switching or using Carpenter over the longer term is that at the beginning, customers will start to migrate portions of their clusters over to, or maybe individual clusters over to Carpenter, especially if the scaling characteristics of those workloads really fit nicely with the value proposition that Carpenter provides. So really spiky workloads or workloads running really, really large clusters. And And then, I think there's some workloads though where the cluster autoscaler will still be the best fit. This will be kind of relatively static workloads that kind of just exist at a pretty steady state for most time, for most of the time, the life of the cluster. But I think that over time we really see Carpenter as the future of cluster autoscaling, and would hope that bears out in its adoption, that it becomes kind of the new standard. So really looking forward to making that happen.
Sounds great. Anyone that's interested, check out the GitHub repo, open source project. It's making all sorts of fun new waves that I've seen for how to schedule nodes in a Kubernetes cluster. So I've been watching it closely and having fun with it. So thank you so much, Alex and Jacob, for coming on and showing it. We are going to transition right away into talking about BottleRocket. So if anyone is using Kubernetes, you have an operating system on all of your nodes, and BottleRocket is the open source Kubernetes or container native operating system from Amazon. So it's an open source operating system. It allows you to minimize kind of that, what's running on the nodes, and really looks at, if all the workloads are containers, what does an operating system look like for that? So we're going to bring in Curtis and Mikhail. And hello.
Hello, everybody.
Hello,
that was
everybody.
exciting. Thank you so much for that introduction. Yeah, I do want to hit on that if we could just dive right in, or was there another introduction you want to do? Okay, yeah.
I mean, you can tell me what you do first, and here at Amazon, like we have lots of time to look at this BottleRocket, and it's gonna be great. But just go ahead and introduce yourselves first.
Okay, go for it, Mikhail.
Sure, I'm Mikhail Shapirov. I'm a partner solutions architect. I'm a container specialist. I work very closely with Curtis, with our partners, consultant partners, and ISVs. With EKS related things, as well as other container infrastructure. Very nice to meet everyone.
Awesome. And I'm Curtis Reese. I'm a principal solutions architect focused on containers NetMod here. Like Mikhail said, we both work on the partner team, and we get to do a lot of really awesome integrations with our AWS partners and all things Kubernetes and containers. And one of the passion plays that I get to be a part of, and Mikhail gets to be a part of, is BottleRocket. And so, like you had that good introduction as to what BottleRocket is, but I think I want to make sure we're very clear. It's like when you look at general purpose operating systems that are out there today, the process of managing those, securing them, making them ready to basically receive the workloads and operate in production, there's a lot of process that has to go into that. And some of that process doesn't necessarily have to be there. Like it's just there because that's just the way it's been. We have this general purpose OS, and it comes with everything you could possibly need for any particular workload. And it's very dynamic in that regard. But when we look at running containers and what's actually needed to run the containers themselves, it's not as much as what you would need in just a general purpose OS. And so what we did there is we actually stripped out a lot of the things that aren't necessary to run containers, and really focused and honed the OS on just being laser focused on how do I run a container workload? Does it have the Docker daemon? Does it have container D? And what else are the things that it might need based on the workloads that are on top of that? And then we took that a step further. Like after we've stripped it down, we took it and we secured it even more. And so when you think about what permissions containers need to run, the way that they get those permissions isn't the same. It's not everything needs privilege mode, everything needs kernel access. And instead, most use cases and most containers they're running don't need access to that. They don't need access to the underlying host file system. And so we essentially locked that down and made it read-only and put SE Linux policies and other security tools in place to really kind of wall that off. And then when you look at it even further, we decide that, hey, maybe the management constructs for this don't necessarily have to overlap with the orchestration constructs. And so what we actually did is separated those two. So there's a container runtime specifically for your container workloads, and there's a separate runtime that's specifically set up for administration workloads, things that might need elevated permissions and access to the underlying host. So that's really kind of the crux of where we started with this process. And I think those are what some of the cool aspects of the way BottleRocket works today. But in that, do you have any particular questions that you want to discuss or you want us to go over? Should we talk about the update process? Do you want to go deeper into security?
I mean, I wanted to just point out what you were mentioning. Like, a general purpose operating system can be secured. It is a lot of work, and
Absolutely.
it's and in BottleRocket, we're really taking a hard line between kernel space and user space, right? Containers run in user space, and that's where the workload should be running, and that's how applications and libraries and everything else is packaged. If you're running these clusters, you should only be using those things inside of this user space. Maybe there's a few that are like eBPF or something like that that have lower level interactions, but then in BottleRocket, you really are taking that hard line between kernel space is management and that is very much locked down, but also separating out that user space into what you're using to manage the node and operating system itself, and what are essentially like user workloads or general purpose workloads on top of the node. So you have further separation on top of that between how that's being split up.
Absolutely. And the reality is there, we went that far because we want to make sure that whatever's running and is exposed to the public internet is as walled off from that host as possible. Like we don't want, we want you working to secure your workloads and make sure those are as hardened as possible so that we're minimizing the risk of potential attackers getting into the actual containers themselves. But if they did happen to get access to those containers, we want to make sure that they don't get access to the underlying host and therefore potentially have a vector to get to other containers that are running on that host itself. So imagine they got into that cluster, they'd have access to basically anything in that cluster. And that's where we want to separate those. And that's also why we took it a step further to make sure that the operating system is read-only. And so if we look at, well, let's look at this view here. So this kind of explains the process for gaining elevated privileges at a high level. And most workloads are going to start at the top of this, where they're just a standard pod or a task. And those, when it comes down to it, get the standard SE Linux policy of container T. This means they don't have access to the underlying host at all. They're basically able to get access through what Kubelet provides and get access to metrics and logging and things like that, but they don't actually have access to the host. For those that need a little bit more privilege, you can go into privilege mode. So within your container specification, you can specify that it's privilege mode, or you can add the specific SE Linux policy, which would be Control T, which would give you a little bit more access to that underlying server. And the direction we'd like you to take here is if you don't need access, don't go that route. If you need access, go down this in one step at a time. If you need access to things like the kernel, say you have to perform some tasks that require kernel level access, use eBPF first and see if you can get that working through that. And in that, you'll have elevated privileges to connect to ePBF. And this is the way Cilium works on BottleRocket. This is the way other things work on BottleRocket that need underlying access to the kernel itself. And then if you can't do what you need at that level, then you can go one level below to what we call a bootstrap host or admin container. And these are those containers that run in that secondary space just for admin containers. And these can have elevated privileges using Super T where you can get an actual shell prompt. And so we want to be very careful how you go down this path and make patterns of least privilege. But if, say, you need root level access, maybe you're an ISV provider and you want to do runtime scanning or file access scanning on that underlying host, and you need to get that. If you can't gain access through eBPF, then maybe a host container running your agent with elevated privileges is the way to go. But that should be the only option there. And the way this would look from within your actual YAML files is you would just specify the security context, and then you could specify the specific type. So here in this example, we're asking for system U for the user, specific system R for the role, and then Super T for the actual permissions itself. By adding this in, it's going to override how that container gets privileges, and it's going to automatically provide it Super T. And that's a very powerful access. And so it's really nice that depending upon your workload, very quickly, just from the actual spec for the deployment or the pod itself, you can gain the access you need. Mikhail, is there anything you want to add to that?
Oh, for sure. There are many things that I thought probably our users would like to know about BottleRocket. I asked to start with what is the practical benefit of it, given the security, and it's not just security, it's effectively the container optimized OS. It has a very small footprint and it shows itself in the uptime. So effectively you want to bounce a node in your Kubernetes cluster, for example, or you want to maybe perform an upgrade of the OS itself using the partition mechanism and this transactional index we're talking about. at that point, it becomes very fast and the uptime is increased. And that's one of the reasons. But it also not taking away that level of access to the OS in principle, like, for instance, with Fargate, when you are completely isolated from that. And as you pointed out, a lot of partners, and like Cilium, for example, or like Calico with Tigera, they have a need for eBPF access, and that is still possible. So it sounds like it kind of acts in between those, the best of both worlds. Still, you gain a lot of performance and security improvements, but you have a little bit more invasive access compared to a full isolation from the OS level.
Absolutely.
And bringing in a question here from chat as well, is BottleRocket focused on startup time? Is that a specific goal of BottleRocket, or just happens to be, you know, when you strip out an OS and make it run less things, we also get faster startup time?
Well, performance sometimes is not the primary concern, but is a byproduct of a well-architected framework or a well-architected OS. If the OS is purpose-built for that task, then performance becomes one of the benefits, and is a very fortunate one in our specific case. But I'm sure there was a lot of effort put in just performance improvement as well as hardening and security improvements on BottleRocket.
Yeah, absolutely. That's 100% correct. And there are a lot of benefits. It's not just the speed of the boot up time, but if we're looking at things like the update process itself is also benefited from the minified operating system and the fact that we've made it somewhat atomic. So in like other container OSs that are out there, things like Flatcar and others, we've decided to make this an atomic operating system. So when you actually install it, you get out of the gates 2 partitions. And this is optional. If you want to build your own variant, you can actually remove this if you don't want to go this route. But for the EKS variant and ECS variant, it comes with 2 partitions. One that's the running partition that has the operating system in it. And when you download a new version of the operating system, it goes to the secondary partition, and it's a full reboot. So once you reboot over to it, it either works and cuts over, or it fails and you go back to the running partition. And so the update process is a very fast process because it's done in those stages. You know, you can start it, have it there waiting until you're ready to actually do that reboot, and then it's a very fast reboot.
Yeah, I think it makes sense to also point out something that you mentioned, like Container D is actually used to run containers, and that one is also an optimized pipeline. Not only your reboot is faster, but also container startup time is faster, so that's increasing the overall uptime of the OS.
Yeah, and I do think it's important to also kind of touch like how the actual update process happens, and I've got that on the screen. And this is something that can be a little bit different for people. You know, if you come from the traditional operating system update process, like you're running yum updates through some kind of configuration management tool and then waiting for all those packages to go through and download. And there's a lot of that risk that comes with that, where if one of those packages fails or a dependency isn't available, you know, you're sitting basically waiting for these updates to go through. But the way we've done this is, like I said, it's an atomic update, but it's handled in waves. And I think the best way to describe waves, because this is kind of tricky for some people, and I know Garrett, Justin, during your initial talk on containers on the couch, like we had an issue with that one. But yeah, this is a stumbling point where it's much more like Android when we do updates, where the project itself releases the new version, but all of the actual installed running operating systems or running versions of it basically go in what we call a wave pattern, where we've decided, based on some kind of cryptographic scenario, which instances will get a new version and when. And we don't do it all at once. And the idea here is we want to roll this out in phases, let you see and test your workloads and make sure that they're working as you could, or the way that they should. And then basically over time, they will all become in sync and running the latest version. Now, there are ways to override this. So you can basically say in your setup, ignore waves. And this gives you a lot of control over saying, like, look, I want to manually control when I get these versions. I want to manually control how they get out there. And so you can tell it to just not listen to that and ignore those waves. But the way that we want you to do this, and I'll let Mikhail kind of cover the update. We want you to try and do this in an automated way first, and then fall back to a manual way if possible. And so Mikhail, if you want to go through this, go for it.
Oh, for sure. So I think it's important to point out why this update process, why we talk about update process from the very beginning when we talk about BottleRocket. This is the very first question that we get from our customers. Well, yeah, it's a new OS. Do you guys handle OS patching? How exactly is it going to work with a container orchestrator such as EKS or ECS? Do I need to do something manually, or AWS is going to handle all of that for me? And the answer to that is a significantly improved user experience and customer experience when it comes to BottleRocket, depending on what kind of node groups you're using with, let's say, EKS, whether you're using self-managed node groups or you're using managed node groups, your experience is still going to be very pleasant, hopefully. With the self-managed node groups, we provide a Kubernetes operator, and it's also relevant to mention it in the context of our new offering service, EKS Anywhere, which was launched fairly recently. That Kubernetes operator can take care of detecting the new version of the OS, and we do it both for EKS in the cloud as well as for VMware OVAs for EKSA, and apply those updates. And this transactional wave patterns enables us to do it in an atomic way. In a transactional way, that means that if something goes wrong, we can always roll back to the previous state. In addition to that, that update process, if something happens to the kernel, which the rootfs is marked as read-only, we use DM very effectively to create a checksum on effectively a hash on the state of the kernel, and we can always reboot and get rid of that change and restore the ideal state of the operating system from the golden partition, so to say. So with managed node groups, we support it in a way right now, but we have a new exciting feature coming very soon, which is going to be using BottleRocket as a first-class citizen with managed node groups. And the experience for the customers is going to be very aligned with the experience with any other general purposes, whether it's Amazon Linux or Ubuntu with the managed node groups.
And I wanted to bring in this question too, because you keep mentioning the upgrade process of writing to the other partition, but the operating system is read-only. Can you explain why we describe the operating system as read-only, but at the same time, we're doing in-place upgrades and actually writing to disk an upgrade process?
So yeah, it's a little bit of a misnomer that it's read-only. There are a few read spaces like temp, like /temp is naturally writable. But like to Mikhail's point, we have DM Verity on there. We have a few things in place to prevent certain applications from being able to write to that space that don't have permissions to it. But the rest of the operating system is essentially read-only, with one exception being /etc. /etc is where all the configuration needed for the applications and binaries on the OS, that's where that's basically stored and needs to be writable when you boot it up. And so the way that we actually approach that is it's a temp FS that is written when you boot up the instance. So we have a bunch of helper scripts that go through and will take all the configuration that has been provided through the API to basically build /etc for runtime. And then, after that initial boot up is there, you've got things like the SE Linux policy and DM Verity in place to make sure that if any changes occur in that particular directory or other directories, it's automatically flagged and it's prevented from being executed, and that system can be flagged for inspection.
And so SE Linux is protecting that at boot time. To Carl's question here, is SE Linux also being used for workload to workload, isolation?
I don't have a good answer on that one. Like the policies in place really to separate the workloads from the underlying operating system. But the reality is, if you're setting up your Kubernetes environment properly, you've got your proper namespacing, you've got your proper network policy in place. If they don't have access to the underlying file system, they can't really cross-talk in that regard. I don't want to say it's a perfect world and that's an impossibility, but it's if you've set things up properly, these shouldn't be able to talk to each other. And even if one does have access down through the SE Linux policy, it shouldn't have access to the other workloads unless you've explicitly given it permissions. Like if you've given it super T, you've basically handed it the keys to the kingdom. So be very careful about how you give those permissions. And then you can also extend these policies. So if you own the system and you want to go through that process, you can extend the SE Linux policy based on your own configuration to make it match what you need. But just understand that if you go through that process, there are challenges in that, and you're introducing additional risk. So make sure you're doing the right thing.
And that was exactly what I wanted to get to, was the default policies we have are about isolating the operating system and protecting the OS from the workloads. And if you're saying, here, this is a privileged workload now, it does have more permissions, but any other policies you want to add for your workloads are also optional, that you can go in and say, hey, I need more policies because we use SE Linux between these workloads. That's up to you to manage inside that environment, and BottleRocket's not going to give you that by default, but SE Linux being enabled does make sure that SE Linux is enforced.
Absolutely.
And I don't know if you had another slide. I did want to mention, I mean, we've been mentioning BottleRocket all day. Everything is just using BottleRocket over and over again. EKS Anywhere has it by default. I don't even think we mentioned it, but Carpenter is using BottleRocket by default. So if you have, if you're using Carpenter for node autoscaling, BottleRocket's going to be the default node type, and managed node groups will be getting support for BottleRockets without any additional configuration. You can say, hey, I want to manage node group. Please make the nodes the BottleRocket OS, and away you'll go without needing anything in addition, right?
Absolutely. And that's the direction we want to keep moving. We want to continue to see BottleRocket being available as a default option. Maybe not the default option, but basically a option in any of the dropdowns for whatever solution you're using. We want to make it so it's seamless and something that can be used to power your containers no matter where they're running. And so looks like Mikhail wanted to say something in particular, so I'll let him.
Yeah, I think at this point, when we talk about what is the right OS for the orchestrator like EKS, for example, and we have a container optimized OS. So the question is, what would be the reason not to use BottleRocket compared to it? So that's the kind of feedback that we would like. Why would you go down the path of using a general purpose OS when you could use BottleRocket with the latest kernel, with the eBPF features, or any features basically enabled by the kernel, and secure by default within your distribution, gaining the benefits of performance and security, obviously, as well.
Yeah, it begs that question of really making sure that when you're architecting your workloads, really understanding what are the actual needs that workload needs underneath. Does it need root level access? Does it need privileged access? If it doesn't, then you can remove some of the undifferentiated heavy lifting around management, around updates, around hardening that may not be necessary for that particular workload. And from my experience, like the vast majority of workloads that I've seen from customers don't actually require that level of permission. So by making that the default, you're getting a little bit more of a benefit out of the gates, and you're getting the performance benefit for your workloads as well. But yeah, I think it's important to call out the managed node groups, like that is coming, and hopefully soon. But the idea there is a lot of customers and a lot of even consulting partners, when they're implementing workloads for customers in particular, they want to do this in as much of a managed state as possible. Like they want to take that heavy lifting off of them. And by having this as a default option there, we're giving you an additional chance to alleviate the management of those underlying nodes, but not necessarily abstracting as far away as like Fargate, for instance. So you're getting that kind of the balance between the two there. And so if you need a little bit more access, you need a little bit more performance, or you need something off that underlying host, you have that flexibility to have that while reducing some of the management overhead. And that update process, just so we're clear on that update process for managed node groups, this is going to be largely a manual process where we'll go through and you basically flag when you want that update to happen. And even when we consider the automated process, depending upon how you've spun this up, you can use EKS CTL, Terraform, CloudFormation, you got the managed node group option itself. When you think about how that's provisioning it from an infrastructure as code perspective in AWS, there's going to be a launch configuration and an autoscale policy probably tied to that. And it's going to have a specific version of that BottleRocket AMI in there from when you initially spun it up. And so we want you to kind of consider that in concert with that automation, where the operator will keep it up to date and make sure that the nodes you have are running the latest. But at some point, you're going to have to go through a process and perform an update to make sure that launch config is using that latest version. And so I don't want to make it seem like it's this magic thing that does everything, because as soon as we flip that page, people go, aha, I caught you. I want that to be very clear. There's one little check there that you have to make sure is ticked. But it aligns with the rest of the processes you're probably doing today. node group replacement at regular intervals, making sure you're always on that latest version. It's just, we've added one level of automation on top of that to help simplify those processes a little bit more.
For sure. I mean, and I can add to that when you say it's a manual process, the part that is manual is just your intention to upgrade to the next version per cluster. So that intention is manual, but also it gives a sense of security, because let's say I'm running mission critical workloads in my production cluster, and all of a sudden decides that there's a new version of BottleRocket and let's swap it out. So a lot of customers prefer to have this control, so they know exactly when it happens. And as we observed with the operator, we also have a mode when you have to explicitly show your intention to upgrade, or it can do it in the background, and customers start with the semi-manual process of explicitly calling it out, and then when they give it a shot to do it on the background, they enable that mode and just forget about it. And they know that the BottleRocket OS is always the latest, and our cadence is 6 weeks. We release it effectively every 6 weeks, and it impacts both EKS, AMIs, or EKSA.
And the operator for upgrades is Kubernetes, like you're mentioning autoscaling groups, if I have a launch template, but even outside of AWS, the operator still works if you have a cluster. I saw one here for EKS Anywhere, where you can run the update operator inside an EKS Anywhere cluster, and there's nothing specific there that requires AWS to do those upgrades on the OS, right? Because it's a CRD with a controller that looks at those operating systems and says, okay, we need to reboot these in a scheduled manner, right?
Yeah, it's basically going to communicate with the API that's running on each of those nodes. And so basically it's going to say, is there a new version available? If so, stage it. Once we get that flag saying that it's staged and ready to go, then we go through and trigger the reboot process. And so it's all handling that locally on those environments. And so it doesn't have to be running in EKS in the cloud, but it can be running in EKS Anywhere. It can be running in even ECS, and it's going to go through that process. And as we continue to expand the project to ensure that it works on other environments and other providers, that process should be the same. And if you look at what we've done, where we moved to the EKS Anywhere implementation, that implementation is based off of VMware. And it's really one of the first steps we've taken in stripping out the AWS specific portions of that variant to go in that direction. So at one point, the next step will be to make it so it runs on other operating systems and bare metal or not other operating systems, but bare metal and other providers as well.
Yeah, I think it's a great point that it is an open source operating system. Basically, there is nothing specific to AWS that inside that operating. You can use it with self-managed Kubernetes. You can use it to just run Docker images on your laptop as well, or in a VM. We do accept PRs. We do encourage participation from the open source community, and I'm looking for your feedback.
Yeah, I would say that adds one last point of clarity that I think should be provided. As a project and what BottleRocket actually is, underneath, like when you look at what its core purpose is, it is a host OS builder. So it's the tools and the SDK that allows you to build the actual operating system itself. The variants are those versions that include the specific config. So if we look at it from a project perspective, it's really designed based on open source tools to be able to build BottleRocket variants that can run wherever you need them. We've taken the time to go through and provision variants for EKS, ECS, and now VMware for EKS Anywhere, and we're going to continue that process. And if anyone wants to participate and help, by all means, you're welcome to join the project. You're welcome to submit issues. You're welcome to participate with PRs. I have a talk coming up at reInvent that me and Sam are going to give. Sam's one of the engineers on the project. We're going to give a chalk talk at reInvent on how to participate in the project and get started. And so we're always welcome to support and feedback from the community. And if anybody wants to get engaged, by all means, ping us on Slack or on the developer Slack, ping us on Twitter, or participate through the project itself.
That's awesome. So thank you, Curtis, Mikhail, for coming. We're going to take a quick break before our next section on IPv6. And if anyone has comments, go ahead and drop them in Twitch chat. And thank you. We'll hopefully see you both at reInvent.
Awesome. Thanks, everyone. We really appreciate the time.
Appreciate it.
Today starts making breakfast for the family. Doing my secret toast with an omelette. A solutions architect is like a cloud therapist. You need to earn the customer trust. I'm obsessed with data. We focus on infrastructure challenges so our customer can focus on their business challenges. My name is Yahav Viran, and I'm a solutions architect at AWS.
Our job is very simple: secure, efficient, and then enable the heck out of the hundreds of DevOps teams that we have across T-Mobile. AWS has really played a huge role in our modernizing our infrastructure and ecosystem at T-Mobile.
Today we run like 1 billion requests a day on AWS just on our container workloads. So we have used EFS infrequent access. EFS is, as the name suggests, it's elastic. So it can scale up and scale down per demand. We don't have to worry about pre-provisioning a storage. Teams are non-container based workloads. They have access, as long as you have like appropriate tags, you have access to go ahead and provision EFS solutions for you. If you need any extra help on it, we talk with those application teams to configure EFS solutions. The second aspect of self-service is in the container workloads. We enable application teams to use AWS EFS automatically in a Kubernetes cluster. You would just need to write a few lines of code and use Kubernetes manifest to just go and provision EFS cluster, and you can use it in the PVCs. Our requirement for FSX was primarily on big data analytics. A lot of these teams use FSX solutions to get the reporting data as quickly as possible. So the real good thing about FSX is like it's fully managed, and the performance is much better compared to our solution what we had. We actually optimized in terms of like 50 to 60% of cost. It was pretty straightforward for us to migrate these solutions into FSX. Many of the things what AWS provides, we just go and just use it because it saves a lot of time, saves a lot of cost in many of the cases, and scalability. And most important is the reliability aspects of it.
We're continuously delivering value to our end customers on a daily basis versus monthly basis. And what that's allowed us to do also is we've been able to go to market in small markets or with a small subset of our population and do A/B testing for our care and retail applications. And what it's really allowed us to do is get a very broad sample size of what's working and what's not working for our frontline and for our customers, and then to iterate on that and quickly get adjustments and different tweaks out to the market very quickly. So a lot of that has been enabled with our kind of cloud native transformation, and a lot of that work is obviously running within AWS as well.
Hi, Sheetal. Oh no, can you hear me? I hope I'm not muted again.
Hey, yeah, hi, I was muted. Sorry, I can hear you now.
That's all right. Hey, Mike. Actually, hi, Mike. being in person is new for Containers from the Couch. Thank you all for sticking with us. This has been just so much information today, and I hope everyone's learning a ton. This next session was talked about in the very beginning. Bob was mentioning it for IPv6 support in EKS, and Mike and Sheetal here are here to talk about it further. Like, what does it mean to get IPv6? What does it mean to have pods that have that giant long string? Something about grains of sand can now be part of IoT. It's kind of crazy. So, Mike, you had an introduction earlier. So, Sheetal, introduce yourself. Tell us what you do.
Hi, I am Sheetal Joshi. I am a developer advocate on EKS team, and I'm very excited. I know it has been a long day for everybody here listening, and I hope the demo gods are with us at 5 p.m. EST, and hoping to give some great insight into IPv6 and what we have implemented here.
Yeah, sounds great. So I know Mike has a couple slides to kick us off, and then we have a demo of IPv6 running in EKS clusters with pods. So Mike, go ahead, let us know about the update.
All right, so IPv6 update. It feels like IPv6 is
at most companies is next year's project, and it's been that way for the last, I don't know, 10 or 15 years. But at EKS, it's this year's project. We've been hard at work throughout 2021 on adding support for IPv6, and we'll show you that with a demo coming later, and we'll be launching this pretty soon. So we're going to walk through some IPv6 basics, how it works in the VPC, how it'll work in EKS, and then do the demo. Why IPv6? I think this graph makes it pretty clear why we need it. When IPv4 was invented back in the 70s, we didn't consider all of the connected devices and IoT devices and the proliferation of devices that require an IP address that was coming. And so today, public IPv4 addresses are a very scarce resource. And really, to work around that, we've done all kinds of crazy private natting workarounds. That's really just ugly and difficult to work with. And the solution to that is IPv6, which is a massive public space of IP addresses, and it really addresses all of the shortcomings with v4. Adoption of IPv6 has certainly been accelerating over the last several years. 5G, 4G, 5G networks have been driving it. A lot of countries now have pretty substantial v6 internet utilization. You may notice, if you run a ifconfig command on your home network, you may notice that you get v6 depending on your internet provider. So it's becoming more and more common, and it's definitely the future of addressing. And additionally, one of the things not is well known is you actually get slightly better performance and lower latency with IPv6 compared to v4 in most regions of the world. Now, how an IPv6 address looks may be a little foreign to some of you used to the dotted notation of IPv4. IPv6 uses hexadecimal to represent an address, and it's broken up into 3 parts. The first part is the global routing prefix, and this generally is managed by your internet service provider, or in the case of AWS, this will be managed by the VPC if you choose to use Amazon-owned space. The next part is the subnet identifier, and then finally the network interface identifier.
No, wait, Mike, I was told IPv6 had no subnets. What are you talking about?
IPv6 has subnets. We're still doing subnets. We're still doing private networks, and we'll talk about all that. It just works a little differently, and it's much cleaner.
Do I get a slash anywhere in here? Like, I mean, there's colons now. It's just like more dots and letters. I don't understand.
We'll get into some of the details. I think when Sheetal does the demo, she'll show you exactly what it looks like in a real-world v6 scenario. So the size of IPv6 versus v4, it's a number that's hard to comprehend for humans. I think if you gave every atom on planet Earth a v6 address, you could do that 100 times over for another 100 Earths. The other stat is the Earth is 4.5 billion years old. If you were assigning IPv6 addresses at a rate of 1 billion every second since the Earth was formed, you've only used a trillionth of the IPv6 space. So it's a very large number. It's unlikely to run out in any of our lifetimes. So to summarize, with IPv6, you get a much larger address space, and there's also some built-in authentication, encryption, and better performance. So it really addresses all of the limitations of IPv4. So now how it works in Amazon. VPC has supported IPv6 for a number of years now, and then it supports it in dual stack mode. So with the VPC, today you cannot yet do IPv6 only VPC, but you can do v4 and v6 dual stack VPC. So you can add a single IPv6 CIDR block to a VPC. You can either bring your own or use an AWS assigned one. For subnets, you get, it's a fixed length. It's a /64. There's the slash you were looking for.
Thank you.
So you can get up to 256 subnets per VPC. And then /28 is an individual address assigned. And actually not shown on this slide, but how EKS is going to work is the recently launched prefix assignment feature from VPC where you can assign a /80 to every node. So different sizes, different slashes, and we'll cover this more.
How many pods does that mean if I have a /80?
I think a /80 is 13 trillion addresses, if my math is right. So,
I don't know of a node size that would fit that many pods, but okay.
Yeah, I don't think you're going to run out of addresses for pods with the /80. And just to show you here the comparison, if you look at a node or an instance in a dual stack VPC, you'll see the different addresses, one for v4 and one for v6. Okay, so this is a common question in IPv6 because it's a globally public address space. One of the first questions is, what about private subnets? How do I protect instances in a subnet? And the answer to that in VPC land is the egress-only internet gateway. It's similar to a NAT gateway, however, importantly, no additional cost. And if you add this to your routing table in a private subnet, traffic can egress from the VPC, but external traffic can't hit your v6 addresses in that subnet. So that's how you do private v6 in the VPC land. And then all of the normal features that you're used to in a VPC, network access control lists, security groups, all that still works. You're just, the source address in the rules is going to be different to target IPv6 addresses versus IPv4. But everything you're used to in VPCs, all of that still works. So putting it all together in a VPC, today it's dual stack mode. Resources can communicate over v4 or v6. They're independent, configured separately. For public networks, you're going to route the default route to the internet gateway, just like you do in public subnet with v4. For private, it's a little different. Instead of routing to a NAT gateway, you're going to route to the egress-only internet gateway. Okay, so that's all the background. How is it going to work in EKS?
Now, this is Kubernetes. Shouldn't this be like 8? Like at least, I'm sorry, it's a bad joke. It's been 6.5 hours. I was thinking IPv8's just, but it's okay. We can keep going and just ignore.
Yeah, we didn't make it all the way to 8.
I was like, we can go with branding here. I mean, like even 7 fits inside the Kubernetes space because of the original name, but 8 would be nice. But I guess we'll just stick with 6.
We'll stick with 6 for now. So let's talk about how Kubernetes networking works. Kubernetes networking is a flat layer 3 network where every pod gets its own IP address, and pods have to be able to communicate to each other without any network address translation. And that makes it very easy to port applications from a VM-based world into Kubernetes, but it has a lot of IP address requirements, and many VPCs with IPv4s aren't equipped to handle that. We've heard from a lot of you that you're running out of the private IPv4 space in your VPCs. And so how v6 is going to work in EKS, I think Bob mentioned this morning, but it is not Kubernetes dual stack. Every pod will not get a v4 and a v6 address. Instead, every pod will get a globally unique IPv6 address assigned per pod. But if your pod needs to talk to something outside of the cluster, whether that's some public website that doesn't support v6 yet or some AWS service that doesn't support v6, the nodes are still dual stack and the traffic will be routed through the node. So you really get the best of both worlds. You can adopt IPv6 in EKS without needing to have the rest of your dependent services support IPv6 already. And so this is coming soon. We're in the final stages of testing and rolling this out, and we'll show you how it works in the demo. Just a couple more slides here. So in v6 networking, I mentioned this a little bit, but every worker node will get a /80 prefix, and you can see that ENI prefix on each node. And then when a pod gets scheduled to the node, the CNI plugin will take an IP from that prefix and wire it up to the pod. If a pod is talking to another pod on the same node, that'll just go through localhost. But if it's talking to a pod on another node, that'll actually go directly over IPv6 in the VPC. So I mentioned pod to pod. Pod to external IPv6. This is where it's much simplified compared to v4. In v4, you have to route through a NAT gateway before you talk to something in the public internet. With v6, if the public internet endpoint already supports IPv6, it's just a direct route. So no more complicated NAT routing setups. Whoops.
I don't know why I never even thought of that, where if IPv6 is at the destination, there is no NAT between me and it. That's okay. That just, I don't know. I just dawned on me, and now I'm just freaking out about that. That's crazy.
It's drastically simplified.
Right.
On the other hand, if the endpoint you're talking, so if you make the DNS call, if the endpoint supports v6, it'll get the v6 address back. If it doesn't, and it returns a v4 address, then we have to go through this route shown here, where the traffic's routed through the worker node, then through the NAT gateway, then to the address. So a couple more hops, but this makes it much easier to transition to v6 and EKS, versus if we just did IPv6 only, then everything your pod needed to talk to would also have to be v6. Okay, I'm going to hand it over to Sheetal to show a quick demo of how this is all going to work.
Okay, thanks, Mike. Just in the interest of time, I have already created a best practice VPC for EKS cluster. So what we are seeing here is VPC with IPv6 enabled.
Can you make that bigger for us?
Okay.
One more time. Thanks, good. Thanks.
Okay, cool. And we have 4 subnets that we have created, 2 private and 2 public subnets. Is it all visible for everybody?
I can see it okay.
Yep.
Okay, and each of the subnet, as Mike previously mentioned, you can see /64 IPv6 header assigned and /24. So you cannot just have IPv6 header for a subnet today. So we both have IPv4 and IPv6. This is just the requirement from the VPC currently. And let's go back to VPC here. The route table that we see here, let me show yeah. Okay, so if you see, all of the IPv6 traffic is routed to egress only internet gateway, while it is through the NAT gateway for the private subnets. Let me hop on to, the egress only internet gateway is just similar to NAT. You don't do anything separately. It's free of cost, and then the same, cost applies for the egress internet gateway. Let me jump back to the cluster creation here. Let me see. Okay. Can you see the command that I'm sharing? Okay.
I can see the terminal, but I can't read it at all.
Okay. Is it any better?
Keep going.
Cool. Okay. So I have already provisioned EKS.
Can you make it a little bigger, Sheetal?
Okay. So I have already provisioned an IPv6 cluster. As you can see, the cluster provision itself is very much similar to IPv4. Just you will see some extra flags saying Kubernetes network config IP family as IPv6, right? It's not like a dual stack IPv4, IPv6. We are just going with an IPv6 model. So you will see Kubernetes network config as IPv6. Let me share the cluster, which is already provisioned via the console. Yeah, as you can see in the networking configuration.
Make that bigger too.
Oh, sorry.
Sorry.
Cluster IP address family as IPv6, and the service IP range is from the VPC IPv6 header range that is assigned. All of the server endpoint access models, the public, private, and the public still applies. You can actually provision the cluster endpoint in all 3 different modes that we support today. That doesn't change. And the add-ons, I don't have anything here, but the add-ons are going to be supporting the IPv6. There are some of the add-ons which might not be, but that the list will be published soon. From the let's go to the nodes, understand the nodes. The nodes that have been provisioned are connected to the cluster using the IPv6 endpoints. So let me share the nodes. Okay. And so they use the IPv6 address to communicate to the cluster endpoint. And let me take to the EC2 console here. So as we talked about, as the nodes join, we still use the VPC CNI in the background. And what VPC CNI, what we do here is we do leverage the prefix assignment mode. And as the nodes join the cluster, we do assign one single IPv6 prefix, which is /80. And this is the significant difference from what happens in the IPv4 land. We do not need once single prefix is sufficient enough to run the large cluster and with multitude of the pods in it. So the IPv prefix assignment happens during the instance launch time, and one prefix is enough. So we do not do any more EC2 control plain API calls with it's just at the launch time we do assign one prefix. So this is the IPv6 prefix assigned to the primary ENI of a node, and the pods will be assigned addresses from this prefix. So let's jump on to understanding how does CNI differ, right? We still allow pods to be communicating to IPv4 endpoints because we do understand not everything is IPv6. Everybody is still trying to get on to IPv6, but that's not the reality. So how does it work, right? So let me log into one of the node.
Can you make it bigger again, Sheetal?
Sure.
Keep going.
A few more times.
Okay. Let me know if this is better.
I can read that.
Okay. So internally, we do the CNI chaining, and for egress only IPv4, every node gets the host local CNI plugin and from a local IPv4 CIDR range. And this IPv4 CIDR range is not going to be visible or routable outside of the node itself. It's just chained along with the regular CNI plugin. So let me go to one of the pod that I have already run. So what does it look like within a pod, right? So the pods get ETH0 for the primary interface. There is an
Go ahead
IPv6.
and pinch to zoom that one too.
Okay. The pods get the IPv6 address along with the IPv4 address as well. The pod-to-pod communication on the cluster, it is always IPv6, and anything trying to communicate via the IPv4 will be blocked. So let's understand. Let me schedule an application and then see how do we provide an ingress access to our application, right? So let me open up. Okay, so I'm just deploying a sample game application, and the service that you see here, here we are using the ingress mode, and when we provision an ingress, it provisions an ALB, internet facing, and you will mention, okay, I want a dual stack IP address. What does that mean is an ALB which is provisioned will have an IPv4 endpoint as well as an IPv6 endpoint, so that IPv4 outside applications or a user or your browser should be able to communicate to your application, as well as an IPv6. And today we only support target type IP mode. We are working on an instance mode, but it should be all seamless for you. So let's see how it all works. Let me apply. Okay, so let's see if we have the deployments. Okay. Yeah, so let's give a couple of minutes for this ingress to come online.
And you mentioned you're using Ingress there in your spec,
Yes.
but you didn't mention you're using the AWS Load Balancer controller, which provisions that load balancer from as an Ingress type, which is neat. Which if people haven't been using the new load balancer controller ever since the 2.0 release, you can deploy Ingress to an ALB directly from that controller. So
Correct,
it used to be the
yeah.
ALB controller. Now it does a lot load balancers for services, NLBs, ALBs, Ingress, all of that stuff. So the new controller, just shout out, we didn't even have a time for a session today for it, but has done a lot of stuff in the last year.
That's correct. Thanks for reminding about that, Justin. So let's go back and check how it all happens. So let's see the load balancers, whether the target groups have been registered here. Sorry, it's session expired.
Always expires right when you're doing the demo. It knows.
Yeah. Yeah. So the listeners, if we go back, so this is the other effect of zooming in too much. Okay, so you will see all of the IP addresses. These are the IPv6 addresses of the pods that get registered, right? So this is all the magic of Elastic Load Balancer that basically is doing for you in the background. So let's check the connectivity. And before I go there, let's confirm the pod IPv6 address. Let me exec into one of the pods that we just provisioned. Sorry, I just...
Here it is.
Okay, you will see the new pods that are scheduled also have an IPv6 address along with the IPv4 from the host local range that we have configured. I am gonna perform some IPv6 connectivity as well as the IPv4 on just to see how does it resolve from a pod itself. Just for a test, I have provisioned an S3 bucket just in an IPv4 mode. And we should be able to reach that S3 bucket from within the pod. Let's see, do a sample curl from the pod. Yeah, so I'm just saying use IPv4 mode here, and from within the pod, it's able to resolve to an IPv4. It's all dynamic. You don't have to do anything specific extra to figure out whether you're reaching an IPv4 or IPv6. The connectivity just gets dynamically routed for you. Let's see if our load balancer is provisioned now, and I'm going to try resolve to the same IPv6 load balancer endpoint from within the pod. Sorry, I am within. So when I try to do it with the pod, it is an IPv6, so it should call to the IPv6 address. Yeah, so we are able to basically reach an IPv6 endpoint from within the pod also. And if I try to basically go resolve an IPv4 endpoint from within the pod, that shouldn't be allowed. IPv4 connectivity from within the pod will be disallowed. And I think I should be able to get to my application from my IPv4 browser. I do not have IPv6 enabled. So it should still work, and you can ingress into your application from outside. Yeah.
So everything here at the pod has IPv6, but everything is just transparent. You can route in and out
Yes.
IPv6, IPv4.
Correct. Yeah.
That's great.
And because I'm actually trying to connect from my browser, which is an IPv4, so it just resolves to NLB IPv4 endpoint to the IPv6 targets pod in the backend.
Wow. That's really cool. So that's coming soon for IPv6 support in EKS. I'm sure we'll have a launch blog and some more information once that's available. And yeah, that's in. Mike, Sheetal, anything else to add?
No, I think that was a great demo. Just to be clear, this is all still coming soon. There'll be a new version of the load balancer controller coming to support v6. There'll be a new version of the CNI plugin, and then there'll be updates to EKS itself. So we're getting close. Final stages of rolling this out. Look out for the announcement soon.
Sounds great. Our next session is with what is it? Oh, it's CloudMap. Jesse and Yaramir. So thank you, Sheetal. Thanks, Mike. We'll see you again soon. Hopefully you're around KubeCon virtual or Mike's here in person. If you're at KubeCon, come say hi. And we'll pull up Jesse and Yaramir. Welcome back.
Hi, folks. Happy to be here.
Hello. So it's cool. We're going to transition from talking about a whole lot of addresses in one place to how to work with name resolution and service discovery across multiple clusters. That seems like a good transition. How you doing, Yaramir?
I'm pretty good. I hope you can hear me well.
Yeah, we can hear you fine. Do you want to introduce yourself?
Yeah, I'll be happy to introduce myself. So again, my name is Yaramir Vanek, and I'm software development engineer on AWS CloudMap team. And today I'm going to talk about running applications in multiple Kubernetes clusters. In other words, multi-cluster setup.
Awesome.
So let me briefly start. I would like to just start with basic use cases for multi-cluster scenarios, because oftentimes it may seem like why would anyone want to run multiple clusters when just a single cluster is more than enough complexity already. But definitely there are use cases, and first of the perspectives is high availability pretty much. So obviously running a single multi-tenant cluster may be actually a single point of failure in the system when the cluster fails because of bad configuration or anything else. Also, with multi-cluster setup, we can get automatic failovers. Let's assume the service runs the same service. Let's say my web server runs across multiple clusters at the same time. When a single cluster fails, doesn't matter. Clients can still reach the other clusters in the group. Quite related to this, it makes multi-cluster setup makes Kubernetes upgrades and all other upgrades and migrations easier, because instead of migrating and changing the Kubernetes version in place while everything is running there, maybe it's easier to actually spin up a new cluster separately and then gradually migrate everything like service by service. But for this transition period, we have multi-cluster setup because some services are running in the new latest Kubernetes version, some services are still in the old Kubernetes version. So actually multi-cluster setup can help with this as well. And very different perspective is security and isolation between teams and organizations. It's a bit obvious that it may not be a great idea to give access to everyone across all organizations to a single cluster when it needs to be like from the security perspective and compliance perspective, but as well as isolation between different Kubernetes settings. Maybe networking setup needs to be different, the preference is different across teams. So it's again like another example where multi-cluster setup can be beneficial. And so let's just assume that there are many more use cases for that. So let's just assume we want to have multi-cluster setup. And now for the rest of the talk, we will discuss how we can achieve that technically, like what can we do to support that. And for me, the crucial topic here is service discovery, and not just because I'm from the CloudMap team. I think it's crucial because services in clusters need to interact with each other, and to interact they need to discover each other. So I just want to quickly recap here how this works with like when we have just single cluster. So the service discovery in Kubernetes clusters, that's something that's built-in mechanism there, and is based on DNS protocol. So essentially, Kubernetes creates a DNS record for us for each running service in the cluster. So in this specific example, when I have a single cluster and I have service A and service B in a local cluster, and so one service needs to reach to service B, it can just use this DNS record following this schema. So it's a service name, that namespace name as an identifier of the service, and then there is a standard suffix svc.cluster.local. And if I send the request to this host name, it just works. The service discovery under the hood works out of the box. But what if we have the multi-cluster setup? Like, what if the service A wants to reach out to service C? It's not that easy. If I follow the example from the previous slide, I'm not gonna get there. And like usually there are workarounds like exposing the service through load balancers or ingresses and some other workarounds that are complex. Luckily, there is a solution, or at least there is an emerging solution for that. So the community, the Kubernetes community proposed new API extension. The official name for this is Multi-Cluster Services API. And essentially what it does, it extends the service resource concept beyond the single cluster boundary. It works it introduced two new custom resource definitions, CRDs, and specifically service export and service import. It's like the usage from the user perspective is super simple. Whenever the service export is deployed to given service, like to give an existing service, it will pretty much extend the service outside of the cluster. So from that moment on, the service is accessible globally, let's say, or at least from other clusters in the group. And then there is a counterpart to this. There is service import, and that means like every service export from one cluster becomes a service import in all other clusters as a placeholder there. Also, as you can notice, the current version of this API is V1 alpha, so it's pretty much experimental. It's not part of the Kubernetes core yet. And also, this is one of the downsides. And other thing is that this implementation, this API proposal doesn't imply any concrete implementation. So it just defines how it should behave, but the behavior may be different depending on cluster provider or different deployment networking and different deployment types. So what we are proposing and what we are announcing today is a new CloudMap multi-cluster services controller for Kubernetes, which is a specific implementation of this community proposed API. It's an open source package that just has been published to GitHub, so feel free to check that out. It can be deployed as a standalone controller through Helm charts, so it is pretty much compatible with any recent Kubernetes version. You just need to deploy the controller, and you get the multi-cluster services features, multi-cluster services feature just by that. But also, I should mention the work is still in progress. It's similar to the API. It is still experimental. So we are publishing early prototype here, hoping that we'll get early feedback from the community, and also we want to support and get some traction for this package as well for the API. So
real quick, I want to just back up a little bit from where, let's say I had two clusters. If I wanted to do it today, I have two services that need to talk to each other. And in that case, I need to expose those services with a load balancer, ingress, something that allows it to be exposed. I could do that privately in the VPC or something as well. And say it's like it's not a public load balancer, so that those two endpoints can talk to each other. But I don't have a way to say where the other service is, right? Like I have to like hard code like, oh, it's this load balancer, or I have to make Route 53 entries manually to kind of make sure those things can see each other, because it is outside of that core DNS internal to the cluster environment, right?
Exactly, that's exactly the case. And in comparison here, I can just define a service export and everything happens automatically.
Right, and so in this case, I have those two clusters with this new controller. One controller, I export a service, and the other cluster, I import a service. And then they magically they figure out, depending on how that's implemented, where that exists. And I don't necessarily need to expose a load balancer at this point to do that. I don't need Route 53. I don't want to manually put Route 53 entries, right? Like I'm just making sure that what I used to have to do to get two clusters or two services to talk to, all of that kind of just goes away and is handled through these exports and imports.
Exactly. I think I'll be showing the live demo after this, so we can discuss this in detail, and I'll show what steps we need to take to make this work. But just to answer this question, I think I'm gonna use this slide with the architecture overview, because it actually shows like how exactly it works under the hood. So if I have my multi-cluster scenario, I have two clusters along each other. So cluster 1 and cluster 2, and in the middle I have AWS CloudMap. I haven't mentioned that before, but that's the engine that actually this whole thing is running on. So for those who don't know what AWS CloudMap is, it's a pretty much a service managed service discovery solution in AWS space. So it works as a service registry. So in our example here, it works as a shared storage between all clusters. So both clusters are running the controller, and the only task for the controller is to monitor the Kubernetes API server and state of the cluster and synchronize this with CloudMap. So all clusters will store their services, register their services and corresponding endpoints to CloudMap, and CloudMap behaves as a shared storage here. So if we follow the path of, let's say, service C, we can see that service C is being exported to CloudMap, and all other clusters can see the service C exported there, and they'll introduce service import, which is essentially a placeholder, local placeholder for the service that can be used as if the service was running locally. So it's completely transparent then for the client.
And in that case, CloudMap with this controller is kind of acting like a global core DNS for us, right? It's giving us those DNS entries, and it's doing that syncing between the clusters because the controllers are looking for what's an export and what's an import.
That's right, yeah. The CloudMap behaves as a shared storage that's not like Route 53, but it can be a replacement for that. Like it's just the scalability and propagation and performance is better than Route 53.
Cool.
So any other question before I proceed?
No, keep going. I'm enjoying it.
All right. So in the next slide, actually, I'm gonna skip to the live demo. I'm gonna show how all this wires together. So we have the similar scenario as we just discussed. Two clusters. I just remove all the unnecessary services here. So we are having just my Nginx web server in cluster 1. And my task is I have some service A here in the second cluster, and this service wants to access the web server, although it's running in another cluster here. So we can exercise the whole cross-cluster scenario here. So I'm gonna switch to actually to the live demo. So first of all, I'm gonna start with my setup. So I just want to show you what needs to be set up before to make this work, and it's not much. I have my two standard clusters. I'm using EKS for that. It's a standard configuration, nothing specific I need to do here.
Can you make it bigger?
Yes, sorry, I'll make it bigger. All right. So this is my standard two clusters. What I need to do, I just need to install the package we discussed from GitHub to each of those clusters. And there is a second requirement. I just need to make sure the networking works, because when I start clusters in EKS, they are in separate VPCs. They cannot talk to each other. So what I needed to set up as an additional step, I needed to set up VPC peering, which is a single step I needed to go through. So I'm just gonna quickly show here that I have two clusters, and between those two clusters, I have the peering set up. So just to verify, one VPC is cluster 1, the other VPC is cluster 2, and this is all I need to make this work. So I'm gonna switch to my overview dashboard, and let me know if it's readable.
Bigger would be good.
Right.
That seems to be the theme of the day.
Okay, let me go slightly bigger here. So this is my overview of both clusters. Again, like on the left side, it's cluster 1, and on the right side, cluster 2. And the top panel monitors here, like running services and imports. And as we can see now, both clusters are empty as we just started. So this is expected. At the bottom here, I have both controllers running just to show you there is some activity. I'm not sure if it's readable, but it's as I said, it monitors the state of those clusters. It monitors all namespaces, and it says syncing namespace, this and that, and there is no activity because there are no changes in the cluster configuration. So we will make some changes. So first, I need to deploy my first service there, my Nginx, as we discussed. So my service, it's a standard configuration. You can make it even slightly bigger. It's a standard configuration. I'm not using anything specific to the multicluster API. Just I'm deploying a web server Nginx exposed on port 80. So I'm gonna use kubectl to apply this configuration and deploy my first service here. So let's apply, and we should see the first change here at the top. So I have my first service running here, but now it doesn't mean I can access it from I can access it from the second cluster. It's just standard service that the scope of the service is local. I could use the cluster.local service discovery, but definitely cannot do that from the other cluster. So the next step following the multi-cluster API is to make sure that the service is exported. So I need to define my service export. And it's super easy. The type is service export, and then there is identifier of the service, the same namespace and same service name as it already exists. So I'm gonna apply this as well. And now let's see what happens there. So now we have the service export. At the bottom here, we should see that the controller will notify the CloudMap about the change, right, somewhere. And it registers the new service to CloudMap under the hood. But also you can see in the second cluster, what we got here is that we got new service import automatically.
Did you already have that import resource existing?
As I exported in cluster 1, it got automatically imported to all clusters that are sharing the scope in the same group. That means now the scope is my account. So whatever I exported here, or all other clusters are automatically imported. So now, without any additional action, I can just use this import. And now the tricky part: how can I use this import as it was service, because it's not in reality service. And I need to go back to slides for a bit to show you the multi-cluster DNS, because that's part of the multi-cluster API. It also defines the multi-cluster DNS. And essentially, it's an extension of the existing principle that I can use the DNS records to discover my services. In the same way, I can also discover my service imports now. So the only difference is the suffix here. And instead of cluster.local, I can do cluster set.local. That tells the service discovery, I want to discover services in the whole group of clusters, in the cluster set, not just locally. Following this example, I can actually go back to my overview and just use this. So let's say I want to access my new import that disappeared. Well, let's give it a try. So I want to follow the schema. So it's the service name. It's the namespace name. And then is the identifier service and cluster set local. All right. You can see it didn't work because it seems like that the service just got re-imported for some reason. As I said, it's experimental. So let's try it again. And now I get the response. So I'm getting here hello from cluster 1, and it just confirms that now my service A can access the service from the cluster 1 cross cluster. Just to finalize this demo, to show how this works under the hood, I can also go to my CloudMap because it's the essential part here. I can show like what happened there, and it's slightly obvious. I just want to confirm. So I should have my namespace there. Yeah, sorry about this. My namespace is. So it was my namespace, is my identifier, and I have my service here exported, and obviously I have my endpoints here exported as well. And this is what happens, what is imported later as endpoint slices, and it's used when I connect to this service using the service import. Let me switch back to the slides. So just to finalize my demo, here is the list of resources. Definitely, the first one is the package we just open sourced. Definitely feel free to check that. Feel free to give it a try. Feel free to open issues there. There are already existing issues, and we continue with the development in open. So everything is going to be tracked there. So feel free to open your own issues if you find something. And the second link is the multi-cluster services API proposal. Because what I presented, I simplified quite a bit, and the proposal is much more complex and definitely worth reading this in detail. So yeah, thank you for your attention. And I believe we can get to questions if there are any.
Yeah, there's a couple in chat here. First one I want to bring up is this regional? Is exporting this on a per region basis? I'm assuming as long as we can peer the VPCs, we can expose those routes?
That's a perfect question. Yeah, it is regional because of CloudMap is regional. So, but it doesn't mean it must be regional. So we can have multiple clusters across regions, but then we need to pick a single region as a storage for our shared services. So we need to pick and define for the controller to use one of those regions as the main one to store services in CloudMap.
And I'm assuming at that point, multi-account would also work if they could both talk to the same CloudMap, because CloudMap's your kind of point that both of the controllers are talking to. So as long as you can route between the VPCs and you can talk to the same CloudMap database at this point, right? It's being used as a database to store these entries, then you're fine.
Yeah, that's a perfect observation. Exactly, like the controller just needs some credentials to CloudMap. It can be shared credentials to the same account, and then this account works as a storage.
And VR Linux is asking also if there's additional load balancing on top of if you want to use the MCS controller to expose these services that needs to be used.
Well, the thing is, like, the Kubernetes networking should take care of this. We can have a example when the same service is being exported from multiple clusters. So then we need load balancing between multiple clusters. But then it's a task for the Kubernetes networking to decide and to pick the closest endpoints. It will, from CloudMap, it will get list of all available endpoints in the cluster set with maybe the region, AZ, and the locality. And the vision is that the Kubernetes networking should pick the right closest endpoint by some preference. But it's outside of the scope of the controller. It relies on Kubernetes.
And being an open source controller, I saw it earlier and I can't find it in chat right now, but this doesn't have to be an EKS cluster, right? What does that mean for if you're self-managing a cluster or running something else, clusters that need to talk to each other? How does that work? Could I do it with an on-prem EKS Anywhere cluster?
Exactly. It doesn't need to be EKS. It doesn't need to be even Kubernetes. And that's the interesting part because the common denominator here is CloudMap. So anything that's registered in CloudMap can be theoretically import it, and we will work more on those use cases because we haven't tested, but it's definitely doable. So if I have my ECS cluster and EKS cluster alongside, they could also talk to each other because ECS integration is already can already register endpoints to CloudMap by design, by default. So anything that's in CloudMap already can be imported to EKS as well, or even on-prem.
So I have EC2 instances that are running Nginx. I expose those into CloudMap, and I can import those into Kubernetes as a service.
Exactly. And that's some scenario we need to define more, because probably it needs to be configurable. Like what needs to be, it shouldn't be automatic, like in this case as I presented.
That's cool.
I like the design of using a controller for this and a CRD, and especially leveraging the upstream KEP, to define that, right? I think this is a perfect example of not to wax too poetic, but a perfect example of using like the scalability and native AWS service that's right there to use. It's fairly affordable to use, especially depending on your application. It can be very affordable. And then, leaning into this controller design where it just makes using it in a Kubernetes environment that much simpler. It also works with EC2, it works with ECS. So it's sort of like if you already have resource, if you already have compute environments in AWS, it just makes even more sense. So, and the other thing that caught my eye here is as you said, it sort of gives an implementation to this KEP upstream, to this idea that we should have these. You've actually built, an example of one. So I think this is great. So what are the plans for this? I mean, you'd said it's pretty early, like real early, right? So you're sharing this really early just to get people's feedback and to sort of engage with folks to see if they're going to use it. What are the plans from here?
So for sure, it is to implement remaining parts in this controller, and there is also scale testing planned, because now we just prototype. It works with single service. I'm not so sure it would work with thousands of services. So that's a plan.
Jeremy, this is where you get to say now accepting PRs, right? You can say that.
Exactly. Feel free to check the repo. And there are already open issues, and we already got few PRs in
awesome.
Just a single day after we published that. So yeah, feel free to check that and feel free to open issues.
That's great.
Yeah, great. Do we have any other questions that we wanted to get to?
I'm not seeing anything specific.
Yeah, Theo's been in there answering a lot. I think, a lot of people sort of went to this sort of like, well, service mesh and load balancers and where is this? And I think this solution speaks to, or the need for this KEP actually speaks to how there's a lot of people with the complexity of a service mesh where they really just need this one aspect, right? So that's another way of looking at this, is it frames a different solution for a problem that we've been solving with different tools. So yeah, I think this is really interesting, and I'm looking forward to seeing where it goes.
Yeah, I think it'll be useful for a lot of people. So, and the chat has agreed. So looking forward to it. Our next session, Jesse, I think I'm going to take a quick break, and we're going to bring in a couple people to talk about OpenTelemetry. So Jaromir, thanks for joining us.
Thank you. Thanks for having me.
Yeah, we'll see you around. And let's pull in Aulita and Eric, I think are the two.
Yep.
Sweet.
There's Eric and Alalita.
Oh,
hello.
no, green screen.
Oh no, you disappeared. You're back. All right, Justin's going to take a break. Thanks, Justin, for everything. And we're going to hang out and talk about OpenTelemetry, which is super exciting. I have been following this project since people were initially talking about it, and we are super involved. Alalita's team has been doing a lot of work in this space, so we want to give you this full half-hour session to talk about it, get people excited about it, see if we have some questions. First off, why don't you introduce yourselves? Alalita?
Yeah, hi everyone. This is Alalita Sharma, and I'm a principal technologist focused on open source observability. I work closely with the container teams, and we have been deeply involved in a lot of the key projects upstream on including OpenTelemetry, which we're going to deep dive into what we've been doing on it. And then also talk a bit about Prometheus, Cortex, Grafana, and other open source projects, FluentBit, that we've been involved with. And again, feel free to ask questions in the chat as we go through a really cool demo of the integration with EKS, where we are pulling in a lot of the metrics and traces for you to be able to observe your applications and understand the behavior. That said, Eric, would you like to introduce yourself very quickly, and then we can get started?
Yeah. Hi, everyone. My name is Eric Xue. I am a software engineer on the ADOT team working under Alita, and I've been working for just a little bit over a month now, but I also happened to intern under Alita last summer. So glad to be back, glad to be working on OpenTelemetry, and excited to show you guys this demo that we have coming up.
Cool. So what I'll do is I'll just share my screen and get started with our talks. I'm going to cover a bit about what we are doing at a high level, and let's see.
Oh, Ellie, you're going to share your screen? Yes. Okay. So Eric will unshare yours for a second. Yes. No problem.
Sorry about that.
All right. Cool. I'm going to share my window, and hopefully you can see it.
There you go.
All right.
Yes, we can.
Okay. So again, wanting to kind of dive into all the cool things you're doing with observability in OpenTelemetry. And for those of you who are not very familiar with the field but are interested in learning about it, monitoring on for applications and services has been around for a long time, and systems especially. You remember the days of Unix monitoring, where we did a lot with Nagios and other tools. And so fast forward into the cloud computing world, we look at monitoring and observability at a larger, in a larger way, because what we are doing is that observability is enabling you to understand the overall behavior of a system, right? It's not only your application, but it's also the infrastructure, it's also the containers you're working with, it's the clusters you're working with, and the network stack, the OS, everything, right? And observability enables you to track the dynamic states of the system, taking into account uncertainty and variation in behavior, and really understanding a better, ongoing view of what's happening overall in the system, and how can you actually leverage that information well to be able to provision your systems better, to be able to optimize performance and other aspects. So especially in the container space, observability in Kubernetes is something we are going to be diving into today. And Kubernetes developers, as many of you may be already, need to understand the telemetry data they're getting from their applications, as well as from the infrastructure, get a better understanding of the code that you're running during runtime, and really, gathering more data enhances you to be more effective, right? It's common sense. But that said, again, there are specific types of data that we collect from the infrastructure as well as applications, such as metrics, logs, and traces, which are the three pillars, if you will, of observability data to be able to monitor applications and infrastructure, right? So OpenTelemetry is a great solution for observability in Kubernetes. It's used very commonly with not only with Kubernetes clusters to monitor and observe them, but also with your applications and with Prometheus metrics, StatsD, FluentBit, different types of data flowing into OpenTelemetry as a collection agent. So for those of you who don't know a lot about OpenTelemetry, it's actually the second most popular project in the Linux Foundation CNCF world. What it does is the project provides an open source collector agent, 11 language libraries, and a data protocol which is the OpenTelemetry protocol for providing a standard specification to unify monitoring, managing, and debugging of applications and services. And that's super interesting because, here you're seeing, an open source project not only providing software components, but also actually providing a standard which is aligned again with W3C's distributed tracing spec and other standards, and unifying that as an industry standard to be able to interoperate across different platforms as well as different components that are being used to monitor the behavior of your applications. So OpenTelemetry, has a lot of promise that it brings to users. And it really has, been able to grab the mind share of a lot of different end users, customers, developers who are using it and building it as one collection agent to support all types of telemetry data, providing interoperability using a standard protocol, the OpenTelemetry data protocol, the choice of being able to access different sources, whether that's, compute services or whether that's compute platforms like EC2, and also being able to, instrument your applications to be able to monitor them and then send that data to the monitoring framework that you use as a destination. So the great power of OpenTelemetry is that you can instrument once and be able to deploy everywhere, right? You can use the single collection agent to be able to talk to your applications as well as to your infrastructure and be able to pull all that telemetry data and be able to, observe it on the back end of it. It's vendor neutral, it's open source, and a lot of users are looking at it and evaluating and using it in production. AWS, as we got involved 2 years ago, has been committed to the success of OpenTelemetry. And I'd like to talk a little bit about, what we are doing before we dive into the demos. So let me introduce, AWS distro for OpenTelemetry, which is a secure production-ready, AWS-supported open source distribution of the OpenTelemetry project. And why this is interesting is because as a project, we have actually been contributing source code, contributing, improvements and changes on the project upstream 100%. And that's fundamentally a great, win-win, because I really look at it as, the source code being developed as a community in general with the industry, with different stakeholders, really building out the best solution and a really, really robust collection agent. And at the same time, being able to provide strong AWS guarantees downstream in a distribution, which is security reviewed, which is performance tested, production ready for large scale usage, and also being able to take a distribution and bundle that with what customers need and can easily integrate and talk to any of the AWS observability services too. So ADOT provides users the ability to instrument your applications to collect observability data. And of course, collecting metrics, logs, and traces on EKS, for EKS on EC2, for ECS itself, for EC2 if you're running self-managed, clusters, AWS Fargate with ECS and EKS, AWS Lambda, and on-prem, right? So you have such a variety of choices to be able to really use any kind of compute and at the same time run your applications and be able to just instrument them out of the box, collect metrics, traces, logs, and be able to send it. And AWS distro really, it makes it easier for you to be able to do that. I just want to highlight, some of the areas that we've been really excited to work on the OpenTelemetry project on. Super excited to be one of, some of the, having made a lot of cool contributions and adding a lot of really useful functionality for end users, and contributing to not only making core components on the project very stable, such as, again, reinforcing and making the collector core features stable, redesigning the metrics processor, converting some of the open census hooks that have been inherited in OpenTelemetry to the OpenTelemetry protocol natively, improving the release tooling of the project, adding to the configuration options that you can have, and the diversity of that on the CLI, ensuring that the Prometheus interoperability for the project is a first-class citizen, and enabling those changes to be built into the collector core as well as all parts of the SDKs, enhancing metrics support in the language libraries, as well as enabling the full compliance for the Prometheus remote write exporter, which is used for backends such as the managed service for Prometheus we have, and any other kind of distributed managed service that may be used in the Prometheus world. Similarly, enhancing stateful set support for being able to actually scale the collector and be able to use it in a Kubernetes environment, whether that's self-managed or whether that's a managed service. Adding tracing support not only for X-ray, but also for all the computes, centralized sampling. So you can see we've been doing a lot, and also participating in driving some of the key initiatives around eBPF profiling, and collection of eBPF data, RUM, which is real user monitoring. So this is super interesting because here you're seeing like an intersection with IoT and mobile end user devices, being able to collect that data also with OpenTelemetry. And here it's not only server side or service side, but also client side data that's being collected. Similarly, actually improving the instrumentation of OpenTelemetry, making it much easier to use and instrument and run with for end users, as well as sampling. So just wanted to kind of give you an overview of all the areas we're involved in. Obviously, we love to work on the project and are looking forward to doing a lot more. Just very briefly, before we dive into our super cool demo that Eric will be doing, what's next in OpenTelemetry? As many of you who may be following the project know that one of the key goals that the project has had over the last year has been to deliver metric stability and to deliver trace stability. So tracing was the first signal that the project stabilized, which means that the specification, the protocol, the API, the SDK, the collector, these are all stable for using tracing end to end. And you should be able to collect traces, from an application and easily pipe it to any monitoring backend of your choice. And similarly, now we are focused on metrics, right? So metric stability is the next big milestone. And here you can see there are several milestones I've outlined, which are being worked on actively right now. And we intend to complete stability requirements by the end of this year. You can see that Prometheus interoperability is a very key milestone for us on the project, enabling and ensuring that there's full interoperability for customers. They can use, if they're already using Prometheus data, then they should be able to easily collect that with OpenTelemetry and be able to reuse it. Similarly, making sure that the metrics APIs and SDKs are stable. These are the first 5 languages that are targeted by the project. So, expect to see rolling releases for these as in the next few weeks. And also, building out auto instrumentation, which means that instrumentation today is available in Java, and also building that out for JavaScript, Python, .NET, Go. So really, you can see stepwise stability moving into not only the protocol and data model, but also in the API SDKs as well as the collector. And then last but not least, after that, we're going to be tackling logs as the next signal for stability. And a lot is happening around logs. So the spec, OTLP, API, and SDK, a lot, right? So that said, I think that was kind of where I wanted to stop and switch over.
I'm gonna
to
stop.
demo.
I'm gonna stop you for a second.
All right.
I just want to point out, like you just powered through it, and it was just so good. It was very complete, but I feel like you were so smooth. We could easily miss the impact of everything you're talking about here. 3 years ago, we were all chasing different solutions, and trust me, I love some of those solutions. We were chasing something for tracing, something for metrics, something for logs. Sometimes people were doing different things. You got the Zipkins, you got the Jaegers, and all of that stuff was good. And you bash script and duct taped it together, and you made it work, and it was great. In 2 years, we got into a place where there's this open source, agnostic standard, which comes with this open source project, which provides multiple languages of libraries. And we're there from the beginning, or from the last couple of years.
Yes.
We now have this distribution, which makes it easy for our customers to pick it up and just use it.
Totally.
And you've done all this work to make it just work on AWS seamlessly, but it doesn't have to work on AWS. It can work anywhere.
Yes.
Like that's basically, that's just awesome. And it might be the end of a 7-hour day for me, or I might just really be thrilled. I don't know, but I'm so excited about that. And I've been playing with it. Of course, I've been working with it, but I want people to understand, like, it's such a huge impact for the community. I think it's one of these projects that's just again, I'm waxing poetic, the beauty of open source, right? Where multiple people get together and say, we have to solve this problem. Let's get in a room and solve this problem. And you're actively solving the problem. I love it.
Yes. And
okay.
it's the really wonderful thing is that we've all worked together, as not only collaborators in the community, but really some of the best, engineering minds coming together, solving solutions, putting together solutions at scale, solving some of those challenges, and it's all open source, which really is a win-win for all users, right? So it's really an exciting project to be involved in.
That's great. All right, so I interrupted your segue to demo. I'll be quiet now because I want to see it too.
Yeah, absolutely. And this is a super cool demo. Again, this is all available, in the OpenTelemetry repositories already. We are going to talk about, how you can monitor and observe your EKS infrastructure and applications with using OpenTelemetry, specifically the OpenTelemetry collector, as well as with a Helm chart and an operator which we have enhanced so that you can just configure and run with it. And Eric's gonna dive into walking through some of the architecture that we have. Eric, did you want to go through the slides first?
Yeah, Jesse, if you could actually switch back to the slides. I just have a couple that I want to walk through real quick before we get into the actual demo.
Okay.
Thank you for that. So before we get into the actual demo, there's a couple components I want to talk about regarding the demo. And the first is the operator that Alita mentioned. And so what the OpenTelemetry operator is a implementation of a Kubernetes operator. And what a Kubernetes operator is a method of packaging, deploying, and managing a Kubernetes native application. And it also introduces new object types through custom resource definitions, or CRDs for short. And so in our case, the CRD is the OpenTelemetry collector. And so you can kind of think of the operator as a controller for our collector here. And for a quick breakdown on the workflow that this diagram is showing, we can see in the middle that the operator is essentially watching for the collector. It's aware of its existence. And whenever a user wants to create or update or delete a collector, the Kubernetes API server will notify the operator. And what the operator does is it first ensures that the required connections are available. And then after that, it will configure the collector in the way that the user describes. Next slide, please. And then I'll briefly talk about Helm and what Helm is. So like what Homebrew is for Macs, Helm is for Kubernetes. That is that Helm is the package manager for Kubernetes. And for the context of our demo, we're going to be using our OpenTelemetry operator Helm chart. And it's pretty straightforward to use. When a user wants to use our operator, they would tell Helm, hey, I want to download this Helm chart and deploy it in my cluster. And then Helm will take care of the rest. So it's pretty straightforward, pretty simple, and I'll show you what that looks like later on. Next slide, please. And then lastly, before we get into the demo, there is the end-to-end data path that I like to talk about a little. So I'll just describe it in short detail. So first, you're going to want to install your OpenTelemetry operator through Helm. After the operator is ready, we want to configure our collector. And here, when we're configuring the collector, just to note that there are 4 different modes to deploy the collector in. There is a deployment, daemon set, stateful set, and a sidecar mode. And I'm not going to get too deep into the advantages of each, but just note that each mode does have its advantages and their best use case. For our demo, we'll be using the deployment mode, and this just gives us a little more control over the collector itself. And finally, the collector will scrape the traces or metrics based on our configuration, and it will ingest these traces or metrics and export them to whichever service you choose to. So in our case, we'll be exporting to our Managed Prometheus service, or AMP for short, and we'll also be exporting to CloudWatch and X-Ray. Next slide, please. And then to get into the demo itself, there's a bit of setup we need to do. I've already gone ahead and done some of it just because, in the interest of time. So for setup, of course, you need an EKS cluster. And you also need to set up your AMP and AMG, AMG being our Managed Grafana service. We need to set up those workspaces. And then we also need to install a cert manager. And what the cert manager is a certificate manager that the Kubernetes API server needs to communicate with the webhook component. And the webhook requires a TLS certificate that the API server is configured to trust. And this is also pretty straightforward. Again, I'll show you this later on in the demo. Lastly, we're going to need to install the OTel operator Helm chart and the OpenTelemetry collector, like I previously mentioned. Quick note about the collector itself. The way it talks to our services is through a SIG-v4 process. And what this process is the process of adding authentication info to our AWS API requests that are sent by HTTP. And to do this, we'll need our access key ID and secret access keys. And again, later on in the demo, I'll show you where exactly this comes into play. And then lastly, not to get too repetitive, but just going over the data path again. So we have our metrics and traces that we are generating. Our metrics and traces that we're generating. I'll be using a traffic generator and a sample application to do this. And then we'll send those traces and metrics to our collector, which is controlled by our operator. And then finally, we'll export the metrics and X-ray metrics and traces to AMP, CloudWatch, and X-Ray. And so if we could switch screens now, thank you. So first, we're going to want to make sure we have our cluster. So I've gone ahead and done this already, but we can check that to make sure that we are in the right cluster.
Yeah, and just to address some of the questions that folks have, just to make sure everything, as Jesse said, is open source and available on the OpenTelemetry project. It can also be, all these components can also generically be used by in any Kubernetes environment. You can run your own cluster, you can have it self-managed, as well as, it is not a AWS solution specifically. It's actually a generic solution that you can use.
And Eric, just while we have a second, can you make your font a little bigger? I can read it, but just a little bigger. Yeah, that's great. Thank you so much.
Yeah, great.
Of course.
That's awesome.
Right. Okay, cool. So yeah, we're in our current cluster, and then we're going to want to install our cert manager. It'll look something just as simple as applying a configuration file. I've already gone ahead and done this, so we don't need to actually run it, but this is what it'll look like. And then we can also check just to make sure that everything's up and running. We can run this. And you'll see that we have our controller, our injector, and our webhook that are up and running. And then next, we're going to want to install our operator through our Helm chart. And so first, we're going to want to add the repo in through this command. And you can see that I've already done this. And we just want to update it just to make sure we have the most recent version. And then after that, we're going to want to actually install the operator itself. Okay, great. And then next, I'm just going to check that. Oops. Okay, I'm just going to check that my traffic generator and sample app are up and running. Important things to note here are that really all that's important here is that the sample app is configured to send its metrics and traces to an endpoint that the collector is configured to listen on. And moving over to the configurations for the collector specifically, I realize we're a little short on time, so I'll try to get through this with all the pertinent information. But you can see in this config section, we have our exporter, our receivers, processors, and exporters listed. Here we have our OTLP receiver that's listening on this endpoint that our sample app is configured to send metrics and traces to. We don't have any processors for our data currently. And for exporters, we have three different kinds. We have our remote write exporter, our X-ray exporter, and our EMF exporter. The first one being for AMP. And this endpoint is of note as this is the endpoint of our Prometheus workspace. So this is needed for our collector to send our metrics over. And then EMF is our CloudWatch exporter, just for clarification. And then there's also the service section here where we configure our pipelines and just detail them out. So you can see we have our traces pipeline and our metrics pipeline listed out here. Lastly, you might need to specify an image. Here we're using the collector contrib image instead of the collector core image because we are using some of the contrib components like the 3 different exporters I mentioned. And then lastly, touching back on the SigV4 authentication that I was talking about earlier, to get your access key ID and secret access keys configured, one way you can do that is through environment variables, and this is what it might look like. I currently don't have mine, obviously, but I will be using them for the actual collector itself. So let's apply the collector. It's up and running. And then let's hop into Prometheus real quick. So here we have the Prometheus workspace. You can see this remote write URL is the same as the one in the collector config. We also have our AMG workspace set up. Things to note here is that we need to enable our single sign-on so you can sign into the Grafana console. And we also have our data sources, which are attached. So we have AMP, CloudWatch, and X-ray attached. For now, we're only going to focus on AMP though. And then if we just move over to our console, we can check our data sources. We'll just add AMP for now. Select our region, and then select the right data source. And so you can see it's been added, and then we can go over to our dashboard, create a new panel. This has been happening for some reason. I don't know why, but refreshing always works. And then here we can just query for different metrics. So say, for example, we can select queue size, outgoing HTTP call, and then in the last, okay, well, That is interesting. For some reason, it's not working right now, but as you can see, oh, it looks like it did show up. Here we go. So you can see that our metrics are being ingested and shown in AMP. Currently, there's not much going on because I just started it, but that's what it should look like. And you can also see in CloudWatch, I made a quick little dashboard to show some of the metrics. This is also interesting that it's not showing up yet. But it should show up in CloudWatch, and traces should also be showing up in X-Ray as well. So you can see here, there's a list of traces that are showing up, and this is where they're coming from in the URL section. But that should be it for the demo. I think we'll hold off on questions. I'm not sure if we have time, but I'll pass it back off to Alita to close
Eric,
out.
if you go into the CloudWatch dashboard, is it continuing to collect, or is it?
Yeah, it should be. I'm not sure what happened.
Okay, it's just running in the background.
Yeah, it is. I did this, like 30 minutes ago, and I wasn't having issues. So it's very, very interesting.
So what did you, but after that, what did you do to appease the demo gods? Like, did you do anything in particular?
I don't know. The demo gods are always, they're always praying for my downfall, it looks like. So yeah, this has happened to me a couple of times, unfortunately, but for the most part, things are looking okay. Oh, here we go. See?
There we go.
Now things want to show up. You gotta give it a little time.
We did assume it worked. You did, you did great.
Yeah.
Little JavaScript between friends. That's fine. That's great. And I think the power here is that this is a unified spec eventually for stability for all three signals, across all these different languages, where we just don't have to chase all these different solutions anymore. And this is fantastic. And we can look here. We're sort of out of time, but we can look here and see if there's and Elalita, did you have anything to wrap up?
Yeah, I just wanted to I just had one slide to thank you. Again, point folks to some links for some of the active, workshops that you could use. And these are really good workshops that we have built around, sample applications and really being able to, walk through an end-to-end pipeline. So please take a, screenshot of this, go try it out. Everything is open source. Everything can be run on-prem, self-managed, as well as, with AWS services. So there is no, it's fully interoperable. That's something that as an open source engineer, we all care about, making sure that every component that we're building is completely used open source, right? So again, please take a snapshot, go try these out. You can find me on Slack. Also, on the CNCF Slack, feel free to ping me if you have any questions. And all of us work very actively on different open source projects. So keep in touch and also participate in more open source. But over to you, Jesse.
Yeah, thank you so much. That was fantastic, and it was a great session for us to end with. I think we're going to have a quick wrap up, and to sort of say thank you to everybody at the end of the day here. But thank you so much for this session. Really appreciate it, Eric and Alalita. Thanks for your time.
Thank you so much. Really nice to participate. Bye, guys. Bye, folks.
Bye.
Thank you, guys.
We're right back.
This is it. That was it. That was wonderful. Thank you, everyone who watched today. Great participation in chat. Loved it. I hope you learned something and also loved the sessions. I want to throw 3 more links at people just because it's a link-filled day. So first of all, if you are learning EKS or Kubernetes, check out eksworkshop.com. We have a lot of workshop guides. You can get started. You can spin up a cluster. Hopefully some of this stuff made sense if you haven't been learning Kubernetes, but if you wanted to learn more, go check that out. The second one I wanted to throw out is if you liked some of the content on this show, we also do this regularly, not just on Container Day. So we have Containers from the Couch on YouTube, which is where we mainly get alerts if you want to watch the stream. We do regular demos for all of this content. A lot of the speakers you saw here today are also come on. We do regular repeats or updates for all of these projects to help you use them. Almost every single one of these Containers from the Couch shows, the regulars shows, will have demo content where we love to get hands-on and hopefully give you like a GitHub repo you can run through it yourself. So subscribe there, join if you want to participate. And the last piece that I had somewhere in here, oh man, so many good comments now, was I also want to say, if you have time, fill a survey. We listen to the surveys for all of the slides, all of the content. Literally, like it's not just like I will see some anonymized information from these slides to know, or from the survey to know like how you liked it. So I would love to hear what you were thinking and what resonated with you. If you are at KubeCon, I'm here in LA. Come find me, please. Jesse, I think you might be hanging out in the hallway chat for KubeCon.
I'm hanging out in my hallway. Yeah. I'll be in Slack. I'll be at the virtual conference. I'll be around, and you can find us both on Twitter. If you can't find us in any particular place, you can always find us there, as well as most of our team. Yeah, just reach out anytime, and this is what we're here for. This type of event is sort of like a little bit of an anchor for us, but every time, the conversations keep going. We love when you ping us, and if we can help with anything, let us know. I want to just take a moment and thank our interpreters. You did such a great job today. We know it's your career, so I'm not saying all that, but it was great, and we thank you so much. We had a lot of great comments indicating that it was very helpful. Thank you.
My arms are tired just with how much I use my hands. I can't imagine the communication with my hands. That is some endurance.
Well, so my voice is going, so I think your arms must be pretty tired. So yeah, that's great. Thank you so much. And thanks to all the speakers. Thanks to everyone. And enjoy your KubeCon.
Yeah, it's been great. Thanks. Bye.